The Character of Consciousness. David J Chalmers. Introduction. What is consciousness? How can it be explained? Can there be a science of consciousness? What is the neural basis of consciousness? What is the place of consciousness in nature? Is consciousness physical or non-physical? How do we know about consciousness? How do we think about consciousness? What are the contents of consciousness? How does consciousness relate to the external world? What is the unity of consciousness? We can think of these questions as limbing a few dimensions of the character of consciousness. Consciousness is an extraordinary and multifaceted phenomenon whose character can be approached from many different directions. It has a phenomenological and a neurobiological character. It has a metaphysical and an epistemological character. It has a perceptual and a cognitive character. It has a unified and a differentiated character. And it has many further sorts of character. We will not understand consciousness by studying its character on just one of these dimensions. Studying the phenomenology or the neurobiology of consciousness alone may tell us a great deal, as might studying the metaphysics or the epistemology. The perceptual and cognitive aspects of consciousness pose huge challenges in their own right. But ultimately we must approach consciousness from all of these directions. In this book, I address all of these issues about the character of consciousness and a number of others. It is not the last word, or even my last word, on any of them. There are many aspects of the character of consciousness that it does not address at all. Still, I hope that it provides a unified picture of many aspects of consciousness that repays attention. The chapters of this book were first written as separate articles, so one might think that the book is bound to be fragmented. I have tried to structure and rework it in such a way that it works as a whole, however. Later chapters build on ideas put forward in earlier chapters, and there are many common themes throughout. In principle, one could read the book from start to finish as if following a narrative thread. The book is long enough that perhaps this is too much to expect, but there are also many subbooks within it, some of which I will explain. I have added afterwards to some of the chapters, as well as new footnotes, marked with an asterisk. I have shifted some of the material and cut out the more blatant acts of repetition, although occasional repetition has survived, in part to assist readers who may not be reading straight through. The book is structured as follows. Chapter 1 introduces the problems of consciousness in an accessible way. Chapters 2-4 address the science of consciousness by developing a positive picture of how the science works in light of the problems. Chapters 5-7 address the metaphysics of consciousness, arguing in detail against materialist views and for a view on which consciousness is irreducible. Chapters 8-10 address thought about consciousness and the epistemology of consciousness, developing an account of the concepts we use to think about consciousness and the distinctive knowledge that we have of consciousness. Chapters 11-13 address perceptual consciousness and the way it represents the external world. Chapter 14 addresses the unity of consciousness. The appendix gives an outline of the two-dimensional framework that plays a central role in a number of the more technical chapters. Although the book contains some technical material, it also contains much that is intended to be highly accessible. Chapters 1, 4 and 13 were written with a general audience in mind, and chapters 5 and 14 should be accessible to a reasonably broad audience. Chapters 6-12 are more technical and are likely to appeal mainly to philosophers or to those who are willing to work hard. To someone without much background in philosophy, I suggest skipping these chapters on a first reading. If pressed for time, start with chapters 1, 2, and 13, which have perhaps the broadest appeal. Likewise, for those especially interested in the science of consciousness, chapters 1-4 are the places to start, with perhaps some material of interest in chapters 13 and 14. There are also many paths through the book for philosophers. Those especially interested in the mind-body problem might focus on chapters 1, 5, 7, and 10, with some relevant material in 2, 8, and 9. Those interested in issues about language, content, and concepts might focus on chapters 6, 8, and 11, 13, as well as the appendix. Those interested in epistemology might focus first on chapters 9 and 13, with relevant material also in 2, 4, 6, and 7. Those interested in phenomenology might find material of interest in chapters 11, 12, and 14. I urge philosophers not to skip chapter 13. The topic might seem frivolous, but the philosophical issues go as deep as in any chapter in the book. This book could be considered a sort of sequel to my earlier book on consciousness, The Conscious Mind, TCM. That book received far more attention than I could reasonably have expected, for which I am enormously grateful. At the same time, it is very far from a perfect work. Most of it was written as my PhD dissertation after 4 years of studying philosophy, and there is much about it that I would change if I were writing it now. There are also many relevant issues that it simply does not address. I would like to think that in subsequent years, I have come to understand a number of important issues better than I did then. In this book, I aim to flesh out a picture of consciousness that is clearer, fuller, and more adequate than the picture in the conscious mind. The picture in this book is largely consistent with the picture in the conscious mind. I have not had an enormous change of mind since then, though there are some medium-sized changes. For example, I am somewhat less sympathetic to epiphenomenalism than I was then and somewhat more sympathetic to drawing close connections between consciousness and intentionality. A few chapters present arguments along the same lines as those in that book. In particular, chapters 1 and 5-7 cover the same sort of ground as the early chapters of TCM, in what I hope is a better fashion. In some of those chapters I have also responded to various critics of TCM. The chapters in sections 2 and 4 address issues regarding the science of consciousness and concepts of consciousness that are touched on far too briefly in TCM, while sections V and 6 move in new directions that are not explored at all there. Those who want to explore entirely different issues could start here. I have not presupposed any knowledge of the earlier book. This book can stand alone. One regret concerning the conscious mind is that the book has become known especially for a negative thesis, the thesis that consciousness is not physical. Perhaps this was to be expected, but my central goal in studying consciousness has always been positive rather than negative. I would like to find a theory of consciousness that works. Negative arguments are just a step on the way. So while this book contains its share of negative arguments, mainly in section 3 and to some extent in chapters 1 and 10, I have tried to put more focus on the positive. Chapters 2-4 outline a positive picture of how the science of consciousness can proceed, and is proceeding, even once the distinctive problems of consciousness are fully recognized. The second halves of chapters 1 and 5 sketch speculative positive pictures of the metaphysics of consciousness. Chapters 8 and 9 try to tell a positive story about phenomenal concepts and the epistemology of consciousness, and the chapters in sections V and 6 develop a positive picture of perceptual consciousness, its relation to the external world, and the unity of consciousness. It is worth noting that many elements of this positive picture can be accepted by those who are not convinced by the negative arguments. Apart from chapters 1, 4, 6, and 10, most of this book is quite compatible with various sorts of materialism. At the same time, there is at least a non-reductive spirit to many aspects of the picture. One might think of the book as a whole as an attempt to articulate a reasonably unified, broadly non-reductive vision of the character of consciousness. In the remainder of this introduction I introduce each of the chapters in more detail, sketching some context and some informal background. I have permitted myself a few more personal remarks than elsewhere in the book. Readers can read this material or not as they like. The material can also be read before or after reading the chapters themselves. Chapter 1 introduces the distinction between the hard problem and the easy problems of consciousness. The easy problems are those of explaining cognitive and behavioral functions such as discrimination, integration, and verbal report. The hard problem is that of explaining conscious experience. Where the easy problems are concerned, it suffices to explain how a function is performed, and to do this it suffices to specify an appropriate neural or computational mechanism. But where the hard problem is concerned, explaining cognitive and behavioral functions always leaves a further open question: why is the performance of these functions accompanied by experience? Because of this, the standard reductive methods of neuroscience and cognitive science that work for the easy problems do not work for the hard problem. I argue that this problem applies to any reductive explanation. In principle, these can explain only structure and function, and explaining conscious experience requires more than explaining structure and function. If this is right, there can be no wholly reductive explanation of consciousness. I go on to sketch an alternative non-reductive approach in which consciousness is taken as fundamental, and I sketch the outlines of a speculative theory of that sort. I first presented this material in a talk at the first Tucson Conference on the Science of Consciousness in April 1994. Although there is nothing especially original about the idea that consciousness poses a hard problem, I was in the right place at the right time. At the conference, the talk received an overwhelming and entirely unexpected reaction. Shortly afterward, I was invited to write up versions of this material for both Scientific American and the Journal of Consciousness Studies. The latter journal published 4 special issues containing a keynote article by me, around 25 responses, and a response by me in turn, all of which were later collected into the 1997 book titled Explaining Consciousness, The Hard Problem, edited by Jonathan Shear. The chapter here is a version of the original article in that journal. As an afterword to Chapter 1, I have also included an excerpt from my lengthy reply to the responses, moving forward on the problem of consciousness. That article is too long to include here in full. It is available online, and much of it covers ground that is covered elsewhere in this book. But I have included a response to Daniel Dennett, both here and in the afterword to Chapter 2, as his brand of highly deflationary materialism, the Type A materialism of Chapter 5, is not discussed at length elsewhere in the book. I know that the debate between the deflationary and inflationary views of consciousness is of interest to readers both inside and outside philosophy, where the argument between the likes of Dennett and the likes of me is sometimes cast as an ideological battle. I learned long ago that I am not much of an ideological crusader. I do not believe that the world will be a hugely better place if everyone accepts my views, and I am only occasionally inclined to rhetorical extremes. Still, I think that one has a responsibility to the views that one has put forward, and the back and forth can at least shed some light on the underlying issues. So I have done my best to indicate how I see the core issues here. I am fond of the original article on the hard problem in part because it makes the case against reductive theories of consciousness without any technicalities or far-out philosophical thought experiments. I have no objection to technicalities and thought experiments, which play a central role in the arguments of the conscious mind, but I think that the argument here is just as effective. There is a sense in which the argument here, which turns on simple issues about explanation, is more fundamental than conceivability arguments involving zombies, epistemological arguments involving Mary in her black and white room, and the like. And certainly it works better for an audience outside philosophy. It is sometimes supposed that non-reductive arguments turn essentially on these thought experiments, but this is just wrong. In fact, in Chapter 5 and elsewhere, I suggest that the thought experiments turn essentially on points about structure and function that are close to the central points in this chapter. I see the thought experiments as a useful technical device for making the arguments more formal and more analyzable, as well as more vivid, and as a result they have produced much interesting and useful philosophical literature. Still, many of the common responses to those thought experiments have no clear application as a response to the simple arguments here. The phenomenal concept strategy discussed in Chapter 10 is an exception, among others. Although the material in this chapter has been very widely cited, I have seen many fewer serious replies to its line of argument than to the line in the conscious mind. I would certainly be interested to see more. 16 years after that first Tucson conference, the science of consciousness has gone from strength to strength. But the state of play in the science of consciousness with respect to the hard problem is very much as it was. Almost everyone in the field recognizes that there is a hard problem of consciousness that poses special challenges, Perhaps this is a sort of progress, although I think that most people recognized it all along. There have been many neurobiological and cognitive models of consciousness, but few of them have been offered as a solution to the hard problem, and when they have, hardly anyone has been convinced. Any associated claims about the hard problem are usually driven by bits of philosophy that are largely independent of the science and can be responded to straightforwardly. I have occasionally been invited to write critical reviews of this sort of work, but one bonus of the phraseology is that it generates a critique that writes itself. The work addresses the easy problems but not the hard problem, it provides a correlate of conscious experience but not an explanation, and so on. So I have not usually felt the need to go back over this ground. That being said, positive non-reductive theories of consciousness have not had a much easier time of it. The speculative theory outlined in the second half of this chapter has certainly not gained widespread acceptance, and even I am inclined to be skeptical about the more speculative parts of it, such as the double aspect theory of information. There have been a handful of attempts at non-reductive theories. The work of Stuart Hameroff and Greg Rosenberg comes to mind, but not many, and none has attained much support. Perhaps it is too early in the science for positive theories that address the hard problem in a substantial and successful way. Still, I think it is worth trying. In any case, the science of consciousness is thriving. Most of the work in the field does not try to solve the hard problem of consciousness but is none the worse for that. There are robust research programs in neurobiology, especially vision, but also emotion, bodily awareness, and other areas, psychology, especially conscious and unconscious processing in memory and learning, and the relationship between perception, attention, and consciousness, clinical neurology, especially on the vegetative state and other post-coma conditions, and other areas. These programs raise all sorts of fascinating philosophical issues, and in chapters 2-4 I address some of them. Chapter 2 gives an overview of the science of consciousness and presents a picture of how it can work even in the absence of a solution to the hard problem. The central role of the science, as I see it, is to provide a bridge between third-person data about brain and behavior and first-person data about consciousness, where it is data of the latter sort that make the science of consciousness truly distinctive. I suggest that the science is essentially correlative rather than reductive. At least, the central parts of the science make claims about correlation without making claims about reduction. Science of this sort can still have great explanatory power, however, by articulating powerful general principles that connect the first-person and third-person domains. The science of consciousness is not yet at the point of having that power, but if one squints, one can see the possibility of a framework of that sort in the distance. After discussing the role of much of the present work in the field, the chapter ends with discussion of some obstacles and of where the science might eventually go. I have tried to sketch a framework for the science that can be embraced by reductionists and non-reductionists alike. I have given talks corresponding to Chapter 2 at numerous conferences and other venues, including a memorable occasion at the Central Intelligence Agency in Virginia in 2000. The talk was advertised without my knowledge as Consciousness at the Millennium, the Mind-Machine Connection. I think the audience did not get what it was expecting, at least until I mentioned the consciousness meter. Dan Dennett was present on a couple of occasions and responded in a debate at Northwestern with a paper titled The Fantasy of First-Person Science. I have not responded to Dennett's paper in print anywhere, so I have added an afterword indicating the general lines of my response, as well as discussing some other central issues involving first-person data. Chapters 3 and 4 address what is arguably the centerpiece of the resurgence of the science of consciousness, the search for neural correlates of consciousness, especially of visual consciousness. Chapter 3 addresses conceptual issues about what it is to be a neural correlate of consciousness. The question might seem straightforward initially, but it generates all sorts of interesting puzzles. Must there be one neural correlate of consciousness, or might there be many? How strong a correlation is required? Over what range of cases? The chapter addresses these questions and a number of others and puts forward a proposal for understanding the notion of a neural correlate of consciousness in a way that does justice to the way the notion is used in the field. I use this analysis to draw some conclusions for the methodology of the search for neural correlates of consciousness. Chapter 4 focuses directly on the epistemology of the search. The key question is, how can we isolate the neural correlate of consciousness in the absence of a consciousness meter, which measures consciousness directly? The obvious answer is that we rely on verbal reports and other behavioral indicators of consciousness. Importantly, the use of these indicators tacitly relies on pre-experimental principles that connect these behavioral indicators to consciousness. The use of these principles is unavoidable, and it has a number of interesting consequences for the science. After drawing out some of the key principles, I once again draw some conclusions that bear directly on the practical methodology of the scientific work in this area. Of course, there are many important issues in the science of consciousness that I do not address in these chapters. There is much to be said about the science of unconscious processes, especially regarding the philosophical assumptions behind the principles used in this area to ascribe conscious and unconscious mental states to subjects. I have discussed that work in talks, example implicit philosophy in implicit cognition research, but not yet in print. Likewise, there are very interesting philosophical issues concerning how to monitor consciousness in apparently unresponsive patients, such as those diagnosed with vegetative state. I have recently started some collaborative work with neurologists and neurobiologists on this topic. The relationship between consciousness and attention also raises all sorts of interesting issues that I hope to address in future work. Chapters 5-7 focus on issues about materialism and dualism with regard to consciousness. The arguments of Chapter 1 make a case for a view in which consciousness is irreducible and non-physical, but much more needs to be said to flesh out these arguments, to answer objections, and to investigate the resulting views. Chapter 5 provides an overview of the territory. It starts by presenting the central arguments against materialism, which involve establishing an epistemic gap between the physical and the phenomenal, and moves from there to an ontological gap. It then distinguishes between the three most important sorts of materialist opposition to these arguments, what I call Type A materialism, which denies the epistemic gap, Type B materialism, which accepts the epistemic gap but denies the ontological gap, and Type C materialism, which holds that there is a deep epistemic gap but one that will be closed in the limit. I make the case, in reasonable detail but without technicality, that each of these three views should be rejected. In the second half of the chapter I investigate the most important non-reductive views that result, Type D dualism, or interactionism, Type E dualism, or epiphenomenalism, and Type F monism, Russellian monism, or panprotopsychism. I discuss the pros and cons of each, suggesting that all three have significant attractions and that none has fatal flaws. My own loyalties are fairly evenly spread among these three views, depending on the day of the week. I have often been told that I am an epiphenomenalist, based on the sympathetic discussion of epiphenomenalism in the conscious mind. Sometimes that is taken to be sufficient reason to reject the arguments of the book, as epiphenomenalism is widely regarded as crazy. But even in TCM I was just as sympathetic to Russellian monism, in both panpsychist and non-panpsychist variants, as to epiphenomenalism, and Russellian monism involves a causal role for consciousness. In addition, I now think that the criticisms of interactionism there were much too quick, for reasons discussed in the section on Type D dualism here, and that there are no decisive reasons for rejecting that view. In any case, the proper conclusion of the anti-materialist arguments is disjunctive. The choice among the three disjunct rests on further and largely independent considerations. As things stand, the choice is wide open. At the end of the day, the choice will come down to which of the disjunct yields the most successful detailed theory, in light of a well-developed science of consciousness. Chapter 6 is mainly devoted to the conceivability argument against materialism, viewed through the lens of the two-dimensional semantic framework. An argument of this sort was one of the centerpieces of the conscious mind and has attracted many replies. At the same time, the two-dimensional argument there was not as clearly formulated as it could have been. Here I have tried to give the argument a really clear formulation and to answer all of the central objections that have been raised against it. This chapter is unavoidably technical, but I would like to think that this is a case in which technicality has some rewards, not just in understanding issues about consciousness, but also in understanding the metaphysics and epistemology of modality. The key issue in this chapter is whether conceivability, of some sort, entails metaphysical possibility, of some sort. The key opponent is the type B materialist, who denies the entailment. Many objections and putative counterexamples to the conceivability possibility thesis have been mooted. The chapter discusses 15 or so putative counterexamples, along with 10 or so objections of other sorts to the conceivability argument. I think that on close examination there are straightforward replies to most of them. Some raise deeper issues, about the a priority of modal epistemology, for example, or about the connection between concepts, rationality, and modality. Late in the chapter I sketch a positive grounding for the sort of modal rationalism that drives the conceivability argument. In an afterword I bring the analysis to bear on some other central arguments against materialism, the knowledge argument, Kripke's modal argument, the property dualism argument, the argument from disembodiment, the semantic stability argument, arguing that the issues underlying each are closely related and that a two-dimensional analysis can shed useful light on each. Chapter 7, co-authored with Frank Jackson, addresses a related form of opposition to the anti-materialist arguments. Some type B materialists allow that a unique epistemic gap exists between physics and consciousness. Truths about consciousness are not deducible from physical truths, but truths about water, life, and other high-level phenomena are deducible from physical truths. Others argue that these epistemic gaps arise in many high-level domains. In a 1999 paper, Ned Block and Robert Stalnaker respond in the second way to arguments given by Jackson, by Joseph Levine, and by me, suggesting that truths about water, life, and heat are no more deducible from physical truths than are truths about consciousness. If so, the case of consciousness is nothing special, and unless one is prepared to accept that water is non-physical, one should reject the argument that consciousness is non-physical. In response, Jackson and I argue that there are in fact a priori entailments from a nearly physical base to truths about water, life, and so on. The base needs to be expanded a little to allow index equals, that's all truth, and of course truths about consciousness. But from this base, other ordinary macroscopic truths can be deduced by a priori reasoning. The argument here turns on some general observations about concepts and conceptual analysis. One of the key points is that there can be a priori entailments even in the absence of definitions or explicit analyses, contrary to what Block and Stalnaker appear to assume. The issues here are largely conceptual and epistemological, but we draw consequences for the explanatory gap regarding consciousness. Chapters 6 and 7 raise issues in metaphysics, epistemology, and the philosophy of language that go well beyond issues about consciousness. Much more needs to be said about these issues, and in recent work I have tried to say some of it. A forthcoming book is devoted to issues in the philosophy of language and content, arguing for a free gene approach to meaning and an internalist approach to mental content, grounded largely in the two-dimensional semantic framework that is central to Chapter 6. Another forthcoming book takes up some of the issues in Chapter 7 through the lens of the scrutability thesis, arguing that there is a limited class of truths from which all truths are deducible. I suggest that this scrutability thesis can be used to vindicate some, not all, of the aims of Rudolf Carnap and other logical empiricists, and that it has many interesting consequences in epistemology, the philosophy of language, metaphilosophy, and metaphysics. For me, these works grew out of seeds in work on consciousness and then took on a life of their own. This seems to me to be a sign of the fertility of issues about consciousness for thinking about philosophy more generally, although perhaps it is just a sign of the way that every issue in philosophy is connected to every other. Chapters 8 to 10 concern our thoughts and beliefs about consciousness, and the concepts we use to think about consciousness. These concepts are now known throughout philosophy as phenomenal concepts. Chapter 8 develops an account of the distinctive nature of phenomenal concepts, grounded in part in an analysis of the epistemological and conceptual observations that drive the arguments against materialism. I argue that phenomenal concepts behave in a way that is quite unlike most other concepts, involving a very strong sort of direct reference, on which the phenomenal qualities that are the referents of the concepts are also somehow present inside their sense. Here, the two-dimensional framework is again a useful tool in analyzing the phenomenon. The account in this chapter is in principle compatible with materialism, and in recent years some materialists have developed closely related accounts, but I think the account itself is fairly neutral, perhaps ultimately with some support for dualism, for reasons given toward the end of chapter 10. In any case, the issues concerning concepts and belief are of much interest in their own right. Chapter 9 concerns our knowledge of consciousness. It was originally the second half of a long paper also containing chapter 8, and it builds on the central idea of that chapter. The special phenomenal concepts of chapter 8 lead to a distinctive class of direct phenomenal beliefs, which I argue have many interesting epistemological properties. For a start, they support a sort of infallibility thesis: direct phenomenal beliefs cannot be false. This thesis can do only limited epistemological work, but analysis of these beliefs leads to a more substantial epistemological view that involves a central role for acquaintance. I use the framework to analyze two important issues in the epistemology of consciousness: epistemological arguments against non-reductive views of consciousness, as well as Wilfrid Sellers's arguments against the given. I suggest that with the appropriate analysis in hand, both sorts of arguments can be defanged. Among other things, I think that this analysis provides a better response to the paradox of phenomenal judgment than I gave in the conscious mind. These chapters are explicitly concerned just with beliefs about consciousness, but much of the material here has application to a much broader class of beliefs. For example, I think that some perceptual beliefs are closely related to direct phenomenal beliefs, such that consciousness plays a central role in their constitution. Moreover, these consciousness-based beliefs may play a distinctive role in perceptual epistemology. The role for consciousness may go further still. Chapter 8 concludes by drawing some speculative morals for the role of consciousness in grounding intentionality quite generally, a topic that I revisit in chapters 11 and 12. Chapter 9 ends with some morals about the general role of consciousness in epistemology. Chapter 10 concerns a role for phenomenal concepts in the debate over materialism. As I noted earlier, many Type B materialists think that a unique epistemic gap exists between physical and phenomenal truths, one that does not arise in other domains. It is then incumbent on them to explain why there should be such a gap in a purely physical world. By far the most popular strategy is to argue that the gap results from the way we think about consciousness, rather than from the nature of consciousness itself, and in particular from the nature of phenomenal concepts. Many different accounts of phenomenal concepts have been offered for this purpose. In Chapter 6 I argue against two such accounts individually. In Chapter 10 I discuss the accounts as a class and argue that no such account can work. In particular, I argue that there is no account of phenomenal concepts such that the nature of the concepts is both explainable in physical terms and capable of explaining our epistemic situation regarding consciousness. And I argue that without doing these things, the account is toothless in explaining away the epistemic gap. Put differently, if an account of phenomenal concepts is substantial enough to explain our distinctive epistemic situation regarding consciousness, it will itself be as difficult to explain in physical terms as consciousness was. If I am right about this, it removes perhaps the most powerful sort of opposition to the arguments of chapters 1, 5, and 6. Chapters 11-13 concern the contents of consciousness, in particular, the way that consciousness represents the external world. A central theme is the connection between consciousness and intentionality. Chapters 11 and 12 are concerned with the contents of perceptual experience. Chapter 13 is concerned with external world representation in belief rather than in perception, but the themes are closely connected. Chapter 11 focuses on representationalism, or intentionalism, roughly, the view that consciousness is essentially and wholly a matter of representing goings-on in the world. Representationalism has been a central view in recent philosophy of perception and philosophy of consciousness more generally. It is often put forward as a reductive thesis and is used in the interest of reducing consciousness to the physical. It is also often put forward as a radically externalist thesis, on which consciousness is grounded in states outside the head. These commitments are quite inessential to representationalism per se, however, and representationalism is much more plausible when it is detached from them. In this chapter I argue for a distinctive sort of non-reductive, internalist representationalism, one that has most of the benefits of other sorts of representationalism along with relatively few of the costs. The first half of chapter 11 surveys the territory. I clarify the nature of representationalism and argue for its plausibility. I survey varieties of representationalism, making the case for a non-reductive, internalist variety. The second half of the chapter develops an account of the contents of perceptual experience. If internalism is true, it appears that standard forms of environment-dependent content are ruled out and that one needs a sort of narrow, or internal, content instead. I bring in some ideas from the two-dimensional semantic framework to analyze the content of perception into two dimensions, free-gene content and Russellian content. Free-gene content is narrow, while Russellian content is not. I argue that free-gene content is closely associated with the phenomenal character of experience. An afterword to the chapter spells out the application of the two-dimensional framework to perception in more depth. Chapter 12 takes up the issue of the contents of experience where Chapter 11 leaves off. I argue that the account of free-gene content in Chapter 11 has some important inadequacies concerning its relation to phenomenology and leaves some crucial issues unexplained. I develop a further account involving what I call Edenic content, content that represents primitive properties, such as primitive redness or greenness, properties that are not instantiated in our world but that one can imagine might have been instantiated in the Garden of Eden. I bring this account to bear on many questions in the philosophy of perception, including questions about color constancy, spatial content, the representation of objects, and more. I originally intended chapters 11 and 12 to be one long piece of work, but they are each long enough as they stand. Separating them might give the sense that I had a change of mind between the chapters, but that is not quite right. The Edenic view in Chapter 12 extends the free-gene view in Chapter 11 without rejecting it. When it comes to the metaphysics of consciousness, I think the Edenic story is more fundamental. Fundamentally, consciousness may consist in the phenomenal representation of certain primitive properties. However, more than one sort of content is required for an adequate account of the many aspects of representation in experience. This reflects a general pluralism about mental and semantic content. One almost always needs contents of many different sorts to properly understand the complex phenomena of representation. Chapters 11 and 12, along with chapters 8 and 9, can also be viewed as a contribution to what is now often called the Phenomenal Intentionality Research Program, the program of grounding intentionality in phenomenology. Chapters 11 and 12 suggest that a distinctive sort of intentionality is inherent in perceptual experience. Chapters 8 and 9 suggest that phenomenology can play a constitutive role in determining the content of our beliefs, along with a corresponding epistemological role. These suggestions might well be taken much further. While I doubt that all of intentionality is fully determined by phenomenology, I think that intentionality cannot be properly understood without giving phenomenology a central role. I am at least attracted to a view in which all narrow intentionality is grounded in phenomenal intentionality along with functional and/or inferential roles, and in which wide intentionality is grounded in turn in narrow intentionality plus the environment in the way suggested by the two-dimensional framework. I cannot claim to have made the case for a view as strong as that here, but I hope to develop it in future work. Chapter 13 uses the movie The Matrix to address issues about our knowledge of the external world. On the face of it, the movie raises a version of Descartes' skeptical challenge. Just as I cannot know I am not the victim of an evil genius, I also cannot know I am not in a matrix. And if I am in a matrix, so the challenge goes, most of my beliefs are false, I am not really seeing a table in front of me, I do not really live in Australia, and so on. In this chapter, I argue that this thought, although initially compelling, is wrong. Even if I am in a matrix, there are still tables and cars, and most of my beliefs remain true. That is, the hypothesis that I am in a matrix is not a skeptical hypothesis, as traditionally thought. Instead, it is a sort of metaphysical hypothesis about the underlying nature of our world. If we are in a matrix, the physical world is more fundamentally a computational world, in which things are made of bits. This is an interesting new metaphysics, but it does not lead to skepticism. I argue that much the same applies to many traditional skeptical hypotheses, such as the evil demon hypothesis and the hypothesis that my life is a dream. This does not provide a complete victory over skepticism. Some skeptical hypotheses survive, but it nevertheless helps in the project of vindicating knowledge of the external world. The conclusion of the chapter is in some ways reminiscent of anti-skeptical conclusions by philosophers as diverse as Berkeley and Putnam. However, I arrive at the conclusion by a quite different route, one that involves reflection on the possible character of physics, as well as on the possible character of the mind-body relation and of creation. Most people start off very dubious about the conclusion, just as I did, but my experience is that the arguments bring a surprising number of people around. I am not sure what to make of this, except perhaps that in this domain people's Cartesian intuitions run less deep than one might think. On the face of it, Chapter 13 might seem distant from Chapters 11 and 12, with little explicit discussion of perception and consciousness. In fact, the issues are deeply linked. If the arguments in this chapter are correct, the beliefs of a subject in a matrix are largely true. The same goes for perception. The perceptual experiences of a subject in a matrix are largely veridical. This picture coheres well with the free gene picture developed in Chapter 11, according to which perception represents properties that are the normal causes of certain sorts of perceptual experiences. This free gene content does not require properties of a highly constrained sort, so if it turns out that the relevant experiences are typically caused by certain computational properties, then these properties are represented by our experiences. This way, our experiences can be largely veridical, and our corresponding beliefs largely true. Still, there is a persisting intuition that, if we are in a matrix, the world is not wholly as it seems. This intuition can be accommodated by bringing in ideas from Chapter 12. If we are in a matrix, our experiences are not perfectly veridical. That would require our world to have primitive color properties, primitive spatiotemporal properties, and so on, as in Eden. But a moral of the Matrix chapter is that a matrix world is no better and no worse than a non-matrix world in which quantum mechanics, relativity, and so on are true. In such a world, we have already fallen from Eden. Even in the world as revealed by contemporary science, it seems that our experiences are not perfectly veridical. Their Edenic contents are not true at best, they are imperfectly veridical. Their ordinary free gene and Russellian contents are true. But imperfect veridicality is good enough. And imperfect veridicality is something that the world of science shares with the world of the matrix. In effect, Eden and the matrix can be seen as two poles in a familiar philosophical dichotomy. Eden is akin to the manifest image, the world exactly as it seems to us. The matrix is, very loosely, akin to the scientific image, the messy and complicated real world of science with its many divergences from the manifest. But despite the mismatch between these images, we have grown used to the idea that the world of the scientific image is good enough to make our ordinary beliefs about the world true. The world does not vindicate them completely. A perfect match would require primitive solidity, primitive redness, and primitive squareness, and nothing in our world is really that way. So in a sense, our manifest image puts demands on the world that it does not meet. Still, the world of science vindicates our beliefs and experiences well enough by meeting the standard of imperfect veridicality. Perfect veridicality would require our world to be Eden, but imperfect veridicality can be satisfied even in a matrix. These two poles call to mind another famous dichotomy. Eden corresponds at least loosely to Kant's phenomenal world, the world of things as they appear. The matrix corresponds loosely to Kant's noumenal world, the world of things in themselves. We might think of Eden as a pure phenomenal world. If we were in Eden, nothing would have a hidden nature. But if we are in the matrix, the world has a hidden nature that is not revealed to us in perception or even in ordinary science. Like the analogy with the scientific image, the analogy with the noumenal world is imperfect. The movie offers us an uncanny route to see the things in themselves. The red pill reveals their computational nature, which of course just raises the question of the noumena underlying the computers in turn. Still, through this lens, the film no longer seems to be an illustration of Cartesian deception. Rather, it is an illustration of Kantian, or perhaps Russellian, humility. Perception and even science do not reveal the entire intrinsic character of the world. Perhaps it was unreasonable ever to expect that they would. Still, even if perception and science are not perfect, in their imperfect ways they are adequate to their tasks all the same. Reflection on the matrix scenario is fertile in many other ways. Coming to grips with it requires getting to the bottom of some of the deepest issues in philosophy. These include not just issues in epistemology but also those in metaphysics. What is the nature of objects? The philosophy of language, what determines the reference of our expressions? The philosophy of mind, how do we make cognitive contact with the world? The philosophy of perception, how do we represent space? The philosophy of physics, what is the role of spatio-temporal concepts in theoretical physics? The philosophy of computation, what does it take to implement a computation? And even the philosophy of religion, what should we say about God if our world is the product of imperfect creators? And ethics, is life in a matrix as meaningful as a life outside it? I address a few of these issues in the chapter and in the philosophical notes that follow. I am sure that I have not gotten to the bottom of any of them. Still, because of the way that it opens a door to all of these issues in such a simple way, this chapter is my favorite in the book. Chapter 14, co-authored with Tim Bain, addresses another Kantian topic, the unity of consciousness. It is hard to turn this fuzzy topic into clear philosophy, but in recent years a few people have tried. This is our attempt. We start with the question of what it is for two states of consciousness, experiencing red and hearing middle C, say, to be unified. We analyze a number of different notions of unity in search of one that undergirds a non-trivial but still plausible unity thesis holding that consciousness is necessarily unified. This leads to a notion of phenomenal unity, defined in terms of a sort of conjoint phenomenal character. We suggest that there is a prima facie case that consciousness is necessarily unified in this sense and that prima facie counter-evidence from split brain syndrome can be accommodated by making relevant distinctions. To get a better handle on unity, we introduce a quasi-mereological analysis and an analysis in terms of entailment between phenomenal states. We use these analyses to argue against certain representationalist and higher-order theories of consciousness on the grounds that they cannot vindicate the unity thesis. We end by speculating about why consciousness is unified, if indeed it is. The end of the chapter suggests a certain holistic view of the metaphysics of consciousness, one in which local states of consciousness, experiencing red, hearing middle C, are grounded in total states of consciousness for a subject at a time. It is tempting to think that these states are the basic units of consciousness. If we combine this picture with the picture in Chapter 12, a more detailed hypothesis in the metaphysics of consciousness suggests itself. Consciousness consists in the unified phenomenal representation of an Edenic world. I do not know whether this hypothesis is correct, but it is at least aesthetically pleasing. The appendix provides an introduction to the two-dimensional semantic framework that I use in a number of the more technical chapters. This framework provides a very useful tool for analyzing the relationship between modal and epistemological issues, as well as for modeling the content of linguistic expressions and mental states in a way that is sensitive to their cognitive and epistemological roles. After outlining the framework and some of its applications, I address a number of objections that various philosophers have put forward. I think that once the framework is understood correctly, there are straightforward replies to many of these objections, although of course some objections raise substantial issues, too. But readers can decide for themselves. 1. Facing up to the problem of consciousness. 1. Introduction. Consciousness poses the most baffling problems in the science of the mind. There is nothing that we know more intimately than conscious experience, but there is nothing that is harder to explain. All sorts of mental phenomena have yielded to scientific investigation in recent years, but consciousness has stubbornly resisted. Many have tried to explain it, but the explanations always seem to fall short of the target. Some have been led to suppose that the problem is intractable and that no good explanation can be given. To make progress on the problem of consciousness, we have to confront it directly. In this chapter I first isolate the truly hard part of the problem, separating it from more tractable parts and giving an account of why it is so difficult to explain. I critique some recent work that uses reductive methods to address consciousness and argue that these methods inevitably fail to come to grips with the hardest part of the problem. Once this failure is recognized, the door to further progress is opened. In the second half of the chapter I argue that, if we move to a new kind of non-reductive explanation, a naturalistic account of consciousness can be given. 2. The easy problems and the hard problem. There is not just one problem of consciousness. Consciousness is an ambiguous term that refers to many different phenomena. Each of these phenomena needs to be explained, but some are easier to explain than others. At the start, it is useful to divide the associated problems of consciousness into hard and easy problems. The easy problems of consciousness are those that seem directly susceptible to the standard methods of cognitive science, whereby a phenomenon is explained in terms of computational or neural mechanisms. The hard problems are those that seem to resist those methods. The easy problems of consciousness include those of explaining the following phenomena. 1. The ability to discriminate, categorize, and react to environmental stimuli. The integration of information by a cognitive system. The reportability of mental states. The ability of a system to access its own internal states. The focus of attention. The deliberate control of behavior. The difference between wakefulness and sleep. All of these phenomena are associated with the notion of consciousness. For example, one sometimes says that a mental state is conscious when it is verbally reportable or when it is internally accessible. Sometimes a system is said to be conscious of some information when it has the ability to react on the basis of that information or, more strongly, when it attends to that information or when it can integrate that information and exploit it in the sophisticated control of behavior. We sometimes say that an action is conscious precisely when it is deliberate. Often we say that an organism is conscious as another way of saying that it is awake. There is no real issue about whether these phenomena can be explained scientifically. All of them are straightforwardly vulnerable to explanation in terms of computational or neural mechanisms. To explain access and reportability, for example, we need only specify the mechanism by which information about internal states is retrieved and made available for verbal report. To explain the integration of information, we need only exhibit mechanisms by which information is brought together and exploited by later processes. For an account of sleep and wakefulness, an appropriate neurophysiological account of the processes responsible for organisms contrasting behavior in those states will suffice. In each case, an appropriate cognitive or neurophysiological model can clearly do the explanatory work. If these phenomena were all there was to consciousness, then consciousness would not be much of a problem. Although we do not yet have anything close to a complete explanation of these phenomena, we have a clear idea of how we might go about explaining them. This is why I call these problems the easy problems. Of course, easy is a relative term. Getting the details right will probably take a century or two of difficult empirical work. Still, there is every reason to believe that the methods of cognitive science and neuroscience will succeed. The really hard problem of consciousness is the problem of experience. When we think and perceive, there is a whir of information processing, but there is also a subjective aspect. As Nagel, 1974, has put it, there is something it is like to be a conscious organism. This subjective aspect is experience. When we see, for example, we experience visual sensations, the felt quality of redness, the experience of dark and light, the quality of depth in a visual field. Other experiences go along with perception in different modalities, the sound of a clarinet, the smell of mothballs. Then there are bodily sensations from pains to orgasms, mental images that are conjured up internally, the felt quality of emotion, and the experience of a stream of conscious thought. What unites all of these states is that there is something it is like to be in them. All of them are states of experience. It is undeniable that some organisms are subjects of experience, but the question of why it is that these systems are subjects of experience is perplexing. Why is it that when our cognitive systems engage in visual and auditory information processing, we have visual or auditory experience, the quality of deep blue, the sensation of middle C? How can we explain why there is something it is like to entertain a mental image or to experience an emotion? It is widely agreed that experience arises from a physical basis, but we have no good explanation of why and how it so arises. Why should physical processing give rise to a rich inner life at all? It seems objectively unreasonable that it should, and yet it does. If any problem qualifies as the problem of consciousness, it is this one. In this central sense of consciousness, an organism is conscious if there is something it is like to be that organism, and a mental state is conscious if there is something it is like to be in that state. Sometimes terms such as phenomenal consciousness and qualia are also used here, but I find it more natural to speak of conscious experience or simply experience. Another useful way to avoid confusion, used by, example Newell 1990, Chalmers 1996, is to reserve the term consciousness for the phenomena of experience, using the less loaded term awareness for the more straightforward phenomena described earlier. If such a convention were widely adopted, communication would be much easier. As things stand, those who talk about consciousness are frequently talking past each other. The ambiguity of the term consciousness is often exploited by both philosophers and scientists writing on the subject. It is common to see a paper on consciousness begin with an invocation of the mystery of consciousness, noting the strange intangibility and ineffability of subjectivity and worrying that so far we have no theory of the phenomenon. Here, the topic is clearly the hard problem, the problem of experience. In the second half of the paper, the tone becomes more optimistic, and the author's own theory of consciousness is outlined. Upon examination, this theory turns out to be a theory of one of the more straightforward phenomena of reportability, of introspective access, or whatever. At the close, the author declares that consciousness has turned out to be tractable after all, but the reader is left feeling like the victim of a bait-and-switch. The hard problem remains untouched. 3. Functional explanation. Why are the easy problems easy, and why is the hard problem hard? The easy problems are easy precisely because they concern the explanation of cognitive abilities and functions. To explain a cognitive function, we need only specify a mechanism that can perform the function. The methods of cognitive science are well suited for this sort of explanation and so are well suited to the easy problems of consciousness. By contrast, the hard problem is hard precisely because it is not a problem about the performance of functions. The problem persists even when the performance of all of the relevant functions is explained. Here function is not used in the narrow teleological sense of something that a system is designed to do, but in the broader sense of any causal role in the production of behavior that a system might perform. To explain reportability, for instance, is just to explain how a system could perform the function of producing reports on internal states. To explain internal access, we need to explain how a system could be appropriately affected by its internal states and use information about them in directing later processes. To explain integration and control, we need to explain how a system's central processes can bring information together and use them in the facilitation of various behaviors. These are all problems about the explanation of functions. How do we explain the performance of a function? By specifying a mechanism that performs the function. Here, neurophysiological and cognitive modeling are perfect for the task. If we want a detailed, low-level explanation, we can specify the neural mechanism that is responsible for the function. If we want a more abstract explanation, we can specify a mechanism in computational terms. Either way, a full and satisfying explanation will result. Once we have specified the neural or computational mechanism that performs the function of verbal report, for example, the bulk of our work in explaining reportability is over. In a way, the point is trivial. It is a conceptual fact about these phenomena that their explanation involves only the explanation of various functions, as the phenomena are functionally definable. All it means for reportability to be instantiated in a system is that the system has the capacity for verbal reports of internal information. All it means for a system to be awake is for it to be appropriately receptive to information from the environment and for it to be able to use this information in directing behavior in an appropriate way. To see that this is a conceptual fact, note that someone who says, "You have explained the performance of the verbal report function, but you have not explained reportability," is making a trivial conceptual mistake about reportability. All it could possibly take to explain reportability is an explanation of how the relevant function is performed. The same goes for the other phenomena in question. Throughout the higher level sciences, reductive explanation works in just this way. To explain the gene, for instance, we needed to specify the mechanism that stores and transmits hereditary information from one generation to the next. It turns out that DNA performs this function. Once we explain how the function is performed, we have explained the gene. To explain life, we ultimately need to explain how a system can reproduce, adapt to its environment, metabolize, and so on. All of these are questions about the performance of functions and so are well suited to reductive explanation. The same holds for most problems in cognitive science. To explain learning, we need to explain the way in which a system's behavioral capacities are modified in light of environmental information, and the way in which new information can be brought to bear in adapting a system's actions to its environment. If we show how a neural or computational mechanism does the job, we have explained learning. We can say the same for other cognitive phenomena, such as perception, memory, and language. Sometimes the relevant functions need to be characterized quite subtly, but it is clear that insofar as cognitive science explains these phenomena at all, it does so by explaining the performance of functions. When it comes to conscious experience, this sort of explanation fails. What makes the hard problem hard and almost unique is that it goes beyond problems about the performance of functions. To see this, note that even when we have explained the performance of all the cognitive and behavioral functions in the vicinity of experience, perceptual discrimination, categorization, internal access, verbal report, a further unanswered question may remain: why is the performance of these functions accompanied by experience? A simple explanation of the functions leaves this question open. There is no analogous further question in the explanation of genes or of life or of learning. If someone says, "I can see that you have explained how DNA stores and transmits hereditary information from one generation to the next, but you have not explained how it is a gene," then they are making a conceptual mistake. All it means to be a gene is to be an entity that performs the relevant storage and transmission function. But if someone says, "I can see that you have explained how information is discriminated, integrated, and reported, but you have not explained how it is experienced," they are not making a conceptual mistake. This is a non-trivial further question. This further question is the key question in the problem of consciousness. Why doesn't all of this information processing go on in the dark, free of any inner field? Why is it that when electromagnetic waveforms impinge on a retina and are discriminated and categorized by a visual system, the discrimination and categorization are experienced as a sensation of vivid red? We know that conscious experience does arise when these functions are performed, but the very fact that it arises is the central mystery. There is an explanatory gap, a term due to Levine 1983, between the functions and experience, and we need an explanatory bridge to cross it. A mere account of the functions stays on one side of the gap, so the materials for the bridge must be found elsewhere. This is not to say that experience has no function. Perhaps it will turn out to play an important cognitive role, but for any role it might play, there will be more to the explanation of experience than a simple explanation of the function. Perhaps it will even turn out that in the course of explaining a function, we will be led to the key insight that allows an explanation of experience. If this happens, though, the discovery will be an extra explanatory reward. There is no cognitive function such that we can say in advance that explanation of that function will automatically explain experience. To explain experience, we need a new approach. The usual explanatory methods of cognitive science and neuroscience do not suffice. These methods have been developed precisely to explain the performance of cognitive functions, and they do a good job of it. Still, as these methods stand, they are equipped to explain only the performance of functions. When it comes to the hard problem, the standard approach has nothing to say. For some case studies. In the last few years, a number of works have addressed the problems of consciousness within the framework of cognitive science and neuroscience. This might suggest that the foregoing analysis is faulty, but in fact a close examination of the relevant work only lends the analysis further support. When we investigate just which aspects of consciousness these studies are aimed at and which aspects they end up explaining, we find that the ultimate target of explanation is always one of the easy problems. I illustrate this with two representative examples. The first is the neurobiological theory of consciousness outlined by Crick and Cook, 1990, see also Crick 1994. This theory centers on certain 35-75 Hz neural oscillations in the cerebral cortex. Crick and Cook hypothesize that these oscillations are the basis of consciousness. This is partly because the oscillations seem to be correlated with awareness in a number of different modalities within the visual and olfactory systems, for example, and also because they suggest a mechanism by which the binding of information might be achieved. Binding is the process whereby separately represented pieces of information about a single entity are brought together to be used by later processing, as when information about the color and shape of a perceived object is integrated from separate visual pathways. Following others, example Eckhorn et al. 1988, Crick and Cook hypothesize that binding may be achieved by the synchronized oscillations of neuronal groups representing the relevant contents. When two pieces of information are to be bound together, the relevant neural groups will oscillate with the same frequency and phase. The details of how this binding might be achieved are still poorly understood, but suppose that they can be worked out. What might the resulting theory explain? Clearly it might explain the binding of information, and perhaps it might yield a more general account of the integration of information in the brain. Crick and Cook also suggest that these oscillations activate the mechanisms of working memory, so that there may be an account of this and perhaps other forms of memory in the distance. The theory might eventually lead to a general account of how perceived information is bound and stored in memory for use by later processing. Such a theory would be valuable, but it would tell us nothing about why the relevant contents are experienced. Crick and Cook suggest that these oscillations are the neural correlates of experience. This claim is arguable. Does not binding also take place in the processing of unconscious information? But even if it is accepted, the explanatory question remains: why do the oscillations give rise to experience? The only basis for an explanatory connection is the role they play in binding and storage, but the question of why binding and storage should themselves be accompanied by experience is never addressed. If we do not know why binding and storage should give rise to experience, Telling a story about the oscillations cannot help us. Conversely, if we knew why binding and storage gave rise to experience, the neurophysiological details would be just the icing on the cake. Crick and Cock's theory gains its purchase by assuming a connection between binding and experience and so can do nothing to explain that link. I do not think that Crick and Cook are ultimately claiming to address the hard problem, although some have interpreted them that way. A published interview with Cook gives a clear statement of the limitations on the theory's ambitions. Well, let's first forget about the really difficult aspects, like subjective feelings, for they may not have a scientific solution. The subjective state of play, of pain, of pleasure, of seeing blue, of smelling a rose. There seems to be a huge jump between the materialistic level, of explaining molecules and neurons, and the subjective level. Let's focus on things that are easier to study, like visual awareness. You're now talking to me, but you're not looking at me, you're looking at the cappuccino, and so you are aware of it. You can say, it's a cup and there's some liquid in it. If I give it to you, you'll move your arm and you'll take it, you'll respond in a meaningful manner. That's what I call awareness. What is consciousness? Discover November 1992, 96. The second example is an approach at the level of cognitive psychology. This is Bernard Barz's global workspace theory of consciousness, presented in his book A Cognitive Theory of Consciousness. According to this theory, the contents of consciousness are contained in a global workspace, a central processor used to mediate communication between a host of specialized non-conscious processors. When these specialized processors need to broadcast information to the rest of the system, they do so by sending this information to the workspace, which acts as a kind of communal blackboard for the rest of the system, accessible to all the other processors. Barz uses this model to address many aspects of human cognition and to explain a number of contrasts between conscious and unconscious cognitive functioning. Ultimately, however, it is a theory of cognitive accessibility that explains how it is that certain information contents are widely accessible within a system, as well as a theory of informational integration and reportability. The theory shows promise as a theory of awareness, the functional correlate of conscious experience, but an explanation of experience itself is not on offer. One might suppose that, according to this theory, the contents of experience are precisely the contents of the workspace. However, even if this is so, nothing internal to the theory explains why the information within the global workspace is experienced. The best the theory can do is to say that the information is experienced because it is globally accessible. But now the question arises in a different form: why should global accessibility give rise to conscious experience? As always, this bridging question is unanswered. Almost all of the work taking a cognitive or neuroscientific approach to consciousness in recent years could be subjected to a similar critique. The neural Darwinism model of Edelman c. 1989, for instance, addresses questions about perceptual awareness and the self-concept but says nothing about why there should also be experience. The multiple drafts model of Dennett, 1991, is largely directed at explaining the reportability of certain mental contents. The intermediate level theory of Jackendorf, 1988, provides an account of some computational processes that underlie consciousness, but Jackendorf stresses that the question of how these project into conscious experience remains mysterious. Researchers using these methods are often inexplicit about their attitudes to the problem of conscious experience, although sometimes they take a clear stand. Even among those who are clear about it, attitudes differ widely. In relating this sort of work to the problem of experience, a number of different strategies are available. It would be useful if these strategic choices were more often made explicit. The first strategy is simply to explain something else. Some researchers are explicit that the problem of experience is too difficult for now and perhaps even outside the domain of science altogether. These researchers instead choose to address one of the more tractable problems such as reportability or the concept of the self. Although I have called these problems the easy problems, they are among the most interesting unsolved problems in cognitive science, so this work is certainly worthwhile. The worst that can be said of this choice is that in the context of research on consciousness it is relatively unambitious, and the work can sometimes be misinterpreted. The second choice is to take a harder line and deny the phenomenon. Variations on this approach are taken by Allport 1988, Dennett 1991, Wilkes 1988. According to this line, once we have explained the functions such as accessibility and reportability, there is no further phenomenon called experience to explain. Some explicitly deny the phenomenon, holding, for example, that what is not externally verifiable cannot be real. Others achieve the same effect by allowing that experience exists, but only if we equate experience with something like the capacity to discriminate and report. These approaches lead to a simpler theory but are ultimately unsatisfactory. Experience is the most central and manifest aspect of our mental lives, and indeed is perhaps the key explanandum in the science of the mind. Because of this status as an explanandum, experience cannot be discarded like the vital spirit when a new theory comes along. Rather, it is the central fact that any theory of consciousness must explain. A theory that denies the phenomenon solves the problem by ducking the question. In a third option, some researchers claim to be explaining experience in the full sense. These researchers, unlike those mentioned above, wish to take experience very seriously. They lay out their functional model or theory and claim that it explains the full subjective quality of experience. Example: Floor 1992, Humphrey 1992. The relevant step in the explanation is typically passed over quickly, however, and usually ends up looking something like magic. After some details about information processing are given, experience suddenly enters the picture, but it is left obscure how these processes should suddenly give rise to experience. Perhaps it is simply taken for granted that it does, but then we have an incomplete explanation and a version of the fifth strategy below. A fourth, more promising approach appeals to these methods to explain the structure of experience. For example, it is arguable that an account of the discriminations made by the visual system can account for the structural relations between different color experiences, as well as for the geometric structure of the visual field. See, example Clark 1992, Harden 1992. In general, certain facts about structures found in processing will correspond to and arguably explain facts about the structure of experience. This strategy is plausible but limited. At best, it takes the existence of experience for granted and accounts for some facts about its structure, providing a sort of non-reductive explanation of the structural aspects of experience. I say more on this later. This is useful for many purposes, but it tells us nothing about why there should be experience in the first place. A fifth and reasonable strategy is to isolate the substrate of experience. After all, almost everyone allows that experience arises in one way or another from brain processes, and it makes sense to identify the sort of process from which it arises. Crick and Cook present their work as isolating the neural correlate of consciousness, for example, and Edelman, 1989, and Jackendorf, 1987, make related claims. Justification of these claims requires careful theoretical analysis, especially as experience is not directly observable in experimental contexts, but when applied judiciously this strategy can shed indirect light on the problem of experience. Nevertheless, the strategy is clearly incomplete. For a satisfactory theory, we need to know more than which processes give rise to experience. We also need an account of why and how. A full theory of consciousness must build an explanatory bridge. 5. The extra ingredient. We have seen that there are systematic reasons why the usual methods of cognitive science and neuroscience fail to account for conscious experience. These are simply the wrong sort of methods. Nothing that they give to us can yield an explanation. To account for conscious experience, we need an extra ingredient in the explanation. This makes for a challenge to those who are serious about the hard problem of consciousness. What is your extra ingredient, and why should that account for conscious experience? There is no shortage of extra ingredients to be had. Some propose an injection of chaos and nonlinear dynamics. Some think that the key lies in non-algorithmic processing. Some appeal to future discoveries in neurophysiology. Some suppose that the key to the mystery will lie at the level of quantum mechanics. It is easy to see why all of these suggestions are proposed. None of the old methods work, so the solution must lie with something new. Unfortunately, these suggestions all suffer from the same old problems. Non-algorithmic processing, for example, is suggested by Penrose, 1989, 1994, because of the role it might play in the process of conscious mathematical insight. The arguments about mathematics are controversial, but even if they succeed and an account of non-algorithmic processing in the human brain is given, it will still only be an account of the functions involved in mathematical reasoning and the like. For a non-algorithmic process as much as an algorithmic process, the question is left unanswered: why should this process give rise to experience? In answering this question, there is no special role for non-algorithmic processing. The same goes for nonlinear and chaotic dynamics. These might provide a novel account of the dynamics of cognitive functioning, quite different from that given by standard methods in cognitive science. But from dynamics, one only gets more dynamics. The question about experience here is as mysterious as ever. The point is even clearer for new discoveries in neurophysiology. These discoveries may help us make significant progress in understanding brain function, but for any neural process we isolate, the same question will always arise. It is difficult to imagine what a proponent of new neurophysiology expects to happen over and above the explanation of further cognitive functions. It is not as if we will suddenly discover a phenomenal glow inside a neuron. Perhaps the most popular extra ingredient of all is quantum mechanics, example Hameroff 1994. The attractiveness of quantum theories of consciousness may stem from a law of minimization of mystery: consciousness is mysterious, and quantum mechanics is mysterious, so maybe the two mysteries have a common source. Nevertheless, quantum theories of consciousness suffer from the same difficulties as neural or computational theories. Quantum phenomena have some remarkable functional properties, such as nondeterminism and non-locality. It is natural to speculate that these properties may play some role in the explanation of cognitive functions, such as random choice and the integration of information, and this hypothesis cannot be ruled out a priori. When it comes to the explanation of experience, however, quantum processes are in the same boat as any other. The question of why these processes should give rise to experience is entirely unanswered. 3. One special attraction of quantum theories is the fact that, according to some interpretations of quantum mechanics, consciousness plays an active role in collapsing the quantum wave function. Such interpretations are controversial, but in any case they offer no hope of explaining consciousness in terms of quantum processes. Rather, these theories assume the existence of consciousness and use it in the explanation of quantum processes. At best, these theories tell us something about a physical role that consciousness may play. They tell us nothing about why it arises. At the end of the day, the same criticism applies to any purely physical account of consciousness. For any physical process we specify, there will be an unanswered question: why should this process give rise to experience? Given any such process, it is conceptually coherent that it could be instantiated in the absence of experience. It follows that no mere account of the physical process will tell us why experience arises. The emergence of experience goes beyond what can be derived from physical theory. Purely physical explanation is well suited to the explanation of physical structures by explaining macroscopic structures in terms of detailed microstructural constituents. It also provides a satisfying explanation of the performance of functions by accounting for these functions in terms of the physical mechanisms that perform them. This is because once the internal details of the physical account are given, the structural and functional properties fall out as an automatic consequence. However, the structure and dynamics of physical processes yield only more structure and dynamics, so structures and functions are all we can expect these processes to explain. The facts about experience cannot be an automatic consequence of any physical account, as it is conceptually coherent that any given process could exist without experience. Experience may arise from the physical, but it is not explained by the physical. The moral of all this is that you can't explain conscious experience on the cheap. It is a remarkable fact that reductive methods that explain a high-level phenomenon wholly in terms of more basic physical processes work well in so many domains. In a sense, one can explain most biological and cognitive phenomena on the cheap, in that these phenomena are seen as automatic consequences of more fundamental processes. It would be wonderful if reductive methods could explain experience, too. I hoped for a long time that they might. Unfortunately, there are systematic reasons why these methods must fail. Reductive methods are successful in most domains because what needs explaining in those domains are structures and functions, and these are the kinds of thing that a physical account can entail. When it comes to a problem over and above the explanation of structures and functions, these methods are impotent. This might seem reminiscent of the vitalist claim that no physical account could explain life, but the cases are disanalogous. What drove vitalist skepticism was doubt about whether physical mechanisms could perform the many remarkable functions associated with life, such as complex adaptive behavior and reproduction. The conceptual claim that explanation of functions is what is needed was implicitly accepted, but, lacking detailed knowledge of biochemical mechanisms, the vitalists doubted whether any physical process could do the job and proposed the hypothesis of the vital spirit as an alternative explanation. For once it turned out that physical processes could perform the relevant functions, vitalist doubts melted away. With experience, on the other hand, physical explanation of the functions is not in question. The key is instead the conceptual point that the explanation of functions does not suffice for the explanation of experience. This basic conceptual point is not something that further neuroscientific investigation will affect. In a similar way, experience is disanalogous to the Allah vital. The vital spirit was presented as an explanatory posit in order to explain the relevant functions and could therefore be discarded when those functions were explained without it. Experience is not an explanatory posit but an explanandum in its own right, and so is not a candidate for this sort of elimination. It is tempting to note that all sorts of puzzling phenomena have eventually turned out to be explainable in physical terms. But these were all problems about the observable behavior of physical objects and came down to problems in the explanation of structures and functions. Because of this, these phenomena have always been the kind of thing that a physical account might explain, even if at some points there have been good reasons to suspect that no such explanation would be forthcoming. The tempting induction from these cases fails in the case of consciousness, which is not a problem about physical structures and functions. The problem of consciousness is puzzling in an entirely different way. An analysis of the problem shows us that conscious experience is just not the kind of thing that a wholly reductive account could succeed in explaining. 6. Non-reductive explanation. At this point some are tempted to give up, holding that we will never have a theory of conscious experience. McGinn, 1989, for example, argues that the problem is too hard for our limited minds. We are cognitively closed with respect to the phenomenon. Others have argued that conscious experience lies outside the domain of scientific theory altogether. I think this pessimism is premature. This is not the place to give up, it is the place where things get interesting. When simple methods of explanation are ruled out, we need to investigate the alternatives. Given that reductive explanation fails, non-reductive explanation is the natural choice. Although a remarkable number of phenomena have turned out to be explicable wholly in terms of entities simpler than themselves, this is not universal. In physics, it occasionally happens that an entity has to be taken as fundamental. Fundamental entities are not explained in terms of anything simpler. Instead, one takes them as basic and gives a theory of how they relate to everything else in the world. For example, in the 19th century it turned out that electromagnetic processes could not be explained in terms of the wholly mechanical processes that previous physical theories appealed to, so Maxwell and others introduced electromagnetic charge and electromagnetic forces as new fundamental components of a physical theory. To explain electromagnetism, the ontology of physics had to be expanded. New basic properties and basic laws were needed to give a satisfactory account of the phenomena. Other features that physical theory takes as fundamental include mass and space-time. No attempt is made to explain these features in terms of anything simpler. This does not rule out the possibility of a theory of mass or of space-time, however. There is an intricate theory of how these features interrelate and of the basic laws they enter into. This theory is used to explain many familiar higher-level phenomena concerning mass, space, and time. I suggest that a theory of consciousness should take experience as fundamental. We know that a theory of consciousness requires the addition of something fundamental to our ontology, as everything in physical theory is compatible with the absence of consciousness. We might add some entirely new non-physical feature from which experience can be derived, but it is hard to see what such a feature would be like. More likely, we will take experience itself as a fundamental feature of the world, alongside mass, charge, and space-time. If we take experience as fundamental, then we can go about the business of constructing a theory of experience. Where there is a fundamental property, there are fundamental laws. A non-reductive theory of experience will add new principles to the basic laws of nature. These basic principles will ultimately carry the explanatory burden in a theory of consciousness. Just as we explain familiar high-level phenomena involving mass in terms of more basic principles involving mass and other entities, we might explain familiar phenomena involving experience in terms of more basic principles involving experience and other entities. In particular, a non-reductive theory of experience will specify basic principles that tell us how experience depends on physical features of the world. These psychophysical principles will not interfere with physical laws, as it seems that physical laws already form a closed system. Rather, they will be a supplement to a physical theory. A physical theory gives a theory of physical processes, and a psychophysical theory tells us how those processes give rise to experience. We know that experience depends on physical processes, but we also know that this dependence cannot be derived from physical laws alone. The new basic principles postulated by a non-reductive theory give us the extra ingredient that we need to build an explanatory bridge. Of course, by taking experience as fundamental, there is a sense in which this approach does not tell us why there is experience in the first place, but this is the same for any fundamental theory. Nothing in physics tells us why there is matter in the first place, but we do not count this against theories of matter. Certain features of the world need to be taken as fundamental by any scientific theory. A theory of matter can still explain all sorts of facts about matter by showing how they are consequences of the basic laws. The same goes for a theory of experience. This position qualifies as a variety of dualism as it postulates basic properties over and above the properties invoked by physics. But it is an innocent version of dualism, entirely compatible with the scientific view of the world. Nothing in this approach contradicts anything in physical theory, we simply need to add further bridging principles to explain how experience arises from physical processes. There is nothing particularly spiritual or mystical about this theory. Its overall shape is like that of a physical theory, with a few fundamental entities connected by fundamental laws. It expands the ontology slightly, to be sure, but Maxwell did the same thing. Indeed, the overall structure of this position is entirely naturalistic, allowing both that the universe ultimately comes down to a network of basic entities obeying simple laws and that there eventually may be a theory of consciousness cast in terms of such laws. If the position is to have a name, naturalistic dualism is a good choice. If this view is right, then in some ways a theory of consciousness will have more in common with a theory in physics than a theory in biology. Biological theories involve no principles that are fundamental in this way, so biological theory has a certain complexity and messiness to it, but theories in physics, insofar as they deal with fundamental principles, aspire to simplicity and elegance. The fundamental laws of nature are part of the basic furniture of the world, and physical theories are telling us that this basic furniture is remarkably simple. If a theory of consciousness also involves fundamental principles, then we should expect the same. The principles of simplicity, elegance, and even beauty, which drive physicists' search for a fundamental theory, will also apply to a theory of consciousness. Some philosophers, the type B materialists of Chapter 5, argue that even though there is a conceptual gap between physical processes and experience, there need be no metaphysical gap, so that experience might in a certain sense still be physical. I argue against this view in Chapters 5-7 and Chapter 10. Still, if what I have said so far is correct, this position must at least concede an explanatory gap between physical processes and experience. For example, the principles connecting the physical and the experiential will not be derivable from the laws of physics, so such principles must be taken as explanatorily fundamental. So even on this sort of view, the explanatory structure of a theory of consciousness will be much as I have described. 7. Outline of a theory of consciousness. It is not too soon to begin work on a theory. We are already in a position to understand certain key facts about the relationship between physical processes and experience and about the regularities that connect them. Once reductive explanation is set aside, we can lay those facts on the table so that they can play their proper role as the initial pieces in a non-reductive theory of consciousness and as constraints on the basic laws that constitute an ultimate theory. There is an obvious problem that plagues the development of a theory of consciousness, and that is the paucity of objective data. Conscious experience is not directly observable in an experimental context, so we cannot generate data about the relationship between physical processes and experience at will. Nevertheless, we all have access to a rich source of data in our own case. Many important regularities between experience and processing can be inferred from considerations about one's own experience. There are also good indirect sources of data from observable cases, as when one relies on the verbal report of a subject as an indication of experience. These methods have their limitations, but we have more than enough data to get a theory off the ground. Philosophical analysis is also useful in getting value for money out of the data we have. This sort of analysis can yield a number of principles relating consciousness and cognition, thereby strongly constraining the shape of an ultimate theory. The method of thought experimentation can also yield significant rewards, as we will see. Finally, the fact that we are searching for a fundamental theory means that we can appeal to non-empirical constraints such as simplicity and homogeneity in developing a theory. We must seek to systematize the information we have, to extend it as far as possible by careful analysis, and then to make the inference to the simplest possible theory that explains the data while remaining a plausible candidate to be part of the fundamental furniture of the world. Such theories will always retain an element of speculation that is not present in other scientific theories because of the impossibility of conclusive intersubjective experimental tests. Still, we can certainly construct theories that are compatible with the data that we have and evaluate them in comparison to each other. Even in the absence of intersubjective observation, there are numerous criteria available for the evaluation of such theories: simplicity, internal coherence, coherence with theories in other domains, the ability to reproduce the properties of experience that are familiar from our own case, and even an overall fit with the dictates of common sense. Perhaps there will be significant indeterminacies remaining even when all of these constraints are applied, but we can at least develop plausible candidates. Only when candidate theories have been developed will we be able to evaluate them. A non-reductive theory of consciousness will consist in a number of psychophysical principles, principles that connect the properties of physical processes to the properties of experience. We can think of these principles as encapsulating the way in which experience arises from the physical. Ultimately, these principles should tell us what sort of physical systems will have associated experiences, and for the systems that do, they should tell us what sort of physical properties are relevant to the emergence of experience and just what sort of experience we should expect any given physical system to yield. This is a tall order, but there is no reason we should not get started. In what follows, I present my own candidates for the psychophysical principles that might go into a theory of consciousness. The first two of these are non-basic principles: systematic connections between processing and experience at a relatively high level. These principles can play a significant role in developing and constraining a theory of consciousness, but they are not cast at a sufficiently fundamental level to qualify as truly basic laws. The final principle is my candidate for a basic principle, which might form the cornerstone of a fundamental theory of consciousness. This final principle is particularly speculative, but it is the kind of speculation that is required if we are ever to have a satisfying theory of consciousness. I can present these principles only briefly here. I argue for them at much greater length in the conscious mind. 1. The principle of structural coherence. This is a principle of coherence between the structure of consciousness and the structure of awareness. Recall that awareness was used earlier to refer to the various functional phenomena that are associated with consciousness. I am now using it to refer to a somewhat more specific process in the cognitive underpinnings of experience. In particular, the contents of awareness 5 are to be understood as those information contents that are accessible to central systems and brought to bear in a widespread way in the control of behavior. Briefly put, we can think of awareness as direct availability for global control. To a first approximation, the contents of awareness are the contents that are directly accessible and potentially reportable, at least in a language-using system. 6. Awareness is a purely functional notion, but it is nevertheless intimately linked to conscious experience. In familiar cases, wherever we find consciousness, we find awareness. Wherever there is conscious experience, there is some corresponding information in the cognitive system that is available in the control of behavior and available for verbal report. Conversely, it seems that whenever information is available for report and for global control, there is a corresponding conscious experience. Thus, there is a direct correspondence between consciousness and awareness. The correspondence can be taken further. It is a central fact about experience that it has a complex structure. The visual field has a complex geometry, for instance. There are also relations of similarity and difference between experiences, as well as relations in things such as relative intensity. Every subject's experience can be at least partly characterized and decomposed in terms of these structural properties: similarity and difference relations, perceived location, relative intensity, geometric structure, and so on. It is also a central fact that, to each of these structural features, there is a corresponding feature in the information processing structure of awareness. Take color experiences as an example. For every distinction between color experiences, there is a corresponding distinction in processing. The different phenomenal colors that we experience form a complex three-dimensional space, varying in hue, saturation, and intensity. The properties of this space can be recovered from information processing considerations. Examination of the visual systems shows that waveforms of light are discriminated and analyzed along 3 different axes, and it is this three-dimensional information that is relevant to later processing. The three-dimensional structure of phenomenal color space therefore corresponds directly to the three-dimensional structure of visual awareness. This is precisely what we would expect. After all, every experienced color distinction corresponds to some reportable information and therefore to a distinction that is represented in the structure of processing. In a more straightforward way, the geometric structure of the visual field is directly reflected in a structure that can be recovered from visual processing. Every geometric relation corresponds to something that can be reported and is therefore cognitively represented. If we were given only the story about information processing in an agent's visual and cognitive system, we could not directly observe that agent's visual experiences, but we could nevertheless infer those experiences' structural properties. In general, any information that is consciously experienced will also be cognitively represented. The fine-grained structure of the visual field will correspond to some fine-grained structure in visual processing. The same goes for experiences in other modalities and even for non-sensory experiences. Internal mental images have geometric properties that are represented in processing. Even emotions have structural properties, such as relative intensity, that correspond directly to a structural property of processing. Where there is greater intensity, we find a greater effect on later processes. In general, Precisely because the structural properties of experience are accessible and reportable, those properties will be directly represented in the structure of awareness. It is this isomorphism between the structures of consciousness and awareness that constitutes the principle of structural coherence. This principle reflects the central fact that even though cognitive processes do not conceptually entail facts about conscious experience, consciousness and cognition do not float free of one another but cohere in an intimate way. This principle has its limits. It allows us to recover structural properties of experience from information processing properties, but not all properties of experience are structural properties. There are properties of experience, such as the intrinsic nature of a sensation of red, that cannot be fully captured in a structural description. The very intelligibility of inverted spectrum scenarios, where experiences of red and green are inverted but all structural properties remain the same, show that structural properties constrain experience without exhausting it. Nevertheless, the very fact that we feel compelled to leave structural properties unaltered when we imagine experiences inverted between functionally identical systems shows how central the principle of structural coherence is to our conception of our mental lives. It is not a logically necessary principle, as after all we can imagine all of the information processing occurring without any experience at all, but it is nevertheless a strong and familiar constraint on the psychophysical connection. The principle of structural coherence allows for a very useful kind of indirect explanation of experience in terms of physical processes. For example, we can use facts about the neural processing of visual information to indirectly explain the structure of color space. The facts about neural processing can entail and explain the structure of awareness. If we take the coherence principle for granted, the structure of experience will also be explained. Empirical investigation might even lead us to better understand the structure of awareness within a bat, shedding indirect light on Nagel's vexing question of what it is like to be a bat. This principle provides a natural interpretation of much existing work on the explanation of consciousness, example Clark 1992 and Harden 1992 on colors and Akins 1993 on bats, although it is often appealed to inexplicitly. It is so familiar that it is taken for granted by almost everybody and is a central plank in the cognitive explanation of consciousness. The coherence between consciousness and awareness also allows a natural interpretation of work in neuroscience directed at isolating the neural correlate of consciousness. This interpretation is developed further in Chapter 4. 2. The principle of organizational invariance. This principle states that any two systems with the same fine-grained functional organization will have qualitatively identical experiences. If the causal patterns of neural organization were duplicated in silicon, for example, with a silicon chip for every neuron and the same patterns of interaction, then the same experiences would arise. According to this principle, what matters for the emergence of experience is not the specific physical makeup of a system but the abstract pattern of causal interaction between its components. This principle is controversial, of course. Some, example Searle 1980, have thought that consciousness is tied to a specific biology, so that a silicon isomorph of a human need not be conscious. I believe that the principle can be given significant support by the analysis of thought experiments, however. Very briefly, suppose, for the purposes of a reductio ad absurdum, that the principle is false and that there could be two functionally isomorphic systems with different experiences. Perhaps only one of the systems is conscious, or perhaps both are conscious, but they have different experiences. For the purposes of illustration, let us say that one system is made of neurons and the other of silicon and that one experiences red where the other experiences blue. The two systems have the same organization, so we can imagine gradually transforming one into the other, perhaps replacing neurons one at a time by silicon chips with the same local function. We thus gain a spectrum of intermediate cases, each with the same organization but with slightly different physical makeup and slightly different experiences. Along this spectrum, there must be two systems, A and B, between which we replace less than 1/10 of the system but whose experiences differ. These two systems are physically identical, except that a small neural circuit in A has been replaced by a silicon circuit in B. The key step in the thought experiment is to take the relevant neural circuit in A and install alongside it a causally isomorphic silicon circuit, with a switch between the two. What happens when we flip the switch? By hypothesis, the system's conscious experiences will change from red to blue, say. This follows from the fact that the system after the change is essentially a version of B, whereas before the change it is just A. Given the assumptions, however, there is no way for the system to notice the changes. Its causal organization stays constant, so that all of its functional states and behavioral dispositions stay fixed. As far as the system is concerned, nothing unusual has happened. There is no room for the thought, something strange just happened. In general, the structure of any such thought must be reflected in processing, but the structure of processing remains constant here. If there were to be such a thought, it must float entirely free of the system and would be utterly impotent to affect later processing. If it affected later processing, the systems would be functionally distinct, contrary to the hypothesis. We might even flip the switch a number of times, so that experiences of red and blue dance back and forth before the system's inner eye. According to the hypothesis, the system can never notice these dancing qualia. This I take to be a reductio of the original assumption. 7. It is a central fact about experience, very familiar from our own case, that whenever experiences change significantly and we are paying attention, we can notice the change. If this were not the case, we would be led to the skeptical possibility that our experiences are dancing before our eyes all the time. This hypothesis has the same status as the possibility that the world was created 5 minutes ago. Perhaps it is logically coherent, but it is not plausible. Given the extremely plausible assumption that changes in experience correspond to changes in processing, we are led to the conclusion that the original hypothesis is impossible and that any two functionally isomorphic systems must have the same sort of experiences. To put it in technical terms, the philosophical hypotheses of absent qualia and inverted qualia, while logically possible, are empirically and nomologically impossible. Some may worry that a silicon isomorph of a neural system might be impossible for technical reasons. That question is open. The invariance principle says only that if an isomorph is possible, then it will have the same sort of conscious experience. There is more to be said here, but this gives the basic flavor. Once again, this thought experiment draws on familiar facts about the coherence between consciousness and cognitive processing to yield a strong conclusion about the relation between physical structure and experience. If the argument goes through, we know that the only physical properties directly relevant to the emergence of experience are organizational properties. This acts as a further strong constraint on a theory of consciousness. 3. The double aspect theory of information. The two preceding principles are non-basic principles. They involve high-level notions such as awareness and organization and therefore lie at the wrong level to constitute the fundamental laws in a theory of consciousness. Nevertheless, they act as strong constraints. What is further needed are basic principles that fit these constraints and that might ultimately explain them. The basic principle that I suggest centrally involves the notion of information. I understand information in more or less the sense of Shannon, 1948. Where there is information, there are information states embedded in an information space. An information space has a basic structure of difference relations between its elements, characterizing the ways in which different elements in a space are similar or different, possibly in complex ways. An information space is an abstract object, but following Shannon we can see information as physically embodied when there is a space of distinct physical states, the differences between which can be transmitted down some causal pathway. The transmittable states can be seen as themselves constituting an information space. To borrow a phrase from Bateson I 1972. Physical information is a difference that makes a difference. The double aspect principle stems from the observation that there is a direct isomorphism between certain physically embodied information spaces and certain phenomenal, or experiential, information spaces. From the same sort of observations that went into the principle of structural coherence, we can note that the differences between phenomenal states have a structure that corresponds directly to the differences embedded in physical processes, in particular, to those differences that make a difference down certain causal pathways implicated in global availability and control. That is, we can find the same abstract information space embedded in physical processing and in conscious experience. This leads to a natural hypothesis, that information, or at least some information, has two basic aspects, a physical aspect and a phenomenal aspect. This has the status of a basic principle that might underlie and explain the emergence of experience from the physical. Experience arises by virtue of its status as one aspect of information, when the other aspect is found embodied in physical processing. This principle is lent support by a number of considerations, which I can outline only briefly here. First, consideration of the sort of physical changes that correspond to changes in conscious experience suggests that such changes are always relevant by virtue of their role in constituting informational changes, differences within an abstract space of states that are divided up precisely according to their causal differences along certain pathways. Second, if the principle of organizational invariance is to hold, then we need to find some fundamental organizational property for experience to be linked to, and information is an organizational property par excellence. Third, this principle offers some hope of explaining the principle of structural coherence in terms of the structure present within information spaces. Fourth, analysis of the cognitive explanation of our judgments and claims about conscious experience, judgments that are functionally explainable but nevertheless deeply tied to experience itself, suggests that explanation centrally involves the information states embedded in cognitive processing. It follows that a theory based on information allows a deep coherence between the explanation of experience and the explanation of our judgments and claims about it. Wheeler, 1990, has suggested that information is fundamental to the physics of the universe. According to this it-from-bit doctrine, the laws of physics can be cast in terms of information, postulating different states that give rise to different effects without actually saying what those states are. It is only their position in an information space that counts. If so, then information is a natural candidate to also play a role in a fundamental theory of consciousness. We are led to a conception of the world in which information is truly fundamental and in which it has two basic aspects, one that corresponds to the physical and one that corresponds to the phenomenal features of the world. Of course, the double aspect principle is extremely speculative and also underdetermined, leaving a number of key questions unanswered. An obvious question is whether all information has a phenomenal aspect. One possibility is that we need a further constraint on the fundamental theory, indicating just what sort of information has a phenomenal aspect. The other possibility is that there is no such constraint. If not, then experience is much more widespread than we might have believed, as information is everywhere. This is counterintuitive at first, but on reflection the position gains a certain plausibility and elegance. Where there is simple information processing, there is simple experience, and where there is complex information processing, there is complex experience. A mouse has a simpler information processing structure than a human and has correspondingly simpler experience, might a thermostat, a maximally simple information processing structure, have maximally simple experience? Indeed, if experience is truly a fundamental property, it would be surprising for it to arise only every now and then. Most fundamental properties are more evenly spread. In any case, this is very much an open question, but I think that the position is not as implausible as it is often thought to be. Once a fundamental link between information and experience is on the table, the door is open to some grander metaphysical speculation concerning the nature of the world. For example, it is often noted that physics characterizes its basic entities only extrinsically, in terms of their relations to other entities, which are themselves characterized extrinsically, and so on. The intrinsic nature of physical entities is left aside. Some argue that no such intrinsic properties exist, but then one is left with a world that is pure causal flux, a pure flow of information, with no properties for the causation to relate. If one allows that intrinsic properties exist, a natural speculation, given the preceding, is that the intrinsic properties of the physical, the properties that causation ultimately relates, are themselves phenomenal properties. 8. We might say that phenomenal properties are the internal aspect of information. This could answer a concern about the causal relevance of experience and natural worry, given a picture in which the physical domain is causally closed and in which experience is supplementary to the physical. The informational view allows us to understand how experience might have a subtle kind of causal relevance in virtue of its status as the intrinsic nature of the physical. This metaphysical speculation is probably best ignored for the purposes of developing a scientific theory, but in addressing some philosophical issues it is quite suggestive. 8. Conclusion. The theory I have presented is speculative, but it is a candidate theory. I suspect that the principles of structural coherence and organizational invariance will be planks in any satisfactory theory of consciousness. The status of the double aspect theory of information is less certain. Indeed, right now it is more of an idea than a theory. To have any hope of eventual explanatory success, it will have to be specified more fully and fleshed out into a more powerful form. Still, reflection on just what is plausible and implausible about it and on where it works and where it fails can only lead to a better theory. Most existing theories of consciousness either deny the phenomenon, explain something else, or elevate the problem to an eternal mystery. I hope to have shown that it is possible to make progress on the problem even while taking it seriously. To make further progress we will need further investigation, more refined theories, and more careful analysis. The hard problem is a hard problem, but there is no reason to believe that it will remain permanently unsolved. 9. Afterward, from moving forward on the problem of consciousness. There are two quite different ways in which a materialist might respond to the challenge in this chapter. One sort of response denies that on reflection there is a hard problem distinct from the easy problems, or at least holds that solving the easy problems, perhaps along with some philosophical reflection, suffices to solve the hard problem. Another accepts that there is a distinctive phenomenon that generates a distinctive hard problem that goes beyond the easy problems, but argues that it can be accommodated within a materialist framework all the same. To a first approximation, the first sort of view corresponds to what I call type A materialism in chapter 5, while the second sort corresponds to type B and type C materialism. The second sort of response is much more popular than the first, and I discuss it at some length in other chapters here, especially chapters 6 and 10. So in this afterword I take the opportunity to address the first sort of response, as put forward in articles responding to this chapter by Paul Chitchland, 1996, and Daniel Dennett, 1996. The type A materialist, more precisely, denies that there is any phenomenon that needs explaining, over and above accounting for the various functions. Once we have explained how the functions are performed, we have thereby explained everything. Sometimes type A materialism is expressed by denying that consciousness exists. More often, it is expressed by claiming that consciousness may exist, but only if the term consciousness is defined as something like reportability or some other functional capacity. Either way, it is asserted that there is no interesting fact about the mind in the vicinity that is conceptually distinct from the functional facts and that needs to be accommodated in our theories. Once we have explained how the functions are performed, that is that. This is an extremely counterintuitive position. At first glance, it seems to simply deny a manifest fact about us. But it deserves to be taken seriously. After all, counterintuitive theories are not unknown in science and philosophy. On the other hand, to establish a counterintuitive position, strong arguments are needed. And to establish a position as counterintuitive as this, one might think that extraordinarily strong arguments are needed. So what arguments do its proponents provide? A common strategy for a type A materialist is to deflate the hard problem by using analogies to other domains, where talk of such a problem would be misguided. Thus, Dennett imagines a vitalist arguing about the hard problem of life or a neuroscientist arguing about the hard problem of perception. Similarly, Paul Chitland imagines a 19th-century philosopher worrying about the hard problem of light. In these cases, we are to suppose, someone might once have thought that more needed explaining than structure and function, but in each case, science has proved them wrong. So perhaps the argument about consciousness is no better. This sort of argument cannot bear much weight, however. Pointing out that analogous arguments do not work in other domains is no news. The whole point of anti-reductionist arguments about consciousness is that there is a disanalogy between the problem of consciousness and problems in other domains. As for the claim that analogous arguments in such domains might once have been plausible, this strikes me as something of a convenient myth. In the other domains, it is more or less obvious that structure and function are what need explaining, at least once any experiential aspects are left aside, and one would be hard-pressed to find a substantial body of people who ever argued otherwise. When it comes to the problem of life, for example, it is just obvious that what needs explaining is structure and function. How does a living system self-organize? How does it adapt to its environment? How does it reproduce? Even the vitalists recognized this central point. Their driving question was always, how could a mere physical system perform these complex functions, not why are these functions accompanied by life? It is no accident that Dennett's version of a vitalist is imaginary. There is no distinct hard problem of life, and there never was one, even for vitalists. In general, when faced with the challenge explain X, we need to ask, what are the phenomena in the vicinity of X that need explaining, and how might we explain them? In the case of life, what cries out for explanation are phenomena such as reproduction, adaptation, metabolism, and self-sustenance, all complex functions. There is not even a plausible candidate for a further sort of property of life that needs explaining, leaving aside consciousness itself, and indeed there never was. In the case of consciousness, on the other hand, the manifest phenomena that need explaining are things such as discrimination, reportability, integration, the functions, and experience, so this analogy does not even get off the ground. If someone were to claim that something has been left out by reductive explanations of light, Paul Chitland's example, or of heat, an example used by Patricia Chitland 1997, what something might they be referring to? The only phenomenon for which the suggestion would be even remotely plausible is our subjective experience of light and hotness. The molecular theory of heat does not explain the sensation of heat, and the electromagnetic theory of light does not explain what it is like to see, and understandably so. The physicists explaining heat and light have quite reasonably deferred the explanation of their experiential manifestations until the time when we have a reasonable theory of consciousness. One need not explain everything at once. With consciousness itself, however, subjective experience is precisely what is at issue, so we cannot defer the question in the same way. So once again, the analogy is no help to a reductionist. Paul Chitland suggests that parallel anti-reductionist arguments could have been constructed for the phenomenon of luminescence and might have been found plausible at the time. I have my doubts about that plausibility, but in any case it is striking that his arguments about luminescence all depend on intuitions about the conscious experience of light. His hypothetical advocate of a hard problem about light appeals to light's visibility and the visual point of view, his advocate of a knowledge argument about light appeals to blind Mary, who has never had the experience of seeing, and the advocate of a zombie argument appeals to the conceivability of a universe physically just like ours but in which everything is dark. That the first two arguments trade on intuitions about experience is obvious, and even for the third, it is clear on a moment's reflection that the only way such a universe might make sense is as a universe in which the same electromagnetic transmission goes on but in which no one has the experience of seeing. Chitland might insist that by luminescence he means something quite independent of experience, which physical accounts still do not explain, but then the obvious reply is that there is no good reason to believe in luminescence in the first place. Light's structural, functional, and experiential manifestations exhaust the phenomena that cry out for explanation and the phenomena in which we have any reason to believe. By contrast, Conscious experience presents itself as a phenomenon to be explained and cannot be eliminated in the same way. So, analogies do not help. To have any chance of making the case, a type A materialist needs to argue that for consciousness, as for life, the functions are all that need explaining. Perhaps some strong, subtle, and substantive argument can be given, establishing that once we have explained the functions, we have automatically explained everything. If a sound argument could be given for this surprising conclusion, it would provide as valid a resolution of the hard problem as any. Is there any compelling, non-question begging argument for this conclusion? The key word, of course, is non-question begging. Often a proponent will simply assert that functions are all that need explaining, or will argue in a way that subtly assumes this position at some point, but that is clearly unsatisfactory. Prima facie, there is very good reason to believe that the phenomena that a theory of consciousness must account for include not just discrimination, integration, report, and other such functions, but also experience, and prima facie there is good reason to believe that the question of explaining experience is distinct from the questions about explaining the various functions. Such prima facie intuitions can be overturned, but to do so requires very solid and substantial argument. Otherwise, the problem is being resolved simply by placing one's head in the sand. Such arguments are not easy to find. Dennett is the one of the few philosophers who has attempted to give them, and his arguments are typically not extensive. In his response to this chapter, he spends about a paragraph making the case. I take it that this paragraph bears the weight of his piece, once the trimmings are stripped away. So it is this paragraph that we should examine. Dennett's argument here, interestingly enough, is an appeal to phenomenology. He examines his own phenomenology and tells us that he finds nothing other than functions that need explaining. The manifest phenomena that need explaining are his reactions and his abilities, nothing else even presents itself as needing to be explained. This is daringly close to a simple denial. One is tempted to agree that it might be a good account of Dennett's phenomenology, and it raises immediate questions. For a start, it is far from obvious that even all of the items on Dennett's list, feelings of foreboding, fantasies, delight and dismay, are purely functional matters. To assert without argument that all that needs to be explained about such things are the associated functions seems to beg the crucial question at issue. And if we leave these controversial cases aside, Dennett's list seems to be a systematically incomplete list of what needs to be explained in explaining consciousness. One's ability to be moved to tears and blithe disregard of perceptual details are striking phenomena, but they are far from the most obvious phenomena that I, at least, find when I introspect. Much more obvious are the experience of emotion and the phenomenal visual field themselves, and nothing Dennett says gives us reason to believe that these do not need to be explained, or that explaining the associated functions will explain them. What might be going on here? Perhaps the key lies in what has elsewhere been described as the foundation of Dennett's philosophy, third-person absolutism. If one takes the third-person perspective on oneself, viewing oneself from the outside, so to speak, these reactions and abilities are no doubt the main focus of what one sees. But the hard problem is about explaining the view from the first-person perspective. So to shift perspectives like this, even to shift to a third-person perspective on one's first-person perspective, which is one of Dennett's favorite moves, is again to assume that what needs explaining are functional matters such as reactions and reports, and so is again to argue in a circle. Dennett suggests subtract the functions and nothing is left. Again, I can see no reason to accept this, but in any case the argument seems to have the wrong form. An analogy suggested by Greg Rosenberg, in Conversation, is useful here. Color has properties of hue, saturation, and brightness. It is plausible that if one subtracts hue from a color, nothing phenomenologically significant is left, but this certainly does not imply that color is nothing but hue. So even if Dennett could argue that function were somehow required for experience, in the same way that hue is required for color, this would fall a long way short of showing that function is all that has to be explained. A slight flavor of non-circular argument is hinted at by Dennett's suggestion. I wouldn't know what I was thinking about if I couldn't identify them by their functional differentia. This tantalizing sentence suggests various interpretations, but all of the reconstructions that I can find fall short of making the case. If the idea is that functional role is essential to the subpersonal process of identification, this falls short of establishing that functioning is essential to the experiences themselves, let alone that functioning is all there is to the experiences. If the idea is rather that function is all we have access to at the personal level, this seems false and seems to beg the question against the intuitive view that we have knowledge of intrinsic features of experience. But if Dennett can elaborate this into a substantial argument, that would be a very useful service. In his paper, Dennett challenges me to provide independent evidence, presumably behavioral or functional evidence, for the postulation of experience. But this is to miss the point. Conscious experience is not postulated to explain other phenomena in turn, rather, it is a phenomenon to be explained in its own right. And if it turns out that it cannot be explained in terms of more basic entities, then it must be taken as irreducible, just as happens with categories such as space and time. Again, Dennett's challenge presupposes that the only explananda that count are functions. Tangentially, I would be interested to see Dennett's version of the independent evidence that leads physicists to introduce the fundamental categories of space and time. It seems to me that the relevant evidence is spatiotemporal through and through, just as the evidence for experience is experiential through and through. Dennett might respond that I, equally, do not give arguments for the position that something more than functions needs to be explained. There would be some justice here. While I do argue at length for my conclusions, all of these arguments take the existence of consciousness for granted, where the relevant concept of consciousness is explicitly distinguished from functional concepts such as discrimination, integration, reaction, and report. Dennett presumably disputes the starting point. He thinks that the only sense in which people are conscious is a sense in which consciousness is defined as reportability, as a reactive disposition, or as some other functional concept. But let us be clear on the dialectic. It is prima facie obvious to most people that there is a further phenomenon here. In informal surveys, the large majority of respondents, even at Tufts, indicate that they think something more than functions needs explaining. Dennett himself, faced with the results of such a survey, perhaps intending to deflate it, has accepted that there is at least a prima facie case that something more than functions needs to be explained, and he has often stated how radical and counterintuitive his position is. So it is clear that the default assumption is that there is a further problem of explanation. To establish otherwise requires significant and substantial argument. I would welcome such arguments in the ongoing attempt to clarify the lay of the land. The challenge for those such as Dennett is to make the nature of these arguments truly clear. I do not think it a worthless project. The hard problem is so hard that we should welcome all attempts at a resolution, but it is clear that anyone trying to make such an argument is facing an uphill battle. Part 2. The Science of Consciousness. 2. How can we construct a science of consciousness? In recent years there has been an explosion of scientific work on consciousness in cognitive neuroscience, psychology, and other fields. It has become possible to think that we are moving toward a genuine scientific understanding of conscious experience. But what is the science of consciousness all about, and what form should such a science take? This chapter gives an overview of the agenda. 1. First-person data and third-person data. The task of a science of consciousness, as I see it, is to systematically integrate two key classes of data into a scientific framework: third-person data, or data about behavior and brain processes, and first-person data, or data about subjective experience. When a conscious system is observed from the third-person point of view, a range of specific behavioral and neural phenomena present themselves. When a conscious system is observed from the first-person point of view, a range of specific subjective phenomena present themselves. Both sorts of phenomena have the status of data for a science of consciousness. 1. Third-person data concern the behavior and the brain processes of conscious systems. These behavioral and neurophysiological data provide the traditional material of interest for cognitive psychology and cognitive neuroscience. Where the science of consciousness is concerned, some particularly relevant third-person data are those concerning perceptual discrimination and those involving verbal reports. Direct measurements of brain processes also play a crucial role in cognitive neuroscience, of course. First-person data concern the subjective experiences of conscious systems. It is a datum for each of us that such experiences exist. We can gather information about them both by attending to our own experiences and by monitoring subjective verbal reports about the experiences of others. These phenomenological data provide the distinctive subject for the science of consciousness. Some central sorts of first-person data include those having to do with the following. Visual experiences, example the experience of color and depth. Other perceptual experiences, example auditory and tactile experience. Bodily experiences, example pain and hunger. Mental imagery, example recalled visual images. Emotional experience, example happiness and anger. A current thought, example the experience of reflecting and deciding. Both third-person data and first-person data need explanation. An example is provided by the case of musical processing. If we observe someone listening to music, relevant third-person data include those concerning the nature of the auditory stimulus, its effects on the ear and the auditory cortex of the subject, various behavioral responses by the subject, and any verbal reports the subject might produce. All of these third-person data need explanation, but they are not all that needs explanation. As anyone who has listened to music knows, there is also a distinctive quality of subjective experience associated with listening to music. A science of music that explained the various third-person data just listed but that did not explain the first-person data of musical experience would be a seriously incomplete science of music. A complete science of musical experience must explain both sorts of phenomena, preferably within an integrated framework. 2. Explaining the data. The problems of explaining third-person data associated with consciousness are among the easy problems of consciousness from the last chapter. The problem of explaining first-person data is the hard problem. In Chapter 1 we saw that, to explain third-person data, we need to explain the objective functioning of a system and can do so in principle by specifying a mechanism. When it comes to first-person data, however, this model breaks down. The reason is that first-person data, the data of subjective experience, are not data about objective functioning. Merely explaining the objective functions does not explain subjective experience. The lesson is that as data, first-person data are irreducible to third-person data and vice versa. That is, third-person data alone provide an incomplete catalog of the data that need explaining. If we explain only third-person data, we have not explained everything. Likewise, first-person data alone are incomplete. A satisfactory science of consciousness must admit both sorts of data and must build an explanatory connection between them. What form might this connection take? A common position holds that, although there are two sorts of data, we can explain first-person data wholly in terms of material provided by third-person data. For example, many think that we might wholly explain the phenomena of subjective experience in terms of processes in the brain. This position is very attractive, but in Chapter 1 I give reasons to be skeptical about it. Here I present a simple argument that encapsulates some reasons for doubt. 1. Third-person data are data about the objective structure and dynamics of physical systems. 2. Low-level, structure and dynamics explain only facts about, high-level, structure and dynamics. 3. Explaining structure and dynamics does not suffice to explain the first-person data. 4. First-person data cannot be wholly explained in terms of third-person data. Premise 1 captures something about the character of third-person data. These data always concern certain physical structures and their dynamics. Premise 2 says that explanations in terms of processes of this sort only explain further processes of that sort. There can be big differences between the processes, as when simple low-level structure and dynamics give rise to highly complex high-level structure and dynamics, In complex systems theory, for example, but there is no escaping the structural/dynamical circle. Premise 3 encapsulates the points discussed earlier, that explaining structure and dynamics is only to explain objective functions, and that to explain objective functions does not suffice to explain first-person data about subjective experience. From these three premises, the conclusion, 4, follows. 2. Of course, it does not follow that first-person data and third-person data have nothing to do with one another. There is obviously a systematic association between them. We have good reason to believe that subjective experiences are systematically correlated with brain processes and behavior. It remains plausible that whenever subjects have an appropriate sort of brain process, they will have an associated sort of subjective experience. We simply need to distinguish correlation from explanation. Even if first-person data cannot be wholly explained in terms of third-person data, the two sorts of data are still strongly correlated. It follows that a science of consciousness remains entirely possible. It is just that we should expect this science to take a non-reductive form. A science of consciousness will not reduce first-person data to third-person data, but it will articulate the systematic connections between them. Where there is systematic covariation between two classes of data, we can expect systematic principles to underlie and explain the covariation. In the case of consciousness, we can expect systematic bridging principles to underlie and explain the covariation between third-person data and first-person data. A theory of consciousness will ultimately be a theory of these principles. Of course, these foundational issues are controversial, and there are various alternative views. One class of views, example Dennett 1991, holds that the only phenomena that need explaining are those that concern objective functioning. The most extreme version of this view says that there are no first-person data about consciousness at all. A less extreme version of this view says that all first-person data are equivalent to third-person data, example about verbal reports, so that explaining these third-person data explains everything. Another class of views, example P.S. Chitchland 1997, accepts that first-person data need further explanation but holds that they might be reductively explained by future neuroscience. One version of this view holds that future neuroscience could go beyond structure and dynamics in ways we cannot currently imagine. Another version holds that if we can find sufficient correlations between brain states and consciousness, that will qualify as a reductive explanation. I argue against views of this sort in Chapter 5. In this chapter I focus on constructive projects for a science of consciousness. I will sometimes presuppose the reasoning sketched earlier, but much of what I say has application even to alternative views. 3 projects for a science of consciousness. If what I have said so far is correct, then a science of consciousness should take first-person data seriously and should proceed by studying the association between first-person data and third-person data without attempting a reduction. In fact, this is exactly what one finds in practice. The central work in the science of consciousness has always taken first-person data seriously. For example, much central work in psychophysics and perceptual psychology has been concerned with the first-person data of subjective perceptual experience. In research on unconscious perception, the first-person distinction between the presence and absence of subjective experience is crucial. In recent years, a growing body of research has focused on the correlations between first-person data about subjective experience and third-person data about brain processes and behavior. In what follows I articulate what I see as some of the core projects for a science of consciousness, with illustrations drawn from existing research. Project 1, explain the third-person data. One important project for a science of consciousness is that of explaining the third-person data in the vicinity, explaining the difference between functioning in sleep and wakefulness, for example, and explaining the voluntary control of behavior. This sort of project need not engage the difficult issues relating to first-person data, but it may still provide an important component of a final theory. One example of this sort of project is that of explaining binding in terms of neural synchrony, as discussed in the last chapter. It is not yet clear whether this hypothesis is correct, but if it is correct, it will provide an important component in explaining the integration of perceptual information, which in turn is closely tied to questions about consciousness. Of course, explaining binding will not on its own explain the first-person data of consciousness, but it may help us to understand the associated processes in the brain. Research on the global workspace hypothesis also falls into this class. Bars, 1988, has postulated such as a workspace as a mechanism by which shared information can be made available to many different cognitive processes. More recently, other researchers, example Dehenny and Changer 2004, have investigated the potential neural basis for this mechanism and postulated a neuronal global workspace. If this hypothesis is correct, it will help to explain third-person data concerning access to information within the cognitive system, as well as data about the information made available to verbal report. Again, explaining these processes will not in itself explain the first-person data of consciousness, but it may well contribute to the Project 4 later in this chapter, of finding neural correlates of consciousness. Project 2, Contrast conscious and unconscious processes. Many cognitive capacities can be exercised both consciously and unconsciously, that is, in the presence or absence of associated subjective experience. For example, the most familiar sort of perceptual processing is conscious, but there is also strong evidence of unconscious perceptual processing, Miracle and Daneman 2000. One finds a similar contrast in the case of memory, where the now common distinction between explicit and implicit memory, Shatter and Curran 2000, can equally be seen as a distinction between conscious and unconscious memory. Explicit memory is essentially memory associated with the subjective experience of the remembered information. Implicit memory is essentially memory in the absence of such a subjective experience. The same goes for the distinction between explicit and implicit learning, Reber 1996, which is in effect a distinction between learning in the presence or absence of relevant subjective experience. Conscious and unconscious processes provide pairs of processes that are similar in some respects from the third-person point of view. Example, both involve registration of perceptual stimuli, but differ from the first-person point of view. One involves subjective experience of the stimulus, one does not. Of course, there are also differences from the third-person point of view. For a start, a researcher's evidence for conscious processes usually involves a verbal report of a relevant experience, and evidence for unconscious processes usually involves a verbal report of the absence of a relevant experience. There are also less obvious differences between the behavioral capacities that go along with conscious and unconscious processes, as well as between the associated neural processes. These differences make for the beginning of a link between the first-person and third-person domains. For example, evidence suggests that, while unconscious perception of visually presented linguistic stimuli is possible, semantic processing of these stimuli seems limited to the level of the single word rather than complex expressions, see Greenwald 1992. By contrast, conscious perception allows for semantic processing of very complex expressions. Here, experimental results suggest a strong association between the presence or absence of subjective experience and the presence or absence of an associated functional capacity, a systematic link between first-person and third-person data. Many other links of the same sort can be found in the literature on unconscious perception, implicit memory, and implicit learning. Likewise, there is evidence for distinct neural bases for conscious and unconscious processes in perception. Appealing to an extensive body of research on visuomotor processing, Milner and Goodale, 1995, see also Goodale 2004, have hypothesized that the ventral stream of visual processing subserves conscious perception of visual stimuli for the purpose of the cognitive identification of stimuli, while the dorsal stream subserves unconscious processes involved in fine-grained motor capacities. If this hypothesis is correct, one can again draw a systematic link between a distinction in first-person data, presence or absence of conscious perception, and a distinction in third-person data, visual processing in the ventral or dorsal stream. A number of related proposals have been made in research on memory and learning. Project 3, investigate the contents of consciousness. Consciousness is not simply an on-off switch. Conscious experiences have a complex structure with complex contents. A conscious subject usually has a manifold of perceptual experiences, bodily sensations, emotional experiences, and conscious thoughts, among other things. Each of these elements may itself be complex. For example, a typical visual experience has an internal structure representing objects with many different colors and shapes in varying degrees of detail. We can think of all of this complexity as composing the contents of consciousness. The contents of consciousness have been studied throughout the history of psychology. Weber's and Fechner's pioneering work in psychophysics concentrated on specific aspects of these contents, such as the subjective brightness associated with a visual experience, and correlated it with properties of the associated stimulus. This provided a basic link between first-person data about sensory experience and third-person data about external stimuli. Later work in psychophysics and Gestalt psychology took an approach of the same general sort, investigating specific features of perceptual experience and analyzing how these co-vary with the properties of a stimulus. This tradition continues in a significant body of contemporary research. For example, research on visual illusions often uses subjects' first-person reports, and even scientists' first-person experiences, to characterize the structure of perceptual experiences. Research on attention, Mack and Rock 1998, Treisman 2003, aims to characterize the structure of perceptual experience inside and outside the focus of attention. Other researchers investigate the contents of consciousness in the domains of mental imagery, Bars 1996, emotional experience, Kuzniak 1998, and stream of conscious thought, Pope 1978, Hurlburt 1990. An important line of research investigates the contents of consciousness in abnormal subjects. For example, subjects with synesthesia have unusually rich sensory experiences. In a common version, letters and numbers trigger reports of extra color experiences, in addition to the standard perceived color of the stimulus. Recent research strongly suggests that these reports reflect the subject's perceptual experiences and not just cognitive associations. For example, Ramachandran and Hubbard, 2001, find that certain visual patterns produce a perceptual pop-out effect in synesthetic subjects that is not present in normal subjects. When first-person data about the experiences of abnormal subjects are combined with third-person data about brain abnormalities in those subjects, this yields a new source of information about the association between brain and conscious experience. Project 4, Find the neural correlates of consciousness. Thus leads us to what is perhaps the core project of current scientific research on consciousness, the search for neural correlates of consciousness, Metzinger 2000, Crick and Cook 2004. A neural correlate of consciousness, NCC, can be characterized as a minimal neural system that is directly associated with states of consciousness. See Chapter 3 for much more on this. Presumably the brain as a whole is a neural system associated with states of consciousness, but not every part of the brain is associated equally with consciousness. The NCC project aims to isolate relatively limited parts of the brain, or relatively specific features of neural processing, that correlate directly with subjective experience. It may be that there will be many different NCCs for different aspects of conscious experience. For example, it might be that one neural system is associated with being conscious as opposed to being unconscious, perhaps in the thalamus or brainstem, see example Schiff 2004, while another neural system is associated with the specific contents of visual consciousness, perhaps in some part of the visual cortex, and other systems are associated with the contents of consciousness in different modalities. Any such proposal can be seen as articulating a link between third-person data on brain processes and first-person data on subjective experience. In recent years, by far the greatest progress has been made in the study of NCCs for visual consciousness. Milner and Goodales, 1995, work on the ventral stream provides an example of this sort of research. Another example is the research of Nikos Logothetis and colleagues on binocular rivalry in monkeys, example Logothetis 1998, Leopold, Mayer, and Logothetis 2003. When different stimuli are presented to the left and the right eyes, subjects usually undergo alternating subjective experiences. Logothetis trained monkeys to signal such changes in their visual experience and correlated these changes with changes in underlying neural processes. The results indicate that changes in visual experience are only weakly correlated with changes in patterns of neural firing in the primary visual cortex. In this area, neural firing was more strongly correlated with the stimulus than with the experience. In contrast, changes in visual experience were strongly correlated with changes in patterns of neural firing in later visual areas, such as the inferior temporal cortex. These results tend to suggest that the inferior temporal cortex is a better candidate than the primary visual cortex as an NCC for visual consciousness. Of course, no single experimental result can provide conclusive evidence concerning the location of an NCC, but much evidence concerning the location of NCCs for vision has accumulated in the last few years, Cook 2004, and one can expect much more to come. If successful, this project will provide some highly specific connections between brain processes and conscious experiences. Project 5, Systematize the connection. To date, links between first-person data and third-person data have been studied in a somewhat piecemeal fashion. Researchers isolate correlations between specific aspects of subjective experience and specific brain processes or behavioral capacities in a relatively unsystematic way. This is to be expected at the current stage of development. We can hope that as the science develops, however, more systematic links will be forthcoming. In particular, we can hope to develop principles of increasing generality that link a wide range of first-person data with a correspondingly wide range of third-person data. For example, there might eventually be an account of the neural correlates of visual consciousness that will not only tell us which neural systems are associated with visual consciousness but will also yield systematic principles that tell us how the specific content of a visual experience covaries with the character of neural processes in these systems. A few principles of this sort have been suggested to date in limited domains. For example, Hobson, 1997, has suggested a general principle linking certain levels of neurochemical activity with different states of consciousness in wakefulness, sleep, and dreaming. It is likely that any such proposals will be heavily revised as new evidence comes in, but one can expect that in the coming decades increasingly well-supported principles of this sort will emerge. The possibility of such principles holds out the tantalizing prospect that eventually we might use them to predict features of an organism's subjective experience based on knowledge of its neurophysiology. Project 6, Infer Fundamental Principles. If the previous project succeeds, we will have general principles that connect third-person data and first-person data, but these general principles will not yet be fundamental. The principles might still be quite complex, and limited both to specific aspects of consciousness and to specific species. A science of consciousness consisting of wholly different principles for different aspects of consciousness and different species would not be entirely satisfactory. It is reasonable to hope that eventually some unity will be discovered behind this diversity. We should at least aim to maximize the generality and the simplicity of the relevant principles wherever possible. In the ideal situation, we might hope for principles that are maximally general in their scope, applying to any conscious system whatsoever and to all aspects of conscious experience. In addition, we might hope for principles that are relatively simple in their form in the way that the basic laws of physics appear to be simple. It is unreasonable to expect that we will discover principles of this sort anytime soon, and it is an open question whether we will be able to discover them at all. Currently, we have little idea what form such principles might take, notwithstanding the speculation at the end of Chapter 1. Still, if we can discover them, principles of this sort would be candidates for fundamental principles, the building blocks of a fundamental theory of consciousness. If what I said earlier is correct, then something about the connection between first-person data and third-person data must be taken as primitive, just as we take fundamental principles in physical theories as primitive. But we can at least hope that the primitive element in our theories will be as simple and as general as possible. If, eventually, we can formulate simple and general principles of this sort, based on an inference from accumulated first-person and third-person data, we could be said to have an adequate scientific theory of consciousness. What would this entail about the relationship between physical processes and consciousness? The existence of such principles is compatible with different philosophical views. One might regard the principles as laws that connect two fundamentally different domains. One might regard them as laws that connect two aspects of the same thing. Or one might regard them as grounding an identification between properties of consciousness and physical properties. Such principles could also be combined with different views of the causal relation between physical processes and consciousness. These matters are all discussed further in Chapter 5, but for many purposes, the science of consciousness can remain neutral on these philosophical questions. One can simply regard the principles as principles of correlation while staying neutral on their underlying causal and ontological status. This makes it possible to have a robust science of consciousness even without having a widely accepted solution to the philosophical mind/body problem. 4 obstacles to a science of consciousness. The development of a science of consciousness as I have presented it thus far may sound remarkably straightforward. We simultaneously gather first-person data about subjective experience and third-person data about behavior and brain processes, isolate specific correlations between them, formulate general principles governing these correlations, and infer the underlying fundamental laws. But of course it is not as simple as this in practice. There are a number of serious obstacles to this research agenda. The most serious obstacles concern the availability of the relevant data in both the third-person and first-person domains. In what follows I discuss a few of these obstacles. Obstacles involving third-person data. The third-person data relevant to the science of consciousness include both behavioral and neural data. The availability of behavioral data is reasonably straightforward. One is constrained only by the ingenuity of the experimenter and the limitations of experimental contexts. In practice, researchers have accumulated a rich body of behavioral data relevant to consciousness. In contrast, the availability of neural data is much more constrained by technological and ethical limitations, and the body of neural data that has been accumulated to date is correspondingly much more limited. In practice, the most relevant neurophysiological data come from 2 or 3 sources: brain imaging via functional magnetic resonance imaging, fMRI, and positron emission tomography, PET, technology, single-cell recording through insertion of electrodes, and surface recording through electroencephalographs, EEG, and magnetoencephalography, MEG. Each of these technologies is useful, but each has serious limitations for the science of consciousness. Both EEG and MEG have well-known limitations in spatial localization. Brain imaging through fMRI and PET is better in this regard, but these methods are still spatially quite coarse-grained. Single-cell recording is spatially fine-grained but is largely limited to experimentation on non-human animals. These limitations apply to all areas of cognitive neuroscience, but they are particularly pressing for the science of consciousness because the science of consciousness relies on gathering third-person and first-person data simultaneously. By far the most straightforward method for gathering first-person data is verbal report, but verbal report is limited to human subjects. By far the most useful third-person data are data at the level of single neurons, where one can monitor representational content that correlates with the content of consciousness. Example, when one monitors a neuron with a specific receptive field, as discussed in Chapter 3, but these experiments are largely limited to non-human subjects. As a result, it is extremely difficult to discover strong associations between first-person data and corresponding neural data with current techniques. There have been numerous ingenious attempts to circumvent these limitations. The best known include Logothetes's experiments on monkeys, in which the animals are trained extensively to provide a substitute for a verbal report of visual consciousness by pressing a bar. Research on blind sight in monkeys by Cowie and Stoerig, 1995, has done something similar. Still, the very fact that researchers have to go to such great lengths in order to gather relevant neural data illustrates the problem. Others have performed neuron-level measurements on human surgical patients, example Kraemen, Fried, and Cook 2002, but there are obvious practical limitations here. Many others, example Rees 2004, have tried to get as much relevant information as they can from the limited resources of brain imaging and surface recording. Nevertheless, fewer deep correlations have emerged from this sort of work than from neuron-level studies. One can hope that this is a temporary limitation imposed by current technology. If a technology is eventually developed that allows for non-invasive monitoring of neuron-level processes in human subjects, we might expect a golden age for the science of consciousness to follow. Obstacles involving first-person data. Where the availability of first-person data is concerned, a number of related obstacles run quite deep. I discuss 3 of these here. 1. Privacy. The most obvious obstacle to the gathering of first-person data concerns the privacy of such data. In most areas of science, data are intersubjectively available, they are equally accessible to a wide range of observers. But in the case of consciousness, first-person data concerning subjective experiences are directly available only to the subject having those experiences. To others, these first-person data are only indirectly available, mediated by observation of the subject's behavior or brain processes. Things would be straightforward if we had a consciousness meter, discussed in the next chapter, that could be pointed at a subject and reveal his or her subjective experiences to all. But in the absence of a theory of consciousness, no such consciousness meter is available. This imposes a deep limitation on the science of consciousness, but it is not a paralyzing limitation. For a start, subjects have direct access to first-person data concerning their own conscious experiences. We could imagine that Robinson Crusoe on a desert island, equipped with the latest brain imaging technology, could make considerable progress toward a science of consciousness by combining this technology with first-person observation. More practically, each of us has indirect access to first-person data concerning others' experiences by relying on behavioral indicators of these data. In practice, by far the most common way of gathering data on the conscious experiences of other subjects is to rely on their verbal reports. Here, one does not treat the verbal reports just as third-person data, as a behaviorist might, limiting the datum to the fact that a subject made a certain noise. Rather, one treats the report as a report of first-person data that are available to the subject. Just as a scientist can accumulate third-person data by accepting reports of third-person data gathered by others, rather than simply treating those reports as noises, a scientist can also gather first-person data by accepting reports of first-person data gathered by others. This is the typical attitude that researchers adopt toward experimental subjects. If there is positive reason to believe that a subject's report might be unreliable, a researcher will suspend judgment about it. But in the absence of any such reason, researchers will take a subject's report of a conscious experience as good reason to believe that the subject is having a conscious experience of the sort that the subject is reporting. In this way, researchers have access to a rich trove of first-person data that is made intersubjectively available. Of course, our access to these data depends on our making certain assumptions, in particular, the assumption that other subjects really are having conscious experiences and that by and large their verbal reports reflect these conscious experiences. We cannot directly test this assumption, instead, it serves as a sort of background assumption for research in the field. But this situation is present throughout other areas of science. When physicists use perception to gather information about the external world, for example, they rely on the assumption that the external world exists and that perception reflects the state of the external world. They cannot directly test this assumption, instead, it serves as a sort of background assumption for the whole field. Still, it seems a reasonable assumption to make, and it makes the science of physics possible. The same goes for our assumptions about the conscious experiences and verbal reports of others. These seem to be reasonable assumptions to make, and they make the science of consciousness possible. Of course, verbal reports have some limits. Some aspects of conscious experience, example the experience of music or of emotion, are very difficult to describe. In these cases we may need to develop a more refined language. What is more, verbal reports cannot be used at all in subjects without language, such as infants and non-human animals. In these cases, one needs to rely on other behavioral indicators, as when logothetis relies on a monkey's bar pressing. These indicators require further assumptions. For example, logothetis's work requires both the assumption that monkeys are conscious and the assumption that visual stimuli that the monkey can exploit in the voluntary control of behavior are consciously perceived. These assumptions appear reasonable to most people, but they go beyond those required in the case of verbal report. The farther we move away from the human case, the more questionable the required assumptions become. For example, it would be very difficult to draw conclusions about consciousness from experiments on insects. Still, verbal reports in humans, combined with behavioral indicators in primates, give researchers enough access to first-person data to enable a serious body of ongoing research. 2. Methodology. A second obstacle is posed by the fact that our methods for gathering first-person data are quite primitive compared with our methods for gathering third-person data. The latter have been refined by years of scientific practice, but the former have not received nearly as much attention. Where simple first-person data are concerned, this problem is not too pressing. There is usually no great difficulty in determining whether one is having an experience of a certain color in the center of one's visual field, for example. Where more subtle aspects of subjective experience are concerned, however, the obstacle arises quickly. Even with a phenomenon as tangible as visual experience, the issue arises in a number of ways. Visual experiences as a whole usually have a rich and detailed structure, for example, but how can subjects investigate and characterize that detail? Most subjects have great difficulty in introspecting and reporting this detail more than superficially. Particular difficulties arise in investigating the character of consciousness outside attention. To introspect and report this structure would seem to require attending to the relevant sort of experience, which may well change the character of the experience. Here we can expect that at least some progress can be made by developing better methods for the gathering of first-person data. It may be reasonable to pay attention to traditions where the study of experience has been explored in detail. These traditions include those of Western phenomenology, introspectionist psychology, and even Eastern meditative traditions. Even if one is skeptical of the theories put forward by proponents of these traditions, one might still benefit from attending to their data-gathering methods. This research strategy has been pursued most notably in the neurophenomenology of Francisco Varela and colleagues, Varela 1997, Lutz et al. 2002, in which neurophysiological investigation is combined with phenomenological investigation in the tradition of Husserl. A number of other attempts at refining first-person methods are discussed in the papers collected in Varela and Scheer, 2001. Of course, any method has limitations. Subjects' judgments about their subjective experiences are not infallible, and although training may help, it also introduces the danger that observations may be corrupted by theory. The introspectionist program of experimental psychology in the 19th century famously fell apart when different schools could not agree on the introspective data, Boring 1929. Still, our ambitions need not be as grand as those of the introspectionists. For now, we are not aiming for a perfect characterization of the structure of consciousness but simply for a better characterization. Furthermore, we are now in a position where we can use third-person data as a check on first-person investigation. Experimental investigation has helped us to distinguish circumstances in which first-person reports are unreliable from those in which they are more reliable, Schooler and Fiore 1997, and there is room for much more investigation of this sort in the future. So it is reasonable to hope that at least a modest refinement of our methods for the reliable investigation of first-person data will be possible. 3 Formalisms. A final obstacle is posed by the absence of general formalisms with which first-person data can be expressed. Formalisms are important for two purposes. First, they are needed for data gathering. It is not enough to simply know what one is experiencing, one also has to write it down. Second, they are needed for theory construction. To formulate principles that connect first-person data with third-person data, we need to represent the data in a way that such principles can exploit. The main existing formalisms for representing first-person data are quite primitive. Researchers typically rely either on simple qualitative characterizations of data, as in an experience of red in the center of the visual field, or on simple parameterization of data, as when color experiences are parameterized by hue, saturation, and brightness. These simple formalisms suffice for some purposes, but they are unlikely to suffice for the formulation of systematic theories. It is not at all clear what form a proper formalism for the expression of first-person data about consciousness should take. The candidates include, 1. Parametric formalisms, in which various specific features of conscious experience are isolated and parameterized, as in the case of color experience. 2. Geometric and topological formalisms, in which the overall structure of an experience, such as a visual experience, is formalized in geometric or topological terms. 3. Informational formalisms, in which one characterizes the informational structure of an experience, specifying it as a sort of pixel-by-pixel state that falls into a larger space of informational states. And 4. Representational formalisms, in which one characterizes an experience by using language for the states of the world that the experience represents. One might characterize an experience as of a yellow cup, for example. While each of these formalisms may have limitations, a detailed study of various alternative formalisms is likely to have significant benefits. 5. Conclusion. Overall, the prospects for a science of consciousness are reasonably bright. There are numerous clear projects for a science of consciousness that take first-person data seriously. One can recognize the distinctive problems that consciousness poses and still do science. Of course, there are many obstacles, and it is an open question how far we can progress. But the last 10 years have seen many advances, and the next 50 years will see many more. For now, it is reasonable to hope that we may eventually have a theory of the fundamental principles that connect physical processes to conscious experience. Afterward, first-person data and first-person science. The very idea of first-person data and of first-person methods in science makes some philosophers and scientists queasy. A common reaction is to say that first-person data are private, and science is public, so first-person data cannot be part of science. 3. Now, demarcation disputes over what counts as science are usually verbal and sterile. What matters is whether we have good reasons to accept certain conclusions, not whether those reasons count as scientific reasons. Still, it is worth noting that first-person data are private only in a very limited sense, one that is compatible with the most important elements of the publicity of science. The sense in which first-person data are private is that a given datum that concerns the experience of a given subject is directly accessible only to one person, that subject. Still, that datum will be indirectly accessible to many others. For example, when it is expressed through verbal report, I experienced a small cross inside a large circle. So first-person data are certainly communicable in the way that scientific data are required to be. One might worry that, for scientific purposes, an individual datum should be jointly observable by many parties, but this requirement is largely irrelevant to the ordinary practice of science. One does not standardly require 5 scientists to crowd around the same oscilloscope. Rather, what matters for publicity is that data be replaceable. If someone reports a datum, from observing an oscilloscope or an animal for example, we expect that others will be able to observe other data of the same sort, using their own oscilloscopes or looking at different animals of the same species. That is publicity enough for the purposes of science. First-person data can straightforwardly have this sort of publicity. Experiments on consciousness typically have many subjects reporting data of the same sort. In many cases, scientists can replicate the first-person data in their own case by direct observation. Indeed, this is standard practice in the field of psychophysics. To be convinced of the reality of a putative illusion, for example, scientists just need to experience it for themselves. Even when this sort of direct validation is not possible, say, because the data pertain to a group to which the scientist does not belong, it is usually straightforward to cross-validate observations with reports from many subjects. As in any science, occasional one-off observations involve unique or hard-to-replicate conditions. In these cases, as in any science, the putative observation need not be ignored, but one will be more cautious about its use. So first-person data appear to be quite compatible with scientific methods. Of course, there are cases in which the privacy of first-person data poses a much more serious obstacle. In many cases involving infants, machines, and non-human animals, any first-person data cannot easily be communicated to others. Because of this, theorists cannot be said to have access to these data. This situation is akin to the situation in the historical sciences, such as evolutionary biology, in which there were data accessible in the past to which current scientists do not have access. This means that the availability of data is limited, making the science more difficult. Still, in all of these cases, we have access to enough data concerning the present, in the historical case, data concerning human experience, in the case of consciousness, that one can build a reasonably robust science all the same. Daniel Dennett responds to the ideas in an early version of this chapter, and to related claims by Alvin Goldman, in an article called The Fantasy of First-Person Science, 2001. Where Goldman and I think a science of consciousness needs to explain both third-person and first-person data, Dennett thinks that explaining the third-person data is enough. Once we have explained these, including verbal reports, we have explained everything. This is Dennett's method of heterophenomenology. A key idea is that taking verbal reports to be the explananda turns apparently irreducible first-person data into straightforwardly explicable third-person data. The obvious objection to Dennett's method is that the science of consciousness is not primarily about verbal reports or even about introspective judgments. It is about the experiences that the reports and judgments are reports and judgments of. Explaining our reports and judgments may be useful for many purposes, but to explain our reports and judgments is not to explain experience. Dennett's central argument for heterophenomenology proceeds by making a case that heterophenomenology is guaranteed to be at least as good a guide to first-person data as first-person phenomenology. In cases where reports about consciousness go wrong, introspection will also go wrong, so heterophenomenology misses nothing that first-person phenomenology covers. This way of proceeding mislocates the debate, however. The central problem with heterophenomenology has nothing to do with the fallibility of reports. Even if reports were infallible, the same problem would arise. To explain reports is not to explain the experiences that the reports are reports of. Dennett says that my view requires a non-neutral attitude toward a subject's reports, taking them uncritically as a guide to their subject matter. And he says that scientists have to take a neutral attitude, taking reports themselves as data but making no claims about their truth, because reports can go wrong. But this misses the natural intermediate option that Max Velmans, 2007, has called critical phenomenology: accept verbal reports as a prima facie guide to a subject's conscious experience except where there are specific reasons to doubt their reliability. Critical phenomenology seems to capture most scientists' attitudes toward verbal reports and consciousness. The attitude is not uncritical acceptance, but it is also far from the neutrality of heterophenomenology. On this view, we do not treat reports merely as data to be explained in their own right, though we might regard them in this way for some purposes. Rather, we are interested in them as a fallible guide to the first-person data about consciousness that we really want to explain. This way of thinking about the phenomena accommodates a major role for reports while preserving the distinction between explaining the reports and third-person data in general, and explaining the experiences, first-person data, that they are reports of. The issue is clouded just a little by Dennett's occasional blurring of the line between heterophenomenology and critical phenomenology. At one point in his reply to Goldman, he appears to allow that researchers on blind sight can give prima facie credence to subjects' claims that they have no experience in a given area as long as they do not give the subjects infallible authority. Clearly, to adopt this attitude would be to give up on the strict neutrality of heterophenomenology and to move beyond treating verbal reports and introspective judgments as mere third-person data. But I think Dennett's attitude is best captured by the suggestion that researchers are analogous to anthropologists listening to subjects' folk tales. They play along to obtain the subject's judgments without ever accepting them, unless those judgments are later validated by an independent investigation. It is clear that this anthropological attitude is not the attitude of most researchers toward blind sight subjects. Even in the absence of a good theory of blind sight, the results are generally taken to be very strong, although not infallible, evidence for a conclusion concerning visual experience. The conclusion is not just that the subjects judge that they do not visually experience objects in a part of their visual field, it is that subjects do not visually experience objects in a part of their visual field. Likewise, in psychophysics, experiments are usually taken to be strong evidence not just that subjects judge that they visually experience a certain illusion but also that they visually experience a certain illusion. Dennett may be right that the anthropological attitude is the typical attitude of researchers toward subjects' reports about their cognitive mechanisms about whether they rotated a mental image using mechanisms of symbolic representations or analog imagery, for example. But when it comes to reports about experience, by far the most common attitude is non-neutral. Reports are given prima facie credence as a guide to conscious experience. Another relevant illustration is provided by the debate about unconscious perception among cognitive psychologists. A central part of this debate has concerned precisely which third-person measures, direct report, discrimination, etc., are the best guide to the presence and absence of conscious perception. Here, third-person data are being used as a fallible guide to first-person data about consciousness, which are of primary interest. Given the heterophenomenological view, this debate is without much content. Some states subserve report, some subserve discrimination, and that is about all there is to say. I think that something like this is Dennett's attitude toward those debates, but it is not the attitude of most of the scientists working in the field. Dennett makes something of the fact that his method appeals to a subject's beliefs rather than just to reports, but the same issues arise. On Dennett's account of beliefs, to believe that such and such is roughly to be disposed to report that such and to behave in appropriate ways, and to explain such beliefs is in large part to explain the associated dispositions. If one takes this view of beliefs, everything I have said earlier applies to beliefs, as well as to reports. Explaining the beliefs does not suffice to explain the experiences. If one does not take this view, it is no longer obvious that third-person methods can explain our specific beliefs about consciousness, as these beliefs may themselves have a phenomenal element. See Chapter 9 for much more on this. Dennett challenges me to name an experiment that transcends the heterophenomenological method, but of course both views can accommodate experiments equally. For any experiment in which I say that we are using a verbal report or an introspective judgment as a guide to first-person data, Dennett can say that we are using it as third-person data and vice versa. So the difference between the views does not lie in the range of experiments compatible with them. Rather, it lies in a philosophical difference concerning the way that experimental results are interpreted. Should verbal reports be seen as reports of data about the subject's experience or just as data points to be explained in their own right? In any case, the fundamental reasons for rejecting the heterophenomenological view lie prior to these questions about experiments. The fundamental question is, does explaining behavior and other third-person data suffice on its own to explain conscious experience? I think there are overwhelming grounds to say no, as argued in the previous chapter and in the response to Dennett there. The question is then, given that this is so, can there be a science of consciousness anyway? The answer provided by this chapter is yes, as long as we accept that science can deal with first-person data and as long as we allow that verbal reports and the like can be used as an indirect guide to the first-person data about consciousness. Given this basic orientation, we can see the role of verbal reports in the science of consciousness as analogous to the role of perceptual experiences and perceptual judgments in ordinary third-person science. Roughly speaking, verbal reports stand to others' experiences as our own perceptual experiences stand to the external world. Suppose a physicist sees an object in a certain location and judges it to be in that location. One could take the anthropological view that the datum to be explained here is always just the perceptual experience or the perceptual judgment. Then one's science would be a science of explaining experiences and judgments, and the external world hypothesis would be one hypothesis among many that are competing with various skeptical hypotheses to explain the data. Alternatively, one could take the attitude that the datum to be explained here is that the object is in the location. Then skeptical hypotheses will not really be on the table when doing the science, and instead the competition will be among different physical hypotheses for explaining the external datum. Whatever the merits of the two views, the second corresponds to the way that science is usually practiced. On this view, perceptual states themselves do not exhaust the data. Rather, the states of affairs that they report, or represent, are taken as data. It is not unquestioned that perception is accurate. If there are conflicts among the apparent data or specific reasons to believe that perception may be unreliable, then one might retreat to taking the experiences and judgments as data in a given case and look for alternative explanations. But in the absence of positive reasons to question these data, one takes for granted that perception functions as a guide to the external world. Doing this enables science to proceed, even in the absence of decisive rejoinders to skeptical worries about the external world. Likewise, in the science of consciousness, verbal reports do not exhaust the data. Rather, the states of affairs that they report are taken as data. It is not unquestioned that introspection is accurate. If there are conflicts among the apparent data or specific reasons to believe that introspection may be unreliable, then one might retreat to taking the reports and judgments as data in a given case and look for alternative explanations. But in the absence of positive reasons to question these data, one takes for granted that introspection and report function as a guide to consciousness. Doing this enables the science of consciousness to proceed, even in the absence of decisive rejoinders to skeptical worries about other minds. One might say that just as a certain degree of trust in perception is a precondition for the science of physics, a certain degree of trust in introspection is a precondition for the science of consciousness. Of course, in both cases one would also like to have some reason to believe that this trust is reasonable, over and above the pragmatic justification that the science does not work as well without it. Here we enter familiar philosophical territory. For example, one might try to discredit skeptical hypotheses concerning the external world on the grounds that they are more complex than alternative explanations, or in some other way, see Chapter 13 for my own take on this issue, and one might try to discredit skeptical hypotheses concerning other minds in analogous ways. I think that the best justification here may come from abduction from regularities observed in one's own case. Such philosophical justifications for ordinary practices are almost invariably partial and questionable. Still, the science seems to go on successfully all the same. From this perspective, the most worrying obstacle for the science of consciousness comes from specific reasons to doubt the accuracy of introspection even in one's own case. It is well known that the introspective approach to psychology a century ago collapsed in part because of disagreement about the putative data. Most famously, some theorists discerned an experience of imageless thought where others did not. A number of disagreements of this sort can still be found among scientists and philosophers today, and there is good reason to believe that introspection is very far from infallible. Schwitzgebel, 2008, among others, has used considerations of this sort to cast doubt on the possibility of a science of consciousness. Still, we can distinguish hard cases from easy cases. Just as we can isolate conditions under which we have specific reason not to trust perception, We can also isolate conditions under which we have specific reason not to trust introspection. There are good reasons for worrying about introspection of nonsensory experience, of consciousness outside attention, and so on, but these reasons do not obviously extend to core sensory experiences within the focus of attention. When a normal subject claims to experience a vivid red square, for example, there is usually little reason to disbelieve the subject. And it is experiences of this sort that are the bread and butter of the current science of consciousness. So for now, the science of consciousness is making considerable progress by focusing largely on these easy cases, and there is reason to believe that there will be much more progress ahead. Progress of that sort could well yield the core of a fruitful theory of consciousness. Eventually the science of consciousness will have to say something about the hard cases, too. New methods might well be required then, and it is difficult to know how far things will go. But in the meantime, one can predict that the science of consciousness will continue to thrive. 3. What is a neural correlate of consciousness? 1. Introduction. In this chapter and the next I discuss the role that neuroscience plays in the search for a theory of consciousness. Even if neuroscience cannot solve all of the problems of consciousness single-handedly, it unquestionably has a major role to play. Recent years have seen striking progress in neurobiological research bearing on the problems of consciousness. The conceptual foundations of this sort of research, however, are only beginning to be laid. In these chapters I look at some of the things that are going on, from a philosopher's perspective, and try to say something helpful about these foundations. The cornerstone of recent work in the neuroscience of consciousness has been the search for the neural correlate of consciousness. This phrase is intended to refer to the neural system or systems primarily associated with conscious experience. The associated acronym is NCC. The hypothesis is that all of us have an NCC inside our head. The project is to find out what the NCC is. In recent years there have been quite a few proposals about the identity of the NCC. One of the most famous ones is Crick and Koch's 1990 suggestion that the neural basis of consciousness involves 40 Hz neural oscillations. That proposal has lost some favor since then, but many other suggestions have surfaced. The picture is almost reminiscent of particle physics, which now involves so many different sorts of particles that people talk about the particle zoo. In studying consciousness, one might talk about the neural correlate zoo. Here are a few proposals that have been put forward. 1. 40 Hz oscillations in the cerebral cortex, Crick and Koch 1990. Intralaminar nuclei in the thalamus, Bogan 1995a. Reentrant loops in thalamocortical systems, Edelman 1989. 40 Hz rhythmic activity in thalamocortical systems, Linus et al. 1994. Extended reticular thalamic activation system, Newman 1997. Neural assemblies bound by NMDA, Floor 1995. Certain neurochemical levels of activation, Hobson 1997. Certain neurons in the inferior temporal cortex, Scheinberg and Logothetis 1997. Neurons in the extrastriate visual cortex projecting to prefrontal areas, Crick and Koch 1995. Visual processing within the ventral stream, Milner and Goodale 1995. This work raises a number of difficult conceptual and foundational issues. I can see at least 5 foundational questions in the vicinity. 1. What do we mean by consciousness? 2. What do we mean by neural correlate of consciousness? 3. How can we find the neural correlate, S, of consciousness? 4. What will a neural correlate of consciousness explain? 5. Is consciousness reducible to its neural correlate, S? The first 2 questions here are conceptual questions, the third is an epistemological or methodological question, the fourth is an explanatory question, and the fifth is an ontological question. The first, fourth, and fifth are versions of general questions that philosophers have discussed for a long time, and I give my own view on them elsewhere in this book. The second and third questions are more specific to the NCC investigation. I focus on the second question in this chapter and on the third question in the following chapter. What does it mean to be a neural correlate of consciousness? At first glance, the answer might seem to be so obvious that the question is hardly worth asking. An NCC is just a neural state that directly correlates with a conscious state or that directly generates consciousness or something like that. One might have a simple image: when your NCC is active, your consciousness turns on correspondingly. But a moment's reflection suggests that this idea is not completely straightforward and that the concept needs some clarification. Here I undertake a little conceptual spadework in clarifying the concept of an NCC. This may not be the deepest problem in the area, but if we are looking for an NCC, it makes sense to get clear on what we are looking for. On the way I touch on some of the empirical work in the area and see what concept of NCC is at play in some of the central research. I also draw some consequences for the methodology of empirical work in the search. Most of this is intended as a first step rather than a last word. Much of what I say will need to be refined, but I hope at least to draw attention to some interesting issues in the vicinity. Two states of consciousness. As a first pass, we can use the definition of a neural correlate of consciousness given in the program of the 1998 Conference of the Association for the Scientific Study of Consciousness on Neural Correlates of Consciousness, where this chapter was first presented. This definition says that a neural correlate of consciousness is a specific system in the brain whose activity correlates directly with states of conscious experience. This yields something like the following. A neural system N is an NCC if the state of N correlates directly with states of consciousness. There are at least two things to get clear on here. First, what are the relevant states of consciousness? Second, what does it mean for a neural state to correlate directly with states of consciousness? I look into both of these things in turn. The states of consciousness we are concerned with here are all states of subjective experience, or equivalently, states of phenomenal consciousness. But what sorts of states of consciousness are relevant? In the NCC literature I can see a few different classes of states that are sometimes considered. Being conscious. The first option is that the states in question are just those of being conscious and of not being conscious. The corresponding notion of an NCC will be that of a neural system whose state directly correlates with whether a subject is conscious or not. If the NCC is in a particular state, the subject will be conscious. If the NCC is not in that state, the subject will not be conscious. This is perhaps the idea that first comes to mind when we think about an NCC. We might think about it as the neural correlate of creature consciousness, where creature consciousness is the property a creature has when it is conscious and lacks when it is not conscious. Although this is an interesting notion, it does not seem to capture the sort of NCC that most work in the area is aimed at. As we will see, most of the current work is aimed at something more specific. Some ideas can be taken as aiming at least in part at this notion, though. For example, Bogan's, 1995a, ideas about the intralaminar nucleus seem to be directed at least in part at this sort of NCC. Examining current work, we find that insofar as there is any consensus at all about the location of this sort of NCC, the dominant view seems to be that it should be in or around the thalamus, or at least that it should involve interactions between the thalamic and cortical systems in a central role. Penfield, 1937, argued that the indispensable substratum of consciousness lies outside the cerebral cortex and probably lies in the diencephalon, thalamus, hypothalamus, subthalamus, epithalamus. This theme has been taken up in recent years by Bogan, Newman, and Bars, 1993, and others. 2. Background state of consciousness. A related idea is that of the neural correlate of what we might call the background state of consciousness. A background state is an overall state of consciousness such as being awake, being asleep, dreaming, or being under hypnosis. Exactly what counts as a background state is not entirely clear, as one can divide things up in a number of ways and with coarser or finer grains, but presumably the class will include a range of normal and of altered states. We can think of this as a slightly more fine-grained version of the previous idea. Creature consciousness is the most coarse-grained background state of consciousness, it is just the state of being conscious. Background states will usually be more fine-grained than this, but they still will not be defined in terms of specific contents or modalities. A neural correlate of the background state of consciousness, then, will be a neural system N such that the state of N directly correlates with whether a subject is awake, dreaming, under hypnosis, and so on. If N is in state 1, the subject is awake; if N is in state 2, the subject is dreaming; if N is in state 3, the subject is under hypnosis, and so on. It may well be that some of the thalamocortical proposals discussed earlier are intended as or might be extended into proposals concerning this sort of NCC. A more direct example is given by Hobson's, 1997, Ideas about Neurochemical Levels of Activation. Hobson holds that these levels can be grouped into a three-dimensional state space and that different regions in this space correspond to different overall states of consciousness, wakefulness, REM sleep, non-REM sleep, and so on. When chemical levels are in a particular region in this space, the subject will be awake; when in another region, the subject will be in REM sleep, and so on. On this reading, one might see the neurochemical system as an NCC of the sort characterized earlier, with the different regions in state space corresponding to correlates of the various specific background states. 3. Contents of consciousness. There is much more to consciousness than the mere state of being conscious or the background state of consciousness. Arguably the most interesting states of consciousness are specific ones, the fine-grained states of subjective experience that one is in at any given time. These might include the experience of a particular visual image, of a particular sound pattern, of a detailed stream of conscious thought, and so on. A detailed visual experience, for example, might include the experience of certain shapes and colors in one's environment, of specific arrangements of objects, of various relative distances and depths, and so on. Specific states like these are most often individuated by their content. Most conscious states seem to have some sort of specific representational content that represents the world as being one way or another. Much of the specific nature of a visual experience, for example, can be characterized in terms of content. A visual experience typically represents the world as containing various shapes and colors, as containing certain objects standing in certain spatial relations, and so on. If the experience is veridical, the world will be the way the experience represents it as being. If the experience is an illusion or is otherwise misleading, the world will be other than the experience represents it as being. Either way, however, it seems that visual experiences typically have detailed representational content. The same goes for experiences in other sensory modalities and arguably for many or most non-sensory experiences as well. Much of the most interesting work on NCCs is concerned with states like these. This is work on the neural correlates of the contents of consciousness. Much of the work on the neural correlates of visual consciousness has this character, for example. This work is not concerned merely with the neural states that determine that one has visual consciousness, it is concerned with the neural states that determine the specific contents of visual consciousness. A nice example is supplied by the work of Logothetis and colleagues on the NCC of visual consciousness in monkeys, Logothetis and Schall 1989, Leopold and Logothetis 1996, Scheinberg and Logothetis 1997. In this work, discussed briefly in Chapter 2, a monkey is trained to press various bars when it is confronted with various sorts of images, horizontal and vertical gratings, for example, or gratings drifting left and right, or faces and sunbursts. Let us use horizontal and vertical gratings for the purposes of illustration. After training is complete, the monkey is presented with two stimuli at once, one to each eye. In humans, this usually produces binocular rivalry, with alternating periods of experiencing a definite image and occasionally partial overlap. The monkey responds by pressing bars, in effect telling the experimenter what it is seeing, a horizontal grating, a vertical grating, or an interlocking grid. At the same time, neurons in the monkey's cortex are being monitored by electrodes. It is first established that certain neurons respond to certain stimuli, to horizontal lines, for example, or to flowers. Then these neurons are monitored in the binocular rivalry situation to see how well they correlate with what the monkey seems to be seeing. It turns out that cells in the primary visual cortex, 6, do not correlate well. When the monkey is stimulated with horizontal and vertical gratings but sees horizontal, a large number of both vertical and horizontal cells in 6 fire. At this point, most cells seem to correlate with retinal stimulus, not with visual percept. Further into the visual system, however, the correlation increases until in the inferior temporal, IT, cortex, there is a very strong correlation. When the monkey is stimulated with horizontal and vertical grating but sees horizontal, almost all of the relevant horizontal cells in IT fire, and almost none of the vertical cells do. When the monkey's response switches, indicating that it is now seeing vertical, the cell responses switch accordingly. These results lend themselves naturally to speculation about the location of a visual NCC. It seems that 6 is unlikely to be or to involve an NCC, for example, due to the failure of 6 cells to correlate with the contents of consciousness. Of course, there are still the possibilities that some small subset of 6 is an NCC or that 6 is a neural correlate of some aspects of visual consciousness but not of others, but I leave those aside for now. On the other hand, IT seems to be a natural candidate for the location of an NCC due to the strong correlation of its cells with the content of consciousness. At least it is natural to suppose that IT is a lower bound on the location of a visual NCC, due to the failure of strong correlation before then, though the NCC itself may be farther in. None of this evidence is conclusive, and Logothetis and colleagues are appropriately cautious, but it is at least suggestive. It is clear that this work is concerned with the neural correlates of the contents of visual consciousness. We are interested in finding cortical areas whose neural activity correlates with and predicts specific contents of consciousness, such as experiences of horizontal or vertical lines or of flowers or sunbursts. The ideal is to find a neural system from whose activity we might determine the precise contents of a visual experience or at least its contents in certain respects, shape, color, and the like. Interestingly, it seems that in doing this we are crucially concerned with the representational contents of the neural systems themselves. In the Logothetis work, for example, it is important to determine the receptive fields of the cells, whether they respond to horizontal or vertical gratings, for example, in order to see whether the receptive fields of active cells match up with the apparent contents of visual consciousness. In essence, the receptive field is acting at least as a heuristic way of getting at representational content in the neurons in question. Then, the crucial question is whether the representational content in the neural system matches up with the representational content in visual consciousness. This suggests a natural definition of a neural correlate of the contents of consciousness. A neural correlate of the contents of consciousness is a neural representational system and such that representation of a content in and directly correlates with representation of that content in consciousness. Or, more briefly, an NCC for content is a neural representational system and such that the content of and directly correlates with the content of consciousness. For example, the Logothetis work lends itself to the speculation that IT might contain a content NCC for visual consciousness since the content of cells in IT seems to directly correlate, at least in these experiments, with the contents of visual consciousness. Much more investigation is required to see whether this correlation holds across the board, of course. This definition requires that we have some way of defining the representational content of a neural system independent of the contents of consciousness. There are various ways to do this. Using a cell's receptive field to define its representational content is probably the simplest. A more refined definition might also give a role to the sort of behavior that activity in that system typically leads to. In addition, there may be more complex notions of representational content still, based on complex correlations with environment, patterns of behavior, and activity in other cells, but even a crude definition of representational content, example the receptive field definition, is good enough for many purposes and can yield informative results about the visual NCC. It is arguable that much work on the visual NCC tacitly invokes this sort of definition. Another example is Milner and Goodale's, 1995, work on the two pathways of visual perception. They suggest that the ventral stream is largely for cognitive identification and decision, while the dorsal stream is largely for online motor response, and that visual consciousness correlates with activity in the ventral stream. Much of the support for this work lies with patients who have dissociations between specific contents of conscious perception and the contents involved in motor response. For example, a subject with visual form agnosia, example Milner and Goodale's patient DF, cannot consciously identify a vertical slot but can post an envelope through it without problem, while subjects with optic ataxia can identify an object but cannot act appropriately toward it. The dissociations here appear to go along with damage to the ventral and dorsal pathways, respectively. What seems to be going on a natural interpretation of these results and of Milner and Goodale's hypothesis, is that for these subjects, there is a dissociation between the contents represented in the ventral pathway and those represented in the dorsal pathway. In these cases, the character of a motor response appears to be determined by the contents represented in the dorsal pathway, but the character of conscious perception appears to be determined by the contents represented in the ventral pathway. Thus, one can see Milner and Goodale's hypothesis as involving the suggestion that the ventral stream contains the neural correlates of the contents of visual consciousness. The hypothesis is quite speculative, of course, though it is interesting to note that it lies in the ventral stream, but it seems that the content-based analysis provides a natural interpretation of what the hypothesis is implicitly claiming regarding the visual NCC and of what may follow if the hypothesis turns out to be correct. One could give a similar analysis of much or most work on the visual NCC. When Crick and Kook, 1998, propose that the visual NCC lies outside V1, for example, much of the experimental evidence they appeal to involves cases where some content is represented in consciousness but not in V1 or vice versa. For example, Gurr and Snodderly, 1997, show that for some quickly alternating isoluminant color stimuli, color cells in V1 flicker back and forth even though a single fused color is consciously perceived. In addition, results by He, Kavanagh, and Intriligator, 1996, suggest that the orientation of a grating can fade from consciousness even though orientation cells in V1 carry the information. The results are not entirely conclusive, but they suggest a mismatch between the representational content in V1 and the content of consciousness. One can apply this sort of analysis equally to NCCs in other sensory modalities. An NCC of auditory consciousness, for example, might be defined as a neural representational system whose contents correlate directly with the contents of auditory consciousness, loudness, direction, pitch, tone, and the like. The analysis can arguably be applied to defining the neural correlates of bodily sensations, of conscious mental imagery, and perhaps of conscious emotion and of the stream of conscious thought. All these aspects of consciousness can be naturally analyzed, at least in part, in terms of their content. In looking for their respective NCCs, we may ultimately be looking for neural systems whose content correlates with the contents of these aspects of consciousness. 4. Arbitrary phenomenal properties. This section is more abstract than the preceding sections and might be skipped by those not interested in philosophical details. One might try to give a general definition of an NCC of various states of consciousness, of which each of the foregoing would be a special case. To do this, one would need a general way of thinking about arbitrary states of consciousness. Perhaps the best way is to think in terms of arbitrary phenomenal properties. For any distinctive kind of conscious experience, there will be a corresponding phenomenal property, in essence the property of having a conscious experience of that kind. For example, being in a hypnotic state of consciousness is a phenomenal property, having a visual experience of a horizontal line is a phenomenal property, feeling intense happiness is a phenomenal property, feeling a throbbing pain is a phenomenal property, being conscious is a phenomenal property. Phenomenal properties can be as coarse-grained or as fine-grained as you like as long as they are wholly determined by the current conscious state of the subject. Using this notion, one might try to define the neural correlate of an arbitrary phenomenal property P. A state N of system N is a neural correlate of phenomenal property P if Ns being in N directly correlates with the subject having P. Note that we here talk of a state being an NCC. Given a specific phenomenal property experiencing a horizontal line, for example, it is no longer clear that it makes sense to speak of a given system being the NCC of that property. Rather, it will be a particular state of that system. Neural firing in certain horizontal cells in IT, say, might be a neural correlate of seeing a horizontal line, for example. On Hobson's hypothesis, having one's neurochemical system in a certain region of state space might be a neural correlate of waking consciousness. These are specific states of the neural systems in question. Most of the time we are not concerned with neural correlates of single phenomenal properties but of families of phenomenal properties. Hobson, 997, is concerned not just with the neural correlate of waking consciousness, for example, but also with the neural correlate of the whole family of background states of consciousness. Work on the visual NCC is not concerned with just the neural correlate of horizontal experience but also with the neural correlates of the whole system of visual experiential contents. We might say a phenomenal family is a set of mutually exclusive phenomenal properties that jointly partition the space of conscious experiences or at least some subset of that space. That is, any subject having an experience, of a certain relevant kind, will have a phenomenal property in the family and will not have more than one such property. Specific contents of visual consciousness make for a phenomenal family, for example. Any visually conscious subject will have some specific visual content, and they will not have two contents at once, given that we are talking about overall visual content. The same goes for contents at a particular location in the visual field. Anyone with an experience of a certain location will have some specific content associated with that location, a red horizontal line, say, and not more than one. Ambiguous experiences are not counterexamples here as long as we include ambiguous contents as members of the family in question. The same again goes for color experience at any given location. There will be a phenomenal family, one property for each color quality, for any such location. And the same goes for background states of consciousness. All these sets of phenomenal properties make phenomenal families. We can then say the following. A neural correlate of a phenomenal family S is a neural system N such that the state of N directly correlates with the subject's phenomenal property in S. For any phenomenal family S, a subject will have at most one property in S, one background state or one overall state of visual consciousness or one color quality at a location. A neural system N will be an NCC of S when there are a corresponding number of states of N, one for every property in P such that N's being in a given state directly correlates with the subjects having the corresponding phenomenal property. This template applies to most of the definitions given earlier. For the neural correlate of creature consciousness, we have a simple phenomenal family with two properties, being conscious and not being conscious. An NCC here will be a system with two states that correlate with these two properties. For the neural correlate of a background state of consciousness, we have a phenomenal family with a few more properties, dreaming, being in an ordinary waking state, being under hypnosis, and so on. An NCC here will be a neural system with a few states that correlate directly with these properties. Hobson's neurochemical system would be an example. For the neural correlate of contents of consciousness, one will have a much more complex phenomenal family, overall states of visual consciousness, states of color consciousness at a location, particular conscious occurrent thoughts, and so on, and a neural representational system to match. The state of the NCC will directly correlate with the specific phenomenal property. In the content case, there is an extra strong requirement on the NCC. In the other cases, we have accepted an arbitrary match of neural states to phenomenal states. Any state can serve as the neural correlate of a dreaming state of background consciousness, for example. But where content is concerned, not any neural state will do. The content of the neural state in question must match the content of consciousness. This is a much stronger requirement. It is arguable that this requirement delivers much greater explanatory and predictive power in the case of neural correlates of conscious content. The systematicity in the correlation means that it can be extended to predict the presence or absence of phenomenal features that may not have been present in the initial empirical data set, for example, and it also will dovetail more nicely with finding a mechanism and a functional role for the NCC that matches the role that we associate with a given conscious state. It is this systematicity in the correlation that makes the current work on the neural correlate of visual consciousness particularly interesting. Without it, things would be much more untidy. Imagine that we find arbitrary neural states that correlated directly with the experience of horizontal and vertical lines such that there was no corresponding representational content in the neural state. Instead, we match seemingly arbitrary states n with horizontal, n with vertical, and so on. Would we count this as a neural correlate of the contents of visual consciousness? If we did, it would be in a much weaker sense, and in a way that would lead to much less explanatory and predictive power. One might then hope to extend this sort of systematicity to other, non-content involving phenomenal families. For example, one might find among background states of consciousness some pattern or some dimension along which they systematically vary, some sort of intensity dimension, for example, or a measure of alertness. If we could then find a neural system whose states do not just arbitrarily correlate with the phenomenal states in question but vary along a corresponding systematic dimension, then the NCC in question will have much greater potential explanatory and predictive power. So this sort of systematicity in phenomenal families is something that we should look for and something that we should look to match in potential neural correlates. Perhaps one could define a systematic NCC as a neural correlate of a phenomenal family such that states correlate with each other in some such systematic way. I will not give a general abstract definition here as things are getting complex enough already, but I think one can see a glimmer of how it might go. I will, however, keep using the case of the neural correlate of the contents of consciousness, especially visual consciousness, as the paradigmatic example of an NCC precisely because its definition builds in such a notion of systematicity. 3. Direct correlation. The other thing that we need to clarify is the notion of direct correlation. We have said that an NCC is a system whose state directly correlates with a state of consciousness, but exactly what does direct correlation involve? Is it required that the neural system be necessary and sufficient for consciousness, for example, or merely sufficient? And over what range of cases must the correlation obtain for the system to count as an NCC? Any possible case? A relevantly constrained set of cases? And so on. The paradigmatic case will involve a neural system N with states that correlate with states of consciousness. So we can say the following. State of N left right arrow state of consciousness and specifically N is in state N1 left right arrow subject has conscious state C1. In the case of the contents of consciousness, we have a system N such that representing a content R in N directly correlates with representation in consciousness. So we can say representing R in N left right arrow representing R in consciousness. The question in all of these cases concerns the nature of the required relation, here represented as left right arrow. How strong a relation is required for N to be an NCC? A. Necessity, sufficiency. The first question is whether the NCC state is required to be necessary and sufficient for the conscious state, merely sufficient, or something else in the vicinity. A1. Necessity and sufficiency. The first possibility is that the state of N is necessary and sufficient for the corresponding state of consciousness. Th is an attractive requirement for an NCC, but it is arguably too strong. It might turn out that there is more than one neural correlate of a given conscious state. For example, it may be that there are two systems, M and N, such that a certain state of M suffices for being in pain and a certain state of N also suffices for being in pain, where these two states are not themselves always correlated. In this case, it seems that we would likely say that both M and N, or their corresponding states, are neural correlates of pain. But it is not the case that activity in M is necessary and sufficient for pain, as it is not necessary, and the same goes for N. If both M and N are to count as NCCs here, we cannot require an NCC to be necessary and sufficient. A2. Sufficiency. From the foregoing, it seems plausible that we require only that an NCC state be sufficient for the corresponding state of consciousness, not necessary. But is any sufficient state an NCC? If it is, then it seems that the whole brain will count as an NCC of any state of consciousness. The whole brain will count as an NCC of pain, for example, since being in a certain total state of the whole brain will suffice for being in pain. Perhaps there is some very weak sense in which this makes sense, but it does not seem to capture what researchers in the field are after when looking for an NCC. So something more than mere sufficiency is required. A3. Minimal sufficiency. The trouble with requiring mere sufficiency, intuitively, is that it allows irrelevant processes into an NCC. If N is an NCC, then the system obtained by conjoining N with a neighboring system M will also qualify as an NCC by the previous definition, since the state of N plus M will suffice for the relevant states of consciousness. The obvious remedy is to require that an NCC be a minimal sufficient system, that is, a minimal system whose state is sufficient for the corresponding conscious state. By this definition, N will be an NCC when, 1. The states of N suffice for the corresponding states of consciousness and, 2. No proper part M of N is such that the states of M suffice for the corresponding states of consciousness. In this way, we pare down any potential NCC to its core. Any irrelevant material will be whittled away, and an NCC will be required to contain only the core processes that suffice for the conscious state in question. On this definition, there may be more than one NCC for a given conscious state. It may be that there is more than one minimal sufficient system for a given state, or for a given system of states, and both of these will count as a neural correlate of that state. This seems to be the right result. We cannot know a priori that there will be only one NCC for a given state or system of states. Whether there will actually be one or more than one for any given state is something that can be determined only empirically. There is a technical problem for the minimality requirement. It may turn out that there is significant redundancy in a neural correlate of consciousness, such that, for example, a given conscious visual content is represented redundantly in many cells in a given area. If this is so, then that visual area as a whole might not qualify as a minimal sufficient system, as various smaller components of it might all themselves correlate with the conscious state. In this case, the preceding definition would imply that various such small components would each be an NCC. One could deal with this sort of case by noting that the problem arises only when the states of the various smaller systems are themselves wholly correlated with each other. If their mutual correlation can be broken, so will their correlation with consciousness, so that the overall system or some key subsystem will again emerge as the true NCC. Given this, one could stipulate that where states of minimal sufficient systems are wholly correlated with each other, it is the union of the system that should be regarded as an NCC rather than the individual systems. So an NCC would be a minimal system whose state is sufficient for a given conscious state and whose state is not wholly correlated with the state of any other system. I pass over this complication in what follows, however. B. What range of cases? An NCC will be a minimal neural system N such that the state of N is sufficient for a corresponding conscious state. This is to say that if the system is in state N, the subject will have conscious state C. However, the question now arises, over what range of cases must the correlation in question hold? There is sometimes a temptation to say that this question does not need to be answered, all that is required is that in this very case, neural state N suffices for or correlates with conscious state C, but this does not really make sense. There is no such thing as a single case correlation. Correlation is always defined with respect to a range of cases. The same goes for sufficiency. To say that neural state N suffices for conscious state C is to say that in a range of cases, neural state N will always be accompanied by conscious state C. But what is the range of cases? By any possible case. It is momentarily tempting to suggest that the correlation should range across any possible case. If N is an NCC, it should be impossible to be in a relevant state of N without being in the corresponding state of consciousness. But a moment's reflection suggests that this is incompatible with the common usage in the field. NCCs are often supposed to be relatively limited systems, such as the inferior temporal cortex or the intralaminar nucleus, but nobody, or almost nobody, holds that if one excises the entire inferior temporal cortex or intralaminar nucleus and puts it in a jar and puts the system into a relevant state, it will be accompanied by the corresponding state of consciousness. That is to say, for a given NCC, it certainly seems possible that one can have the NCC state without the corresponding conscious state, for example by performing sufficiently radical lesions. So we cannot require that the correlation range over all possible cases. Of course, one could always insist that a true NCC be such that it is impossible to have the NCC state without the corresponding conscious state. The consequence of this would be that an NCC would almost certainly be far larger than it is on any current hypothesis, as we would have to build in a large amount of the brain to make sure that all of the background conditions are in place. Perhaps it would be some sort of wide-ranging although skeletal brain state involving aspects of processes from a number of regions of the brain. This might be a valid usage, but it is clear that this is not what researchers in the field are getting at when they are talking about an NCC. We might call the notion just defined a total NCC as it builds in the totality of physical processes that are absolutely required for a given conscious state. The notion that is current in the field is more akin to that of a core NCC. I adapt this terminology from Shoemaker's 1981 notion of a total realization and a core realization of a functional mental state. A total NCC builds in everything and thus automatically suffices for the corresponding conscious states. A core NCC, on the other hand, contains only the core processes that correlate with consciousness. The rest of the total NCC will be relegated to some sort of background conditions that are required for the correct functioning of the core. Philosophical note: the sort of possibility being considered here is natural or nomological possibility or possibility compatible with the laws of nature. If we required correlation across all logically possible cases, there might be no total NCC at all, as it is arguably logically possible or coherently conceivable to instantiate any physical process at all without consciousness. If we require correlation across naturally possible cases, the problem goes away, as these cases are probably not naturally possible. It is almost certainly naturally necessary that a being with my brain state will have the same sort of conscious state as I do, for example. The question is then how to distinguish the core from the background. It seems that what is required for an NCC, in the core sense, is not that it correlate with consciousness across any possible conditions but rather that it correlate across some constrained range of cases in which some aspects of normal brain functioning are held constant. The question then becomes, what is to be held constant? Across just what constrained range of cases do we require then an NCC correlate with consciousness? B2. Ordinary functioning brain in ordinary environments. One might take the moral of the foregoing to be that one cannot require an NCC to correlate with consciousness in unnatural cases. What matters is that the NCC correlates with consciousness in natural cases, that is, those that actually occur in the functioning of a normal brain. The most conservative strategy would be to require correlation only across cases involving a normally functioning brain in a normal environment, receiving ecologically valid inputs of the sort received in a normal life. The trouble with this criterion is that it seems too weak to narrow down the NCC. It may turn out that this way we find NCCs at all stages of the visual system, For example, in a normal visual environment, we expect that the contents of visual systems from V1 through IT will all correlate with the contents of visual consciousness, and that even the contents of the retina will do so to some extent. The reason is that in normal cases all of these will be linked in a straightforward causal chain, and the systems in question will not be dissociated. Nonetheless, it seems wrong to say that, merely because of this, all of the systems, perhaps even the retina, should count as an NCC. The moral of this is that we need a more fine-grained criterion to dissociate these systems and to distinguish the core NCC from processes that are merely causally linked to it. To do this, we have to require correlation across a range of unusual cases as well as across normal cases, as it is these that yield interesting dissociations. B3, Normal brain, unusual inputs. The next most conservative suggestion is that we still require a normal brain for our range of cases, but that we allow any possible inputs, including ecologically invalid inputs. This would cover the logothetis experiments, for example. The inputs that evoke binocular rivalry are certainly unusual and not encountered in a normal environment. However, it is precisely these that allow the experiments to make more fine-grained distinctions than we normally can. The experiments suggest that IT is more likely than V1 to be an NCC precisely because it correlates with consciousness across the wider range of cases. If states of VR truly do not match up with states of consciousness in this situation, then it seems that V1 cannot be an NCC. If that reasoning is correct, then it seems that we require an NCC to correlate with consciousness across all unusual inputs and not just across normal environments. The extension of the correlation requirement from normal environments to unusual inputs is a relatively safe extension and seems a reasonable requirement, though those who place a high premium on ecological validity might contest it. Yet it is arguable that this is still too weak to do the fine-grained work of distinguishing an NCC from systems linked to it. Presumably unusual inputs will go only so far in yielding interesting dissociations, and some systems, particularly those well down the processing pathway, may well stay associated on any unusual inputs. So it is arguable that we will need more fine-grained tools to distinguish the NCC. B4, Normal brain, very brain stimulation. The next possibility is to allow cases involving not just unusual inputs but also direct stimulation of the brain. Such direct stimulation might include both electrode stimulation and transcranial magnetic stimulation. On this view, we will require that an NCC correlate with consciousness across all cases of brain stimulation, as well as normal functioning. So if we have a potential NCC state that does not correlate with consciousness in the right way in a brain stimulation condition, that state will not be a true NCC. This requirement seems to fit some of the methods used in the field. Penfield, example Penfield and Rasmussen 1950, pioneered the use of brain stimulation to draw conclusions about the neural bases of consciousness. Libet, 1982, has also used brain stimulation to good effect, and more recently Newsom and colleagues, example Salzman, Britain, and Newsom 1990, have used brain stimulation to draw some conclusions about neural correlates of motion perception in monkeys. Brain stimulation can clearly be used to produce dissociations that are more fine-grained than can be produced merely with unusual inputs. One might be able to dissociate activity in any system from that in a preceding system by stimulating that system directly, for example, as long as there are not too many backward connections. Given a candidate NCC inferior temporal cortex, say one can test the hypothesis by stimulating an area immediately following the candidate in the processing pathway. If that yields a relevant conscious state without relevant activity in IT, say, that indicates that IT is probably not a true NCC after all. Rather, the NCC may lie in a system further down the processing chain. I leave aside the possibility that there might be two NCCs at different stages of the chain. This reasoning seems sound, suggesting that we may tacitly require an NCC to correlate with consciousness across brain stimulation conditions. There is no immediately obvious problem with the requirement, at least when the stimulation in question is relatively small and localized. If one allows arbitrary large stimulation, there may be problems. For example, one could presumably use brain stimulation at least in principle to disable large areas of the brain, by overstimulating those areas, for example, while leaving NCC activity intact. In this case, it is not implausible to expect that one will have the relevant NCC activity without the usual conscious state, just as in the case where one lesions the whole NCC and puts it in a jar, so the correlation will fail in this case. Intuitively, this does not seem to disprove the claim that the NCC in question is a true NCC, at least before the stimulation. If so, then we cannot allow unlimited brain stimulation in the range of cases relevant to the correlation, and more generally, some of the problems for lesions, discussed later, may apply to reasoning involving brain stimulation. Nevertheless, in the absence of strong reason to believe otherwise, one might well require that an NCC correlate with consciousness at least across cases of limited stimulation. B5. Abnormal functioning due to lesions. In almost all of the preceding cases, we have retained a normally functioning brain, we have just stimulated it in unusual ways. The next logical step is to allow cases where the brain is not functioning normally due to lesions in brain systems. Such lesions might be either natural, example due to some sort of brain damage, or artificial, example induced by surgery. On this view, we will require that an NCC correlate with states of consciousness not just across cases of normal functioning but across cases of abnormal functioning as well. This certainly squares with common practice in the field. Lesion studies are often used to draw conclusions about the neural correlates of consciousness. In Milner and Goodale's 1995 work, for example, the fact that consciousness remains much the same upon lesions to the dorsal stream but not to the ventral stream is used to support the conclusion that the NCC lies within the ventral stream. More generally, it is often assumed that if some aspect of consciousness survives relatively intact when a given brain area is damaged, then that brain area is unlikely to be or to contain an NCC. The tacit premise in this research is that an NCC should correlate with consciousness not just in cases of normal functioning but in cases of abnormal functioning as well. Given this premise, it follows that if we find an abnormal case in which neural system N is damaged but a conscious state C is preserved, then N is not a neural correlate of C. Without this premise or a version of it, it is not clear that any such conclusion can be drawn from lesion studies. The premise may sound reasonable, but we already have reason to be suspicious of it. We know that for any candidate NCC, sufficiently radical changes can destroy the correlation. Preserving merely system N cut off from the rest of the brain, for example, is unlikely to yield a corresponding conscious state, but intuitively, this does not imply that N was not an NCC in the original case. Less radically, one can imagine placing lesions immediately downstream from a candidate NCC so that its effects on the rest of the brain are significantly reduced. In such a case, it is probable that the system in question can be active without the usual behavioral effects associated with consciousness and quite plausibly without consciousness itself. It is not implausible that an NCC supports consciousness largely in virtue of playing the right functional role in the brain, perhaps in virtue of mediating global availability, as discussed in Chapter 4. If so, then if the system is changed so that the NCC no longer plays that functional role, then NCC activity will no longer correlate with consciousness. However, the mere fact that correlation can be destroyed by this sort of lesion does not obviously imply that the system is not an NCC in a normal brain. If that inference could be made, then almost any candidate NCC could be ruled out by the right sort of lesion. It may be that even smaller lesions can destroy a correlation in this way. For example, it is not implausible that for any candidate NCCN, there is some other local system in the brain, perhaps a downstream area, whose proper functioning is required for activity in N to yield the usual effects that go with consciousness and for N to yield consciousness itself. This second system might not itself be an NCC in any intuitive sense, it might merely play an enabling role in the way that proper functioning of the heart plays an enabling role for functioning of the brain. If so, then if one lesions the single area downstream, then activity in N will no longer correlate with consciousness. In this way, any potential NCC might be ruled out by a localized lesion elsewhere. The trouble is that lesions change the architecture of the brain, and it is quite possible that changes to brain architecture can change the very location of an NCC, so that a physical state that was an NCC in a normal brain will not be an NCC in the altered brain. Given this possibility, it seems too strong to require that an NCC correlate with consciousness across arbitrary lesions and changes in brain functioning. We should expect an NCC to be architecture dependent, not architecture independent. So an NCC should not be expected to correlate with consciousness across arbitrary lesion cases. There are now two alternatives. Either we can require correlation across some more restricted range of lesion cases, or we can drop the requirement of correlation in abnormal cases altogether. For the first alternative to work, we would have to find some way to distinguish a class of good lesions from the class of bad lesions. An NCC would be expected to correlate with consciousness across the good lesions but not the bad lesions. If one found a good lesion case where activity in system N was present without the corresponding consciousness state, this would imply that N is not an NCC. But no such conclusion could be drawn from a bad lesion case. The trouble is that it is not at all obvious that such a distinction can be drawn. It might be tempting to come up with an after-the-fact distinction, defined as the range of lesions in which correlation with any given NCC N is preserved, but this will not be helpful, as we are interested in precisely the criterion that makes N qualify as an NCC in the first place. So a distinction will have to be drawn on relatively a priori grounds. It can then be used to determine whether a given correlation pattern qualifies an arbitrary system as an NCC or not. But it is not clear how to draw the distinction. One might suggest that correlation should be preserved across small lesions but not large ones. However, we have already seen that even small lesions might destroy a potential NCC. Or one might suggest that lesions in downstream areas are illegitimate, whereas upstream and parallel lesions are legitimate. Even here, however, it is not clear whether indirect interaction with an upstream or parallel area might be required to support the proper functioning of an NCC. Perhaps with some ingenuity one might be able to come up with a criterion, but it is not at all obvious how. The second alternative is to hold that correlation across cases of normal functioning, perhaps with unusual inputs and brain stimulation, is all that is required to be an NCC. If this is so, one can never infer directly from the fact that N fails to correlate with consciousness in a lesion case to the conclusion that N is not an NCC. On this view, the location of an NCC is wholly architecture dependent, that is, entirely dependent on the normal functioning of the brain. One cannot expect an NCC to correlate with consciousness in cases with abnormal functioning or different architecture, so no direct conclusion can be drawn from failure of correlation across lesion cases. Of course, one can still appeal to cases with unusual inputs and brain stimulation to make fine-grained distinctions among NCCs. The main objection to the second alternative is that one might need lesion cases to make the most fine-grained distinctions that are required. Consider a hypothetical case in which we have two linked systems N and M that correlate equally well with consciousness across all normal cases, including all unusual inputs and brain stimulation, but such that in almost all relevant lesion cases, consciousness correlates much better with N than with M. In this case, might we want to say that N rather than M is an NCC? If so, we have to build in some allowance for abnormal cases into the definition of an NCC. An advocate of the second alternative might reply by saying that such cases will be very unusual and that if N and M are dissociable by lesions, there is likely to be some unusual brain stimulation that will bring out the dissociation as well. In the extreme case where no brain stimulation leads to dissociation, one might simply bite the bullet and say that both N and M are equally good NCCs. Taking everything into consideration, I am inclined to think the second alternative is better than the first. It seems right to say that core NCC location depends on brain architecture and normal functioning, and it is unclear that correlation across abnormal cases should be required, especially given all of the associated problems. A problem like the one just mentioned might provide some pressure to investigate the first alternative further, and I do not rule out the possibility that some way of distinguishing good from bad lesions might be found, but all in all it seems best to say that an NCC cannot be expected to correlate with consciousness across abnormal cases. Of course, this has an impact on the methodology in the search for an NCC. As we have seen, lesion studies are often used to draw conclusions about NCC location, as in the Milner and Goodale research, for example, and also in much research on blind sight, and failure of correlation in lesion cases is often taken to imply that a given system is not an NCC. Still, we have seen that the tacit premise of this sort of research that an NCC must correlate across abnormal, as well as normal, cases is difficult to support and leads to significant problems. So it seems that lesion studies are methodologically dangerous here. One should be very cautious in using them to draw conclusions about NCC location. This is not to say that lesion studies are irrelevant in the search for an NCC. Even if correlation across abnormal cases is not required for system N to be an NCC, it may be that correlation across abnormal cases can provide good evidence that N is an NCC, and that failure of such correlation in some cases provides good evidence that N is not an NCC. Say that, as I have suggested, we define an NCC as a system that correlates with consciousness across all normal cases, including unusual input and stimulation. It may nevertheless be the case that information about correlations across all these normal cases with unusual stimulation is difficult to come by, due to problems in monitoring brain systems at a fine grain, for example, and that information about correlation across lesion cases is easier to obtain. In this case, one might sometimes take correlation across abnormal cases as evidence that a system will correlate across the normal cases in question, and thus as evidence that the system is an NCC. Similarly, one might take failure of correlation across abnormal cases as evidence that a system will fail to correlate across certain normal cases, and thus as evidence that the system is not an NCC. The question of whether a given lesion study can serve as evidence in this way needs to be considered on a case-by-case basis. It is clear that some lesion studies will not provide this sort of evidence, as is witnessed by the cases of severe lesions and downstream lesions discussed earlier. In these cases, failure of correlation across abnormal cases provides no evidence of failure of correlation across normal cases. On the other hand, it does not seem unreasonable that the Milner and Goodale studies should be taken as evidence that, even in normal cases, the ventral stream will correlate better with visual consciousness than the dorsal stream. Of course, the real proof would come from a careful investigation of the relevant processes across a wide range of normal cases involving standard environments, unusual inputs, and brain stimulation. But in the absence of such a demonstration, the lesion cases at least provide suggestive evidence. In any case, the moral is that one has to be very cautious when drawing conclusions about NCC location from lesion studies. At best, these studies serve as indirect evidence rather than as direct criteria, and even as such there is a chance that the evidence can be misleading. One needs to consider the possibility that the lesion in question is changing brain architecture in such a fashion that what was once an NCC is no longer an NCC, and one needs to look very closely at what is going on to rule out the possibility. It may be that this can sometimes be done, but it is a non-trivial matter. For overall definition. With all of this, we have come to a more detailed definition of an NCC. The general case is something like the following. An NCC is a minimal neural system N such that there is a mapping from states of N to states of consciousness, where a given state of N is sufficient, under conditions C, for the corresponding state of consciousness. The central case of the neural correlate of the content of consciousness can be put in more specific terms. An NCC for content is a minimal neural representational system N such that representation of a content in N is sufficient, under conditions C, for representation of that content in consciousness. One might also give a general definition of the NCC for an arbitrary phenomenal property or for a phenomenal family, but I leave those aside here. The conditions C clause here represents the relevant range of cases. If the reasoning earlier is on the right track, then condition C might be seen as conditions involving normal brain functioning, allowing unusual inputs and limited brain stimulation, but not lesions or other changes in architecture. Of course, the precise nature of condition C is still debatable. Perhaps one could make a case for including a limited range of lesion cases in the definition. In the other direction, one might make a case that the requirement of correlation across brain stimulation or unusual inputs is too strong due to the abnormality of those scenarios. But I think the conditions C proposed here are at least a reasonable first pass, pending further investigation. Of course, to some extent, defining what really counts as an NCC is a terminological matter. One could quite reasonably say that there are multiple different notions of NCC depending on just how one understands the relevant condition C or the matter of necessity and sufficiency and so on, and not much really rests on which of these is the right definition. Still, we have seen that different definitions give very different results. Many potential definitions have the consequence that systems that intuitively seem to qualify as an NCC do not qualify after all, and that NCC hypotheses put forward by researchers in the field could be ruled out on trivial a priori grounds. Those consequences seem undesirable. It makes sense to have a definition of NCC that fits the way the notion is generally used in the field and that can make sense of empirical research in the area. At the same time, we want a definition of NCC to be coherent and well motivated in its own right, such that an NCC is something worth looking for and such that the definition can itself be used to assess various hypotheses about the identity of an NCC. The definition I have given here is at least a first pass in this direction. 5 Methodological consequences. The discussion so far has been somewhat abstract, and the definitions given here may look like mere words. But from these definitions and the reasoning that went into them, one can straightforwardly extract some concrete methodological recommendations for the NCC search. Many of these recommendations are plausible or obvious in their own right, but it is interesting to see them emerge from the analysis. 1. Lesion studies are methodologically dangerous. Lesion studies are often used to draw conclusions about neural correlates of consciousness, but we have seen that their use can be problematic. The identity of an NCC is arguably always relative to specific brain architecture and normal brain functioning, and correlation across abnormal cases should not generally be expected. In some cases, lesion studies can change brain architecture so that a system that was previously an NCC is no longer an NCC. So one can never infer directly from failure of correlation between a system and consciousness in a lesion case to the conclusion that that system is an NCC. Sometimes one can infer this indirectly by using the failure of correlation here as evidence for failure of correlation in normal cases, but one must be cautious. 2. There may be many NCCs. On the definition given earlier, an NCC is a system whose activity is sufficient for certain states of consciousness. This allows for the possibility of multiple NCCs in at least 2 ways. First, different sorts of conscious states may have different corresponding NCCs. There may be different NCCs for visual and auditory consciousness, for example, and perhaps even for different aspects of visual consciousness. Second, even for a particular sort of conscious state, such as pain, we cannot rule out the possibility that there will be 2 different systems whose activity is sufficient to produce that state. Of course, it could turn out that there are only a few NCCs or perhaps even 1. In the next chapter I discuss the possibility of some central system that represents the contents of visual consciousness, auditory consciousness, emotional experience, the stream of conscious thought, the background state of consciousness, and so on. Such a system might be seen as a sort of consciousness module, a Cartesian theater, Dennett 1991, or a global workspace, Bars 1988, depending on whether one is a foe or a friend of the idea. However, it is by no means obvious that there will be such a system, and the empirical evidence so far is against it. In any case, the matter cannot be decided a priori, so our definition should be compatible with the existence of multiple or many NCCs. 3. Minimize the size of an NCC. We have seen that an NCC should be understood as a minimal neural system that correlates with consciousness. Given this, we should constrain the search for the NCC by aiming to find a neural correlate that is as small as possible. Given a broad system that appears to correlate with consciousness, we need to isolate the core parts and aspects of that system that underlie the correlation. Given the rival hypotheses that consciousness correlates with a broad system or a narrower system contained within it, we might first investigate the narrow hypothesis. If the narrow system correlates well enough with consciousness, the broad system cannot be a true NCC. It follows that to some extent it makes sense to start small in the search for an NCC. This fits the working methodology proposed by Crick and Kook, 1998, who suggest that an NCC may perhaps involve a very small number of neurons, perhaps in the thousands, with certain distinctive properties. There is no guarantee that this is correct, and my own money is against it, but it makes a good working hypothesis in the NCC search. Of course, one should simultaneously investigate broad systems for correlation with consciousness so that one can then focus on those areas and try to narrow things down. 4. Distinguish NCC for background state and for content. We have seen that there may be different NCCs for different sorts of states of consciousness. An important distinction in this class is that between the neural correlate of background states of consciousness, wakefulness, dreaming, etc., and the neural correlate of specific contents. It may be that these are quite different systems. It is not implausible on current evidence that an NCC for background states involves processes in the thalamus or thalamocortical interactions, while an NCC for specific contents of consciousness involves processes in the cortex. These different sorts of NCC will require quite different methods for their investigation. 5. NCC studies need to monitor neural representational content. Arguably the most interesting part of the NCC search is the search for neural determinants of specific contents of consciousness, such as the contents of visual consciousness. We have seen that an NCC here will be a neural representational system whose contents are correlated with the contents of consciousness. To determine whether such a system is truly an NCC, then, we need methods that monitor the representational content of the system. This is just what we find in Logothetis's work, for example, where it is crucial to keep track of activity in neurons with known receptive fields. This gets at a striking aspect of the NCC search, mentioned in the last chapter. The most informative and useful results usually come from neuron-level studies on monkeys. Large claims are sometimes made for brain imaging on humans, but it is generally difficult to draw solid conclusions from such studies, especially where an NCC is concerned. We can trace the difference to the fact that neuron-level studies can monitor representational content in neural systems, whereas imaging studies cannot, or at least usually do not. The power of single-cell studies in the work of Logothetis, Anderson, and Newsom and colleagues, example the works of Logothetis and Newsom already cited, and Bradley, Chang, and Anderson 1998, comes precisely from the way that cells can be monitored to keep track of the activity profile of neurons with known representational properties, such as receptive and projective fields. This allows us to track representational content in these neural systems and to correlate it with the apparent contents of consciousness. This is much harder to do in a coarse-grained brain imaging study, which generally tells one that there is an activity in a region while saying nothing about specific contents. To deal with this problem, we need better methods for tracking neural representational content, especially in humans, where invasive studies are much more problematic but where evidence for conscious content are much more straightforward. There has been some recent work on the use of imaging methods to get at certain aspects of the content of visual consciousness, such as colors and shapes in the visual field, example Engel, Zhang, and Wandel 1997, and different sorts of objects that activate different brain areas, example Tong et al. 1998. There is also some current work on using invasive methods in neurosurgery patients to monitor the activity of single cells. One can speculate that if a non-invasive method for monitoring single-cell activity in humans is ever developed, the search for an NCC, like most of neuroscience, will be transformed almost beyond recognition. 6. Correlation across a few situations is limited evidence. According to the earlier definition, an NCC is a system that correlates with consciousness across arbitrary cases of normal functioning in any environment and with any unusual input or limited brain stimulation. In practice, though, evidence is far weaker than this. Typically one has a few cases involving either a few subjects with different lesions or a study in which subjects are given different stimuli, and one notes an apparent correlation. This is only to be expected, given the current technological and ethical constraints on experimental methods, but it does mean that the evidence that current methods give is quite weak. To truly demonstrate that a given system is an NCC, one would need to demonstrate correlation across a far wider range of cases than is currently feasible. Of course, current methods may give good negative evidence about systems that fail to correlate and thus are not NCCs, but strong positive evidence is harder to find. Positive hypotheses based on current sorts of evidence should probably be considered suggestive but highly speculative. 7. We need good criteria for the ascription of consciousness. To find an NCC, we need to find a neural system that correlates with certain conscious states. To do this, we first need a way to know when a system is in a given conscious state. This is famously problematic, given the privacy of consciousness and the philosophical problem of other minds. In general, we rely on indirect criteria for the ascription of consciousness, such as verbal reports or other behavioral signs. The need for these criteria raises a number of further methodological issues, which are the focus of Chapter 4. Methodological summary. We can use all of this to sketch a general methodology for the NCC search. First, we need methods for determining the contents of conscious experience in a subject, presumably by indirect behavioral criteria or by first-person phenomenology. Second, we need methods to monitor neural states in a subject and in particular to monitor neural representational contents. Then we need to perform experiments in a variety of situations to determine which neural systems correlate with conscious states and which do not. Experiments involving normal brain functioning with unusual inputs and limited brain stimulation are particularly crucial here. Direct conclusions cannot be drawn from systems with lesions, but such systems can sometimes serve as indirect evidence. We need to consider multiple hypotheses in order to narrow down to a set of minimal neural systems that correlate with consciousness across all relevant scenarios. We may well find many different NCCs in different modalities and different NCCs for background states and conscious contents, although it is not out of the question that there will be only a small number. If all goes well, we might expect to eventually isolate systems that correlate strongly with consciousness across any normally functioning brain. 6. Should we expect an NCC? One might well ask the following: given the notion of an NCC as I have defined it, is it guaranteed that there will be a neural correlate of consciousness? In answering, I assume that states of consciousness depend systematically in some way on overall states of the brain. If this assumption is false, as is held by some Cartesian dualists, example Ecclesiastes 1994, and some phenomenal externalists, example Dridsk 1995, then there may be no NCC as defined here, as any given neural state might be instantiated without consciousness. Even on these positions, an NCC could be possible if it were held that brain states at least correlate with conscious states in ordinary cases. But if the assumption is true, then there will at least be some minimal correlation of neural states with consciousness. Does it follow that there will be an NCC as defined here? This depends on whether we are talking about neural correlates of arbitrary conscious states or about the more constrained case of neural correlates of conscious contents. In the first case, it is guaranteed that the brain as a whole will be a neural system that has states that suffice for arbitrary conscious states. So the brain will be one system whose state is sufficient for a given conscious state, and given that there is at least one such system for a given state, there must be at least one such minimal system for that state. Such a system will be an NCC for that state. Of course, this reasoning does not guarantee that there will be only one NCC for a given state, that the NCC for one state will be the same as the NCC for another, or that an NCC will be simple. But we know that an NCC will exist. In the case of neural correlates of the content of consciousness, things are more constrained since a neural correlate is required not just to map to a corresponding state of consciousness but also to match it in content. This rules out the whole brain as even a non-minimal neural correlate, for example, since representing a content in the brain does not suffice to represent that content in consciousness, much of the brain's representational content is unconscious. Of course, we may hope that there will be more constrained neural systems whose content systematically matches that of some aspect of consciousness. But it is not obvious that such a system must exist. It might be held, for example, that the contents of consciousness are an emergent product of the contents of various neural systems, which together suffice for conscious content in question but none of which precisely mirrors the conscious content. One can plausibly argue that there is reason to expect that conscious contents will be mirrored by the contents of a neural representational system at some level of abstraction. In creatures with language, for example, conscious contents correspond well with contents that are made directly available for verbal report, and in conscious creatures more generally, one can argue, as I do in Chapter 4, that the contents of consciousness correspond to contents that are made directly available for the global voluntary control of behavior. So there is a correlation between the contents of consciousness and contents revealed or exhibited in certain functional roles within the system. Given that these contents are revealed in verbal report and are exhibited in the control of behavior, there is reason to believe that they are represented at some point within the cognitive system. Of course, this depends to some extent on just what representation comes to. On some highly constrained notions of representation, if it is held that the only true representation is symbolic representation, for example, then it is far from clear that the content revealed in behavior must be represented. But on less demanding notions of representation on which, for example, systems are assigned representational content according to their functional role, then the content revealed in a functional role will straightforwardly be represented in a system that plays that functional role. This does not guarantee that there will be any single neural system whose content always matches that of consciousness. It may be that the functional role in question is played by multiple systems and that a given system may sometimes play the role and sometimes not. If this is so, we may have to move to a higher level of abstraction. If there is no localizable neural system that qualifies as a correlate of conscious content, we may have to look at a more global system, the global availability system, for example, whereby contents are made available for report and global control, and argue that the contents of consciousness correspond to the contents made available in the system. If so, it could turn out that what we are left with is more like a cognitive correlate of consciousness, CCC, since the system may not correspond to any neurobiological system whose nature and boundaries are independently carved out, but it can still function as a correlate in some useful sense. In this context, it is important to note that an NCC need not be a specific anatomical area in the brain. Some of the existing proposals regarding NCCs involve less localized neurobiological properties. For example, Libet, 1993, argues that the neural correlate of consciousness is temporally extended neural firing. Crick and Kook, 1998, speculate that the NCC might involve a particular sort of cell throughout the cortex. Edelman, 1989, suggests that the NCC might involve rentranthalamicortical loops and so on. In these cases, NCCs are individuated by temporal properties or by physiological rather than anatomical properties or by functional properties, among other possibilities. If so, the neural representational system involved in defining a neural correlate of conscious content might also be individuated more abstractly. The relevant neural representational contents might be those represented by temporally extended firings or by certain sorts of cells or by rentrant loops and so on. So abstractness and failure of localization are not in themselves a bar to a system's qualifying as an NCC. It seems, then, that a range of possibilities exists for the brain-based correlates of conscious states, ranging from specific anatomical areas through more abstract neural systems to purely cognitive correlates such as Barza's, 1988, global workspace. Just how specific an NCC may turn out to be is an empirical question. One might reasonably expect that there will be some biological specificity. Within a given organism or species, one often finds a close match between specific functions and specific physiological systems, and it does not seem unlikely that particular neural systems and properties in the brain should be directly implicated in the mechanisms of availability for global control. If so, then we may expect specific neural correlates even of conscious contents. If not, we may have to settle for more abstract correlates, individuated at least partly at the cognitive level, though even here one would expect that some neural systems will be much more heavily involved than others. In any case, it seems reasonable to expect that we will find informative brain-based correlates of consciousness at some level of abstraction in cognitive neurobiology. Some have argued that we should not expect neural correlates of consciousness. For example, in their discussion of neural filling in visual perception, Pessoa, Thompson, and No, 1998, argue against the necessity of what Teller and Pugh, 1984, call a bridge locus for perception, which closely resembles the notion of a neural correlate of consciousness. Much of their argument is based on the requirement that such a locus involve a spatio-temporal isomorphism between neural states and conscious states, so a conscious representation of a checkerboard would require a neural state in a checkerboard layout, for example. These arguments do not affect neural correlates of conscious contents as I have defined them, since a match between neural and conscious content does not require such a spatio-temporal correspondence. A neural representation of a shape need not itself have that shape. Pessoa et al. Also argue more generally against a uniformity of content thesis, holding that one should not expect a match between the personal contents of consciousness and the subpersonal contents of neural systems. It is true that the existence of such a match is not automatic, but as before, the fact that conscious contents are mirrored in specific functional roles gives reason to believe that they will be subpersonally represented at least at some level of abstraction. 1. It has also been argued, example by Gozaldier 1999, that there is probably no neural correlate of consciousness, as there is probably no area of the brain that is specifically dedicated to consciousness as opposed to vision, memory, learning, and so on. One may well agree that there is no such area, but it does not follow that there is no neural correlate of consciousness as defined here. An NCC, as defined here, requires only that a system be correlated with consciousness, not that it be dedicated solely or mainly to consciousness. The alternative notion of an NCC is much more demanding than the notion at issue in most empirical work on the subject, where it is often accepted that an NCC may be closely bound up with visual processing, example logothetis, Milner and Goodale, memory, example Edelman, and other processes. This becomes particularly clear once one gives up on the requirement that there be a single NCC and accepts that there may be multiple NCCs in multiple modalities. 7. Conclusion. The discussion in the previous section helps bring out what an NCC is not, or at least what it might turn out not to be. An NCC is defined as a correlate of consciousness. From this, it does not automatically follow that an NCC will be a system solely or mainly dedicated to consciousness, or even that an NCC will be the brain system most responsible for the generation of consciousness. It certainly does not follow that an NCC will itself yield an explanation of consciousness, and it is not even guaranteed that identifying an NCC will be the key to understanding the processes underlying consciousness. If we were to define an NCC in these stronger terms, it would be far from obvious that there must be an NCC, and it would also be much less clear how to search for one. Defining an NCC solely in terms of correlation seems to capture standard usage best, and it also makes the search more clearly defined and the methodology clearer. Correlations are easy for science to study. It also means that the search for an NCC can be to a large extent theoretically neutral rather than theoretically loaded. Once we have found an NCC, one might hope that it will turn out to be a system dedicated to consciousness or that it will yield an explanation of consciousness, but these are further questions. In the meantime, the search for an NCC as defined poses a tractable empirical project with relatively clear parameters, one that researchers of widely different theoretical persuasions can engage in. One might reasonably expect the search for an NCC to yield certain rewards. For example, these systems might be used to monitor and predict the contents of consciousness in a range of novel situations. For example, we may be able to use them to help reach conclusions about conscious experience in patients under anesthesia and in subjects with locked-in syndrome or in an apparent vegetative state. In cases where brain architecture differs significantly from the original cases, perhaps some coma cases, infants, and animals, the evidence will be quite imperfect, but it will at least be suggestive. These systems might also serve as a crucial step toward a full science of consciousness. Once we know which systems are NCCs, we can investigate the mechanisms by which they work and how they produce various characteristic functional effects. Just as isolating the DNA basis of the gene helped explain many of the functional phenomena of life, isolating NCC systems may help explain many functional phenomena associated with consciousness. We might also systematize the relationship between NCCs and conscious states and the abstract general principles governing that relationship. In this way we might be led to a much greater theoretical understanding. In the meantime, the search for a neural correlate of consciousness provides a project that is relatively tractable, clearly defined, and theoretically neutral, whose goal seems to be visible somewhere in the middle distance. Because of this, the search makes an appropriate centerpiece for a developing science of consciousness and an important springboard in the quest for a general theory of the relationship between physical processes and conscious experience. 4. On the search for the neural correlate of consciousness. How can one search for the neural correlate of consciousness? As we all know, measuring consciousness is problematic because the phenomenon is not directly and straightforwardly observable. It would be much easier if we had a way of getting at consciousness directly if we had, for example, a consciousness meter. If we had such an instrument, searching for the NCC would be straightforward. We would wave the consciousness meter and measure a subject's consciousness directly. At the same time, we would monitor the underlying brain processes. After a number of trials, we would say such and such brain processes are correlated with conscious experiences of various kinds, so these brain processes are the neural correlates of consciousness. Alas, we have no consciousness meter, and for principled reasons it seems we cannot have one. Consciousness is just not the sort of thing that can be measured directly. What, then, do we do without a consciousness meter? How can the search go forward? How does all the experimental research on neural correlates of consciousness proceed? I think the answer is as follows. We get there with principles of interpretation, which we use to interpret physical systems to judge the presence of consciousness. We might call these pre-experimental bridging principles. They are the criteria that we bring to bear in looking at systems to say, 1. Whether or not they are conscious now, and 2. Which information they are conscious of and which they are not. We cannot reach indirectly and grab those experiences, so we rely on external criteria instead. That is a perfectly reasonable thing to do. But something interesting is going on. These principles of interpretation are not themselves experimentally determined or experimentally tested. In a sense, they are pre-experimental assumptions. Experimental research gives us a lot of information about processing, then we bring in the bridging principles to interpret the experimental results, whatever they may be. They are the principles by which we make inferences from facts about processing to facts about consciousness, and so they are conceptually prior to the experiments themselves. We cannot actually refine them experimentally, except perhaps by first-person experimentation, because we have no independent access to the independent variable. Instead, these principles will be based on some combination of 1. conceptual judgments about what counts as a conscious process, and 2. Information gleaned from our first-person perspective on our own consciousness. We are all stuck in this boat. The point applies whether one is a reductionist or an anti-reductionist about consciousness. A hardline reductionist might put some of these points a little differently, but either way the experimental work will require pre-experimental reasoning to determine the criteria for ascribing consciousness. Of course, such principles are usually left implicit in empirical research. We do not usually see papers saying here is the bridging principle, here are the data, and here is what follows, but it is useful to make them explicit. The very presence of these principles has strong and interesting consequences in the search for the NCC. In a sense, in relying on these principles we are taking a leap into the epistemological unknown. Because we do not measure consciousness directly, we have to make something of a leap of faith. It may not be a big leap, but it nevertheless suggests that everyone doing this work is engaged in philosophical reasoning. Of course, one can always choose to stay on solid ground, talking about the empirical results in a neutral way, but the price of doing so is that one gains no particular insight into consciousness. Conversely, as soon as we draw any conclusions about consciousness, we have gone beyond the information given. So we need to pay careful attention to the reasoning involved. What are these principles of interpretation? The first and by far the most prevalent is the principle of verbal report. When someone says, "Yes, I see that table now," we infer that the subject is conscious of the table. When someone says, "Yes, I see red now," we infer that the subject is having an experience of red. Of course, one might always say, "How do you know?" A philosopher might suggest that we may be faced with a fully functioning zombie, but in fact most of us do not believe that the people around us are zombies, and in practice we are quite prepared to rely on this principle. As pre-experimental assumptions go, this one is relatively safe, it does not require a huge leap of faith, and it is very widely used. The principle here is that when information is verbally reported, it is conscious. One can extend this principle slightly, for no one believes an actual verbal report is required for consciousness. We are conscious of much more than we report on any given occasion. An extended principle might say that when information is directly available for verbal report, it is conscious. Experimental researchers do not rely only on these principles of verbal report and reportability. The principles can be somewhat limiting when we want to do broader experiments. In particular, we do not want to restrict our studies of consciousness to subjects that have language. The work of Nikos Logothetis and his colleagues discussed in the last two chapters, example Logothetis and Schall 1989, Leopold and Logothetis 1996, Scheinberg and Logothetis 1997, provides a beautiful example of experimental work on consciousness in non-human animals. This work uses experiments on monkeys to draw conclusions about the neural processes associated with consciousness. How do Logothetis et al. Manage to draw conclusions about a monkey's consciousness without getting any verbal reports? They rely on the monkeys pressing bars. If the monkey can be made to press a bar in an appropriate way in response to a stimulus, we can say that that stimulus was consciously perceived. The criterion at play seems to require that the information be available for an arbitrary response. If it turned out that the monkey could press a bar in response to a red light but could do nothing else, we would be tempted to say that it was not a case of consciousness at all but some sort of subconscious connection. If, on the other hand, we find information that is available for response in all sorts of different ways, then we will say that it is conscious. The underlying general principle is something like this: when information is directly available for global control in a cognitive system, then it is conscious. If information is available for response in many motor modalities, we will say it is conscious, at least in a range of relatively familiar systems such as humans, other primates, and so on. This principle squares well with the preceding one in cases where the capacity for verbal report is present. Availability for verbal report and availability for global control seem to go together in such cases. Report is one of the key aspects of control, after all, and it is rare to find information that is reportable but not available more widely. But this principle is also applicable when language is not present. A correlation between consciousness and global availability, for short, seems to fit the first-person evidence that gleaned from our own conscious experience quite well. When information is present in my consciousness, it is generally reportable, and it can generally be brought to bear in controlling behavior in all sorts of ways. I can talk about it, I can point in the general direction of a stimulus, I can press bars, and so on. Conversely, when we find information that is directly available in this way for report and other aspects of control, it is generally conscious information. One can bear out this idea by considering cases. There are some tricky puzzle cases to consider, such as blind sight, where one has some availability for control but arguably no conscious experience. Those cases might best be handled by invoking the directness of availability. Insofar as the information here is available for report and other control processes at all, the availability is indirect by comparison to the direct and automatic availability in standard cases. To exclude cases of involuntary unconscious response, one might also restrict the criterion to availability for voluntary control, although that is a complex issue. 1. In any case, the resulting principle remains at best a first-order approximation of the functional criteria that come into play. Here, I am less interested in getting all of the fine details right than in exploring the consequences of the idea that some such functional criterion is required and is implicit in all of the empirical research on the neural correlate of consciousness. If you disagree with the criterion I have suggested, presumably because you can think of counterexamples, you may want to use those examples to refine it or to come up with a better criterion of your own. The crucial point is that in the very act of experimentally distinguishing conscious from unconscious processes, some such criterion is always at play. If something like this is right, then what follows? That is, if some such bridging principles are implicit in the methodology for the search for the NCC, then what are the consequences? I use global availability as my main functional criterion in this discussion, but many of the points should generalize. The first thing one can do is produce what philosophers might call a rational reconstruction of the search for the neural correlate of consciousness. 2. With a rational reconstruction we can say, maybe things do not work exactly like this in practice, but the rational underpinnings of the procedure have something like this form. That is, if one were to try to justify the conclusions one has reached as well as possible, one's justification would follow the shape of the rational reconstruction. In this case, a rational reconstruction might look something like this. 1. Consciousness left-right arrow global availability, bridging principle. 2. Global availability left-right arrow neural process N, empirical work. 3. Consciousness left-right arrow neural process N, conclusion. According to this reconstruction, one implicitly embraces some sort of pre-experimental bridging principle that one finds plausible on independent grounds, such as conceptual or phenomenological grounds. Then one does the empirical research. Instead of measuring consciousness directly, we detect the functional property. We see that when this functional property, example global availability, is present, it is correlated with a specific neural process, example 40 Hz oscillations. Combining the pre-empirical premise and the empirical result, we arrive at the conclusion that this neural process is a candidate for the NCC. Of course, it does not work nearly so simply in practice. The two stages are highly intertwined. Our pre-experimental principles may themselves be refined as experimental research goes along. Nevertheless, I think one can make a separation into pre-experimental and experimental components for the sake of analysis. With this rational reconstruction in hand, what sort of conclusions follow? We can draw out at least the following 6 consequences. 1. The first conclusion is a characterization of the neural correlates of consciousness. If the NCC is arrived at via this methodology, then whatever it turns out to be, it will be a mechanism of global availability. The presence of the NCC wherever global availability is present suggests that it is a mechanism that subserves global availability in the brain. The only alternative is that it might be a symptom rather than a mechanism of global availability, but in principle that possibility ought to be addressable by dissociation studies, lesioning, and so on. If a process is a mere symptom of availability, we ought to be able to empirically dissociate it from global availability while leaving the latter intact. The resulting data would suggest to us that consciousness can be present even when the neural process in question is not, thus indicating that it was not a perfect correlate of consciousness after all. A related line of reasoning supports the idea that a true NCC must be a mechanism of direct availability for global control. In principle, mechanisms of indirect availability will be dissociable from the empirical evidence for consciousness, for example by directly stimulating the mechanisms of direct availability. The indirect mechanisms will be screened off by the direct mechanisms in much the same way as the retina is screened off as an NCC by the visual cortex. In fact, if one looks at the various proposals, this template seems to fit them fairly well. For example, the 40 Hz oscillations discussed by Crick and Cook were put forward precisely because of the role they might have in binding and integrating information into working memory, and working memory is of course a major mechanism whereby information is made available for global control in a cognitive system. Similarly, it is plausible that Libet's extended neural activity is relevant precisely because the temporal extendedness of activity gives certain information the capacity to dominate later processes that lead to control. Barz's global workspace is a particularly clear example of such a mechanism. It is put forward explicitly as a mechanism whereby information can be globally disseminated. All of these mechanisms and many of the others seem to be candidates for mechanisms of global availability in the brain. 2. This reconstruction suggests that a full story about the neural processes associated with consciousness will do two things. First, it will explain global availability in the brain. Once we know all about the relevant neural processes, we will know precisely how information is made directly available for global control in the brain, and this will be an explanation in the full sense. Global availability is a functional property, and as always the problem of explaining a function's performance is a problem to which mechanistic explanation is well suited. So we can be confident that within a century or two, global availability will be straightforwardly explained. Second, this explanation of availability will do something else. It will isolate the processes that underlie consciousness itself. If the bridging principle is granted, then mechanisms of availability will automatically be correlates of phenomenology in the full sense. Unsurprisingly, I do not think this is a full explanation for consciousness. One can always ask why these processes of availability should give rise to consciousness in the first place. As yet we cannot explain why they do so, and it may well be that even full details about the processes of availability will not answer this question. Certainly, nothing in the standard methodology I have outlined answers the question. That methodology assumes a relation between availability and consciousness and therefore does nothing to explain it. The relationship between the two is instead taken as something of a primitive. So the hard problem remains. But who knows? Somewhere along the line we may be led to the relevant insights that show why the link is there, and the hard problem may then be solved. In the meantime, whether or not we have solved the hard problem, we may nevertheless have isolated the basis for consciousness in the brain. We just have to keep in mind the distinction between correlation and explanation. 3. Given this paradigm, it is likely that there will be many neural correlates of consciousness. This suggestion mirrors an unsurprising suggestion in the last chapter, but this time the rational reconstruction illustrates just why such a multiplicity of correlates should exist. There will be many neural correlates of consciousness because there will be many mechanisms of global availability. There will be mechanisms in different modalities. The mechanisms of visual availability may be quite different from the mechanisms of auditory availability, for example. Of course, they may be the same in that we could find a system that integrates and disseminates all of this information, but that is an open question. There will also be mechanisms at different stages in the processing path whereby information is made globally available, early mechanisms and later ones. All of these may be candidates for the NCC. Furthermore, we will find mechanisms at many levels of description. For example, 40 Hz oscillations may well be redscribed as high-quality representations or as part of a global workspace at a different level of description. It may therefore turn out that a number of the animals in the zoo, so to speak, can coexist because they are compatible in one of these ways. I will not speculate much further on just what the neural correlates of consciousness are. No doubt some of the ideas in the initial list will prove to be entirely off track, and some of the others will prove closer to the mark, but I hope the conceptual issues are becoming clearer. 4. This way of thinking about things allows one to make sense of an idea that is sometimes floated, that of a consciousness module. Sometimes this notion is disparaged, sometimes it is embraced. The analysis given here suggests that it is at least possible that such a module exists. What would it take? It would require some sort of functionally localizable, internally integrated system through which all global availability runs. The system need not be anatomically localizable, but to qualify as a module it would need to be localizable in some broader sense. For example, the parts of the module would have to have high bandwidth communication among themselves, compared to the relatively low bandwidth communication that they have with other areas. Such a thing could turn out to exist. It does not strike me as especially likely that things will turn out this way. It seems just as likely that we will find multiple independent mechanisms of global availability in the brain, scattered around without much mutual integration. If that is the result, we will probably say that there is no consciousness module after all. But that is an empirical question. If something like this module did turn out to exist in the brain, it would resemble Barz's conception of a global workspace, a functional area responsible for integrating information in the brain and disseminating it to multiple non-conscious, specialized processes. Many of the ideas I put forward here are compatible with things that Barz has said about the role of global availability in the study of consciousness. Indeed, this way of looking at things suggests that some of his ideas are direct consequences of the methodology. The special epistemological role of global availability helps explain why the idea of a global workspace is a useful way of thinking about almost any empirical proposal about consciousness. If NCCs are identified as such precisely because of their role in global control, then at least on a first approximation, we should expect the global workspace idea to be a natural fit. 5. We can apply this picture to the question of whether the neural correlates of visual consciousness are to be found in 6, in the extrastriate visual cortex, or elsewhere. If our picture of the methodology is correct, then the answer depends on which visual area is most directly implicated in global availability. Crick and Cook, 1995, have suggested that the visual NCC is not to be found within 6, because 6 does not contain neurons that project to the prefrontal cortex. This reasoning has been criticized by Ned Block for conflating access consciousness and phenomenal consciousness, see Block 1995. Interestingly, the picture I have developed suggests that it may be good reasoning. The prefrontal cortex is known to be associated with control processes, so if a given area in the visual cortex projects to prefrontal areas, then it may well be a mechanism of direct availability. If it does not project in this way, it is less likely to be such a mechanism. At best it might be indirectly associated with global availability. Of course, we still have plenty of room to raise questions about the empirical details. The broader point is that for the sort of reasons discussed in 2 earlier, it is likely that the neural processes involved in explaining access consciousness will simultaneously be involved in a story about the basis of phenomenal consciousness. If something like this idea is implicit in their reasoning, Crick and Cook might escape the charge of conflation. Of course, the reasoning depends on these somewhat shaky bridging principles, but then all work on the neural correlates of consciousness must appeal to such principles somewhere, so this limitation cannot be held against Crick and Cook in particular. 2. 6. Sometimes the neural correlate of consciousness is conceived of as a holy grail for a theory of consciousness. It will make everything fall into place. For example, once we discover the NCC, then we will have a definitive test for consciousness, enabling us to discover consciousness wherever it arises. That is, we might use the neural correlate itself as a sort of consciousness meter. If a system has 40 Hz oscillations, say, then it is conscious; if it has none, then it is not conscious. Or if a thalamocortical system turns out to be the NCC, then a system without such a system is unlikely to be conscious. This sort of reasoning is not usually put quite so baldly, but I think one finds some version of it quite frequently. This reasoning can be tempting, but one should not succumb to the temptation. Given the very methodology that comes into play here, we have no way of definitely establishing a given NCC as an independent test for consciousness. The primary criterion for consciousness will always remain the functional property we started with, global availability or verbal report or whatever. That is how we discovered the correlations in the first place. In other words, 40 Hz oscillations, or whatever, are relevant because of their role in satisfying this criterion. True, in cases where we know that this association between the NCC and the functional property is present, the NCC might itself function as a sort of signature of consciousness, but once we dissociate the NCC from the functional property, all bets are off. To take an extreme example, if we have 40 Hz oscillations in a test tube, that condition almost certainly will not yield consciousness, but the point applies equally in less extreme cases. Because it was the bridging principles that gave us all the traction in the search for an NCC in the first place, it is not clear that anything follows in cases where the functional criterion is thrown away. So there is no free lunch here. One cannot get something for nothing. Once we recognize the central role of pre-experimental assumptions in the search for the NCC, we realize that there are limitations on just what we can expect the search to tell us. Still, whether or not the NCC is the Holy Grail, it is clear that the quest for it is likely to enhance our understanding considerably. I hope to have made a case that in this area, philosophy and neuroscience can come together to help clarify some of the deep problems involved in the study of consciousness. Part 3. The Metaphysics of Consciousness. Consciousness and its place in nature. 1. Introduction. Consciousness fits uneasily into our conception of the natural world. On the most common conception of nature, the natural world is the physical world. But on the most common conception of consciousness, it is not easy to see how it could be part of the physical world. So it seems that to find a place for consciousness within the natural order, we must either revise our conception of consciousness or revise our conception of nature. In 20th century philosophy, this dilemma is posed most acutely in C.D. Broad's The Mind and Its Place in Nature, 1925. For Broad, the phenomena of mind are the phenomena of consciousness. The central problem is that of locating mind with respect to the physical world. Broad's exhaustive discussion of the problem culminates in a taxonomy of 17 different views of the mental-physical relation. 1. In Broad's taxonomy, a view might see the mental as non-existent, delusive, as reducible, as emergent, or as a basic property of a substance, a differentiating attribute. The physical might be seen in one of the same four ways. So a 4x4 matrix of views results. The 17th entry arises from Broad's division of the substance/substance view according to whether one or two substances are involved. At the end, three views are left standing, those on which mentality is an emergent characteristic of either a physical substance or a neutral substance, where in the latter case, the physical might be either emergent or delusive. In this chapter I take my cue from Broad, approaching the problem of consciousness by a strategy of divide and conquer. I do not adopt Broad's categories. Our understanding of the mind-body problem has advanced in the last 75 years, and it would be nice to think that we have a better understanding of the crucial issues. On my view, the most important views on the metaphysics of consciousness can be divided into 6 classes, which I label Type A through Type F. 3 of these, A through C, involve broadly reductive views, which see consciousness as a physical process that requires no expansion of a physical ontology. The other three, D through F, involve broadly non-reductive views, according to which consciousness involves something irreducible in nature and requires expansion or reconception of a physical ontology. The discussion in this chapter is cast at an abstract level, giving an overview of the metaphysical landscape. Rather than engaging the empirical science of consciousness or detailed philosophical theories of consciousness, I examine some general classes into which theories of consciousness might fall. I do not pretend to be neutral in this discussion. I think that each of the reductive views is incorrect, while each of the non-reductive views holds some promise. So the first part of this chapter is an extended argument against reductive views of consciousness, while the second part is an investigation of where we go from there. To the problem. A being is conscious in the sense I am concerned with when there is something it is like to be that being. A mental state is conscious when there is something it is like to be in that state. Conscious states include states of perceptual experience, bodily sensation, mental imagery, emotional experience, a current thought, and more. There is something it is like to see a vivid green, to feel a sharp pain, to visualize the Eiffel Tower, to feel a deep regret, and to think that one is late. Each of these states has a phenomenal character, with phenomenal properties, or qualia, that characterize what it is like to be in the state. 2. The hard problem of consciousness, Chapter 1, is that of explaining how and why physical processes give rise to phenomenal consciousness. A solution to the hard problem would involve an account of the relation between physical processes and consciousness, explaining on the basis of natural principles how and why it is that physical processes are associated with states of experience. A reductive explanation of consciousness will explain this wholly on the basis of physical principles that do not themselves make any appeal to consciousness. 3. A materialist, or physicalist, solution is a solution on which consciousness is itself seen as a physical process. A non-materialist, or non-physicalist, solution is a solution on which consciousness is seen as non-physical, even if closely associated with physical processes. A non-reductive solution is one on which consciousness, or principles involving consciousness, is admitted as a basic part of the explanation. It is natural to hope that there will be a materialist solution to the hard problem and a reductive explanation of consciousness, just as there have been reductive explanations of many other phenomena in many other domains. But we have already seen that consciousness seems to resist materialist explanation in a way that other phenomena do not. This resistance can be encapsulated in three related arguments against materialism, summarized in what follows. 3 arguments against materialism. 3.1 The explanatory argument. The first argument is grounded in the difference between the easy problems and the hard problem. The easy problems concern the explanation of behavioral and cognitive functions, but the hard problem does not. One can argue that by the character of physical explanation, physical accounts explain only structure and function, where the relevant structures are spatio-temporal structures, and the relevant functions are causal roles in the production of a system's behavior. Furthermore, one can argue as in Chapter 1 and 2 that explaining structures and functions does not suffice to explain consciousness. If so, no physical account can explain consciousness. We can call this the explanatory argument 4, formalized here as a mild variant on the 3-premise argument in Chapter 2. 1. Physical accounts explain at most structure and function. 2. Explaining structure and function does not suffice to explain consciousness. 3. No physical account can explain consciousness. If this is right, then while physical accounts can solve the easy problems, which involve only explaining functions, something more is needed to solve the hard problem. It would seem that no reductive explanation of consciousness could succeed. And if we add the premise that what cannot be physically explained is not itself physical, this can be considered an additional final step of the explanatory argument, then materialism about consciousness is false, and the natural world contains more than the physical world. Of course, this sort of argument is controversial. But before examining various ways of responding, it is useful to examine two closely related arguments that also aim to establish that materialism about consciousness is false. 3.2 The conceivability argument. According to this argument, it is conceivable that there be a system that is physically identical to a conscious being but that lacks at least some of that being's conscious states. 5. Such a system might be a zombie, a system that is physically identical to a conscious being but that lacks consciousness entirely. It might also be an 4. Invert, with some of the original being's experiences replaced by different experiences, or a partial zombie, with some experiences absent, or a combination thereof. These systems will look identical to a normal conscious being from the third-person perspective. In particular, their brain processes will be molecule for molecule identical with the original, and their behavior will be indistinguishable. But things will be different from the first-person point of view. What it is like to be an invert or a partial zombie will differ from what it is like to be the original being. And there is nothing it is like to be a zombie. There is little reason to believe that zombies exist in the actual world, but many hold that they are at least conceivable. We can coherently imagine zombies, and there is no contradiction in the idea that reveals itself even on reflection. As an extension of the idea, many hold that the same goes for a zombie world, a universe physically identical to ours but in which there is no consciousness. Something similar applies to inverts and other duplicates. From the conceivability of zombies, proponents of the argument infer their metaphysical possibility. Zombies are probably not naturally possible, they probably cannot exist in our world with its laws of nature. But the argument holds that zombies could have existed, perhaps in a very different sort of universe. For example, it is sometimes suggested that God could have created a zombie world if he had so chosen. From here, it is inferred that consciousness must be non-physical. If there is a metaphysically possible universe that is physically identical to ours but that lacks consciousness, then consciousness must be a further, non-physical component of our universe. If God could have created a zombie world, then, as Kripke puts it, after creating the physical processes in our world, he had to do more work to ensure that it contained consciousness. We can put the argument in its simplest form as follows. 1. It is conceivable that there are zombies. 2. If it is conceivable that there are zombies, it is metaphysically possible that there are zombies. 3. If it is metaphysically possible that there are zombies, then consciousness is non-physical. 4. Consciousness is non-physical. A somewhat more general and precise version of the argument appeals to P, the conjunction of all microphysical truths about the universe, and Q, an arbitrary phenomenal truth about the universe. Here, and represents and represents not. 1. It is conceivable that P and Q. 2. If it is conceivable that P and Q, it is metaphysically possible that P and CQ. 3. If it is metaphysically possible that P and Q, then materialism is false. 4. Materialism is false. 3.3 The knowledge argument. According to the knowledge argument, there are facts about consciousness that are not deducible from physical facts. 6. Someone could know all of the physical facts, be a perfect reasoner, and still be unable to know all of the facts about consciousness on that basis. Frank Jackson's canonical version of the argument, Jackson 1982, provides a vivid illustration. In this version, Mary is a neuroscientist who knows everything there is to know about the physical processes relevant to color vision. But she has been brought up in a black and white room. In an alternative version, she is colorblind 7, and has never experienced red. Despite all her knowledge, it seems that there is something very important about color vision that Mary does not know. She does not know what it is like to see red. Even complete physical knowledge and unrestricted powers of deduction do not enable her to know this. Later, if she comes to experience red for the first time, she will learn a new fact of which she was previously ignorant. She will learn what it is like to see red. Jackson's version of the argument can be put as follows. Here the premises concern Mary's knowledge when she has not yet experienced red. 1. Mary knows all the physical facts. 2. Mary does not know all the facts. 3. The physical facts do not exhaust all the facts. One can put the knowledge argument more generally. 8. 1. There are truths about consciousness that are not deducible from physical truths. 2. If there are truths about consciousness that are not deducible from physical truths, then materialism is false. 3. Materialism is false. 3.4 The shape of the arguments. These three sorts of argument are closely related. They all start by establishing an epistemic gap between the physical and the phenomenal domains. Each denies a certain sort of close epistemic relation between the domains, a relation involving what we can know or conceive or explain. In particular, each of them denies a certain sort of epistemic entailment from physical truths P to the phenomenal truths Q, deducibility of Q from P or explainability of Q in terms of P or conceiving of Q upon reflective conceiving of P. Perhaps the most basic sort of epistemic entailment is a priori entailment, or implication. On this notion, P implies Q when the conditional if P then Q is a priori, that is, when a subject can know that if P is the case, then Q is the case with justification independent of experience. All of these three arguments can be seen as making a case against the claim that P implies Q. If a perfect reasoner who knows only P cannot deduce that Q, as the knowledge argument suggests, or if one can rationally conceive of P without Q, as the conceivability argument suggests, then it seems that P does not imply Q. The explanatory argument can be seen as turning on the claim that an implication from P to Q would require a functional analysis of consciousness and that the concept of consciousness is not a functional concept. After establishing an epistemic gap, these arguments proceed by inferring an ontological gap, where ontology concerns the nature of things in the world. The conceivability argument infers from conceivability to metaphysical possibility, the knowledge argument infers from failure of deducibility to difference in facts, and the explanatory argument infers from failure of physical explanation to non-physicality. One might say that these arguments infer from a failure of epistemic entailment to a failure of ontological entailment. The paradigmatic sort of ontological entailment is necessitation. P necessitates Q when the conditional if P then Q is metaphysically necessary or when it is metaphysically impossible for P to hold without Q holding. It is widely agreed that materialism requires that P necessitates all truths, perhaps with minor qualifications. So if there are phenomenal truths Q that P does not necessitate, then materialism is false. We might call these arguments epistemic arguments against materialism. Epistemic arguments arguably descend from Descartes' arguments against materialism, although these have a slightly different form. As a class, they are given their first thorough airing in Broad's book, which contains elements of all three earlier arguments. 9. The general form of an epistemic argument against materialism is as follows. 1. There is an epistemic gap between physical and phenomenal truths. 2. If there is an epistemic gap between physical and phenomenal truths, then there is an ontological gap, and materialism is false. 3. Materialism is false. Of course, this way of looking at things oversimplifies matters and abstracts away from the differences between the arguments. 10. The same goes for the precise analysis in terms of implication and necessitation. Nevertheless, this analysis provides a useful lens through which we can see what the arguments have in common and analyze various responses to them. There are roughly three ways that a materialist might resist the epistemic arguments. A type A materialist denies the existence of the relevant sort of epistemic gap. A type B materialist accepts the existence of an unclosable epistemic gap but denies that there is an ontological gap. A type C materialist accepts the existence of a deep epistemic gap but holds that it will eventually be closed. In what follows, I discuss all three of these strategies. 4. Type A materialism. According to type A materialism, there is no epistemic gap between physical and phenomenal truths, or at least any apparent epistemic gap is easily closed. According to this view, it is not conceivable, at least on reflection, that there are duplicates of conscious beings that have absent or inverted conscious states. On this view, there are no phenomenal truths of which Mary is ignorant in principle from inside her black and white room. When she leaves the room, she gains at most an ability. And on this view, on reflection there is no hard problem of explaining consciousness that remains once one has solved the easy problems of explaining the various cognitive, behavioral, and environmental functions. 11. Type A materialism sometimes takes the form of eliminativism, holding that consciousness does not exist and that there are no phenomenal truths. It sometimes takes the form of analytic functionalism or logical behaviorism, which holds that consciousness exists, where the concept of consciousness is defined in wholly functional or behavioral terms. Example, where to be conscious might be to have certain sorts of access to information and / or certain sorts of dispositions to make verbal reports. For our purposes, the difference between these two views is terminological. Both agree that we are conscious in the sense of having the functional capacities of access, report, control, and the like, and they agree that we are not conscious in any further, non-functionally defined, sense. The analytic functionalist thinks that ordinary terms such as conscious should be used in the first sense, expressing a functional concept, while the eliminativist thinks that it should be used in the second. Beyond this terminological disagreement about the use of existing terms and concepts, the substance of the views is much the same. Some philosophers and scientists who do not explicitly embrace eliminativism, analytic functionalism, and the like are nevertheless recognizably type A materialists. The characteristic feature of the type A materialist is the view that on reflection there is nothing in the vicinity of consciousness that needs explaining over and above explaining the various functions. To explain these things is to explain everything that needs to be explained. The relevant functions may be quite subtle and complex, involving fine-grained capacities for access, self-monitoring, report, control, and their interaction, for example. They may also be taken to include all sorts of environmental relations. Furthermore, the explanation of these functions will probably involve much neurobiological detail, so views that are put forward as rejecting functionalism on the grounds that it neglects either biology or the role of the environment may still be type A views. One might think that there is room in logical space for a view that denies even this sort of broadly functionalist view of consciousness but still holds that there is no epistemic gap between physical and phenomenal truths. In practice, there appears to be little room for such a view for reasons that I discuss under type C, and there are few examples of such views in practice. 12. So I take it for granted that a type A view is one that holds that explaining the functions explains everything, and I class other views that hold that there is no unclosable epistemic gap under type C. The obvious problem with type A materialism is that it appears to deny the manifest. It is an uncontested truth that we have the various functional capacities of access, control, report, and the like, and these phenomena pose uncontested explananda, phenomena in need of explanation, for a science of consciousness. In addition, it seems to be a further truth that we are conscious, and this phenomenon seems to pose a further explanandum, one that raises the interesting problems of consciousness. To flatly deny the further truth, or to deny without argument that there is a hard problem of consciousness over and above the easy problems, would be to make a highly counterintuitive claim that begs the important questions. This is not to say that highly counterintuitive claims are always false, but they need to be supported by extremely strong arguments. So the crucial question is whether there are any compelling arguments for the claim that, on reflection, explaining the functions explains everything. Type A materialists often argue by analogy. They point out that in other areas of science, we accept that explaining the various functions explains the phenomena, so we should accept the same here. And they suggest that with phenomena such as life and heat, thinkers in the past have pointed out analogous epistemic gaps and that these phenomena turned out to be physically explained all the same. For reasons discussed in Chapter 1 and the afterword there, however, these analogies carry little force. In other domains, it has long been clear, even to vitalists, that the central explananda all involve structure and function, except perhaps for those tied directly to consciousness itself. 13. So the type A materialist needs to address the apparent further explanandum in the case of consciousness head-on, either flatly denying it or giving substantial arguments to dissolve it. Some arguments for type A materialists proceed indirectly by pointing out the unsavory metaphysical or epistemological consequences of rejecting the view, for instance, that the rejection leads to dualism or to problems involving knowledge of consciousness. 14. An opponent will either embrace the consequences or deny that they are consequences. As long as the consequences are not completely untenable, then for the type A materialist to make progress, this sort of argument needs to be supplemented by a substantial direct argument against the further explanandum. Such direct arguments are surprisingly hard to find. Many arguments for type A materialism end up presupposing the conclusion at crucial points. For example, it is sometimes argued, example Ray 1995, that there is no reason to postulate qualia since they are not needed to explain behavior, but this argument presupposes that only behavior needs explaining. The opponent will hold that qualia are an explanandum in their own right. Similarly, Dennett's use of heterophenomenology, verbal reports, as the primary data to ground his theory of consciousness, Dennett 1991, appears to rest on the assumption that these reports are what need explaining or that the only seemings that need explaining are dispositions to react and report. One way to argue for type A materialism is to argue that there is some intermediate X such that, I, explaining function suffices to explain X and, 2, explaining X suffices to explain consciousness. One possible X here is representation. It is often held both that conscious states are representational states, representing things in the world, and that we can explain representation in functional terms. If so, it may seem to follow that we can explain consciousness in functional terms. On examination, though, this argument appeals to an ambiguity in the notion of representation. There is a notion of functional representation, on which P is represented roughly when a system responds top and / or produces behavior appropriate for P. In this sense, explaining functioning may explain representation, but explaining representation does not explain consciousness. There is also a notion of phenomenal representation, on which P is represented roughly when a system has a conscious experience as if. In this sense, explaining representation may explain consciousness, but explaining functioning does not explain representation. Either way, the epistemic gap between the functional and the phenomenal remains as wide as ever. Similar sorts of equivocation can be found with other examples of X that might be appealed to here, such as perception or information. Perhaps the most interesting arguments for type A materialism are those that maintain that we can give a physical explanation of our beliefs about consciousness, such as the belief that we are conscious, the belief that consciousness is a further explanandum, and the belief that consciousness is non-physical. From here it is argued that once we have explained the belief, we have done enough to explain, or to explain away, the phenomenon, example Clark 2000, Dennett 2001. Here it is worth noting that this works only if the beliefs themselves are functionally analyzable. In Chapter 8 I give some reasons to deny this. But even if one accepts that beliefs are ultimately functional, this claim then reduces to the claim that explaining our dispositions to talk about consciousness, and the like, explains everything. An opponent will deny this claim. Explaining the dispositions to report may remove the third-person warrant, based on observation of others, for accepting a further explanandum, but it does not remove the crucial first-person warrant, from one's own case. Still, this is a strategy that deserves extended discussion. At a certain point, the debate between type A materialists and their opponents usually comes down to intuition, most centrally, the intuition that consciousness, in a non-functionally defined sense, exists or that there is something that needs to be explained, over and above explaining the functions. This claim does not gain its support from argument but from a sort of observation, along with rebuttal of counterarguments. The intuition appears to be shared by the large majority of philosophers, scientists, and others, and it is so strong that to deny it, a type A materialist needs exceptionally powerful arguments. The result is that even among materialists, type A materialists are a distinct minority. 5. Type B materialism. According to type B materialism, there is an epistemic gap between the physical and phenomenal domains, but there is no ontological gap. 15. According to this view, zombies and the like are conceivable, but they are not metaphysically possible. On this view, Mary is ignorant of some phenomenal truths from inside her room, but nevertheless these truths concern an underlying physical reality. When she leaves the room, she learns old facts in a new way. And on this view, while there is a hard problem distinct from the easy problems, it does not correspond to a distinct ontological domain. The most common form of type B materialism holds that phenomenal states can be identified with certain physical or functional states. This identity is held to be analogous in certain respects, although perhaps not in all respects, with the identity between water and H2O or between genes and DNA. 16. These identities are not derived through conceptual analysis but are discovered empirically. The concept water is different from the concept H20, but they are found to refer to the same thing in nature. On the type B view, something similar applies to consciousness. The concept of consciousness is distinct from any physical or functional concepts, but we may discover empirically that these refer to the same thing in nature. In this way, we can explain why there is an epistemic gap between the physical and phenomenal domains while still denying any ontological gap. This yields the attractive possibility that we can acknowledge the deep epistemic problems of consciousness while retaining a materialist worldview. Although such a view is attractive, it faces immediate difficulties. These stem from the fact that the character of the epistemic gap with consciousness seems to differ from that of epistemic gaps in other domains. For a start, there do not seem to be analogues of the earlier epistemic arguments in the cases of water, genes, and so on. To explain genes, we merely have to explain why systems function a certain way in transmitting hereditary characteristics. To explain water, we have to explain why a substance has a certain objective structure and behavior. Given a complete physical description of the world, Mary would be able to deduce all of the relevant truths about water and about genes by deducing which systems have the appropriate structure and function. Finally, it seems that we cannot coherently conceive of a world physically identical to our own, in which there is no water or in which there are no genes. So there is no epistemic gap between the complete physical truth about the world and the truth about water and genes that is analogous to the epistemic gap with consciousness, except perhaps for epistemic gaps that derive from the epistemic gap for consciousness. For example, perhaps Mary could not deduce or explain the perceptual appearance of water from the physical truth about the world, but this would just be another instance of the problem we are concerned with and so cannot help the type B materialist. So it seems that there is something unique about the case of consciousness. We can put this by saying that while the identity between genes and DNA is empirical, it is not epistemically primitive. The identity is itself deducible from the complete physical truth about the world. By contrast, the type B materialist must hold that the identification between consciousness and physical or functional states is epistemically primitive. The identity is not deducible from the complete physical truth. If it were deducible, type A materialism would be true instead. So the identity between consciousness and a physical state will be a sort of primitive principle in one's theory of the world. Here, one might suggest that something has gone wrong. Elsewhere, the only place that one finds this sort of primitive principle is in the fundamental laws of physics. Indeed, it is often held that this sort of primitiveness, the inability to be deduced from more basic principles, is the mark of a fundamental law of nature. In effect, the type B materialist recognizes a principle that has the epistemic status of a fundamental law but gives it the ontological status of an identity. An opponent will hold that this move is more akin to theft than to honest toil. Elsewhere, identifications are grounded in explanations, and primitive principles are acknowledged as fundamental laws. It is natural to suggest that the same should apply here. If one acknowledges the epistemically primitive connection between physical states and consciousness as a fundamental law, it will follow that consciousness is distinct from any physical property, since fundamental laws always connect distinct properties. So the usual standard will lead to one of the non-reductive views discussed in the second half of this chapter. By contrast, the type B materialist takes an observed connection between physical and phenomenal states, unexplainable in more basic terms, and suggests that it is an identity. This suggestion is made largely in order to preserve a prior commitment to materialism. Unless there is an independent case for primitive identities, the suggestion will seem at best ad hoc and mysterious and at worst incoherent. A type B materialist might respond in various ways. First, some, example Papineau 1993, suggest that identities do not need to be explained and are always primitive. However, we have seen that identities in other domains can at least be deduced from more basic truths and so are not primitive in the relevant sense. Second, some, example Bloch and Stallnaker 1999, suggest that even truths involving water and genes cannot be deduced from underlying physical truths. I argue in Chapter 7 that these responses are unsuccessful. For now, one can note that the epistemic arguments outlined at the beginning suggest a very strong disanalogy between consciousness and other cases. There is another line that a type B materialist can take. One can first note that an identity between consciousness and physical states is not strictly required for a materialist position. Rather, one can plausibly hold that materialism about consciousness simply requires that physical states necessitate phenomenal states in that it is metaphysically impossible for the physical states to be present while the phenomenal states are absent or different. That is, materialism requires that entailments P d Q be necessary, where P is the complete physical truth about the world and Q is an arbitrary phenomenal truth. At this point, a type B materialist can naturally appeal to the work of Kripke, 1980, which suggests that some truths are necessarily true without being a priori. For example, Kripke suggests that water is H2O is necessary true in all possible worlds but not knowable a priori. Here, a type B materialist can suggest that PDQ may be a Kripkean a posteriori necessity, like water is H2O, though Kripke himself denies this claim. If so, then we would expect there to be an epistemic gap since there is no a priori entailment from P to Q, but at the same time there will be no ontological gap. In this way, Kripke's work can seem to be just what the type B materialist needs. Here, some of the issues that arose previously arise again. One can argue that in other domains, necessities are not epistemically primitive. The necessary connection between water and H2O may be a posteriori, but it can itself be deduced from a complete physical description of the world. One can deduce that water is identical to H2O, from which it follows that water is necessarily H2O. The same applies to the other necessities that Kripke discusses. By contrast, the type B materialist must hold that the connection between physical states and consciousness is epistemically primitive in that it cannot be deduced from the complete physical truth about the world. Again, one can suggest that this sort of primitive necessary connection is mysterious and ad hoc and that the connection should instead be viewed as a fundamental law of nature. I discuss these necessities and their problems at much greater length in Chapter 6. For now, it is worth noting that there is a sense in which any type B materialist position gives up on reductive explanation. Even if type B materialism is true, we cannot give consciousness the same sort of explanation that we give genes and the like in purely physical terms. Rather, our explanation will always require explanatorily primitive principles to bridge the gap from the physical to the phenomenal. The explanatory structure of a theory of consciousness, on such a view, will be very much unlike that of a materialist theory in other domains and very much like the explanatory structure of the non-reductive theories described later. If one labels these principles identities or necessities rather than laws, the view may preserve the letter of materialism, but by requiring primitive bridging principles, one sacrifices much of materialism's spirit. Perhaps the most interesting response from a type B materialist is to acknowledge that the epistemic gap is unique to the case of consciousness and to try to explain this uniqueness in terms of special features of our conceptual system. I discuss this response in Chapter 10, where I argue that the strategy cannot help the materialist. For the special features of our conceptual system to explain the unique epistemic gap in the case of consciousness, These features will themselves pose an explanatory gap that is as large as the original. 7. Type C materialism. According to Type C materialism, there is a deep epistemic gap between the physical and phenomenal domains, but it is closable in principle. On this view, zombies and the like are conceivable for us now, but they will not be conceivable in the limit. The view holds that while it currently seems that Mary lacks information about the phenomenal, in the limit there would be no information that she lacks. And while we cannot see now how to solve the hard problem in physical terms, the problem is solvable in principle. This view is initially very attractive. It seems to acknowledge the deep explanatory gap with which we are faced while at the same time allowing that the apparent gap may be due to our own limitations. There are different versions of the view. Nagel, 1974, has suggested that just as the pre-Socratics could not have understood how matter could be energy, we cannot understand how consciousness could be physical, but a conceptual revolution might allow the relevant understanding. Chitchland, 1997, suggests that even if we cannot now imagine how consciousness could be a physical process, that is simply a psychological limitation on our part that further progress in science will overcome. Van Golik, 1993, suggests that conceivability arguments are question-begging since once we have a good explanation of consciousness, zombies and the like will no longer be conceivable. McGinn, 1989, has suggested that the problem may be unsolvable by humans due to deep limitations in our cognitive abilities but that it nevertheless has a solution in principle. Staljar, 2007, argues that zombies are conceivable for us because we are ignorant of some crucial fact but that once we learn that fact they may no longer be conceivable. One way to put the view is as follows. Zombies and the like are prima facie conceivable, for us now, with our current cognitive processes, but they are not ideally conceivable, under idealized rational reflection. Alternatively, we could say that phenomenal truths are deducible in principle from physical truths, but the deducibility is akin to that of a complex truth of mathematics. It is accessible in principle, perhaps accessible a priori, but is not accessible to us now, perhaps because the reasoning required is currently beyond us or perhaps because we do not currently grasp all of the required physical truths. If this is so, then there will appear to us that a gap exists between physical processes and consciousness, but there will be no gap in nature. Despite its appeal, the Type C view is inherently unstable. Upon examination, it turns out either to be untenable or to collapse into one of the other views on the table. In particular, I think that the view must collapse into a version of Type A materialism, Type B materialism, Type D dualism, or Type F monism and so is not ultimately a distinct option. One way to hold that the epistemic gap might be closed in the limit is to hold that in the limit we will see that explaining the functions explains everything and that there is no further explanandum. It is at least coherent to hold that we currently suffer from some sort of conceptual confusion or unclarity that leads us to believe that there is a further explanandum and that this situation could be cleared up by better reasoning. I count this position as a version of Type A materialism, not Type C materialism. The position is obviously closely related to standard Type A materialism, the main difference is whether we have yet had the relevant insight, and the same issues arise. Like standard Type A materialism, this view ultimately stands or falls with the strength of actual and potential, first-order arguments that dissolve any apparent further explanandum. Once Type A materialism is set aside, the potential options for closing the epistemic gap are highly constrained. These constraints are grounded in the nature of physical concepts and in the nature of the concept of consciousness. The basic problem has already been mentioned. First, physical descriptions of the world characterize the world in terms of structure and dynamics. Second, from truths about structure and dynamics, one can deduce only further truths about structure and dynamics. Third, truths about consciousness are not truths about structure and dynamics. We can take these steps one at a time. First, a microphysical description of the world specifies a distribution of particles, fields, and waves in space and time. These basic systems are characterized by their spatiotemporal properties and properties such as mass, charge, and quantum wave function state. These latter properties are ultimately defined in terms of spaces of states that have a certain abstract structure, example the space of continuously varying real quantities or of Hilbert space states, such that the states play a certain causal role with respect to other states. We can subsume spatiotemporal descriptions and descriptions in terms of properties in these formal spaces under the rubric of structural descriptions. The state of these systems can change over time in accord with dynamic principles, perhaps involving laws of nature, defined over the relevant properties. The result is a description of the world in terms of its underlying spatiotemporal and formal structure and dynamic evolution over this structure. 17. Some Type C materialists hold that we do not yet have a complete physics, so we cannot know what such a physics might explain. But here we do not need to have a complete physics. We simply need the claim that physical descriptions are in terms of structure and dynamics. This point is general across physical theories. Novel theories such as relativity and quantum mechanics may introduce new structures and new dynamics over those structures, but the general point, and the gap with consciousness, remains. A Type C materialist might hold that there could be new physical theories that go beyond structure and dynamics, but given the character of physical explanation, it is unclear what sort of theory this could be. Novel physical properties are postulated for their potential in explaining existing physical phenomena, themselves characterized in terms of structure and dynamics, and it seems that structure and dynamics always suffice here. One possibility is that instead of postulating novel properties, physics might end up appealing to consciousness itself in the way that some theorists hold that quantum mechanics does. This possibility cannot be excluded, but it leads to a view on which consciousness is itself irreducible and is therefore to be classed in a non-reductive category, type D or type F. There is one appeal to a complete physics that should be taken seriously. This is the idea that current physics characterizes its underlying properties, such as mass and charge, in terms of abstract structures and relations, but it leaves open their intrinsic natures. According to this view, a complete physical description of the world must also characterize the intrinsic properties that ground these structures and relations, and once such intrinsic properties are invoked, physics will go beyond structure and dynamics in such a way that truths about consciousness may be entailed. The relevant intrinsic properties are unknown to us, but they are knowable in principle. This is an important position, but it is precisely the position discussed under type F, so I defer discussion of it until then. Second, what can be inferred from this sort of description in terms of structure and dynamics? A low-level microphysical description can entail all sorts of surprising and interesting macroscopic properties, as with the emergence of chemistry from physics, of biology from chemistry, or more generally of complex emergent behaviors in complex systems theory. In all of these cases, however, the complex properties that are entailed are nevertheless structural and dynamic. They describe complex spatiotemporal structures and complex dynamic patterns of behavior over those structures, so these cases support the general principle that, from structure and dynamics, one can infer only structure and dynamics. 18. A type C materialist might suggest there are some truths that are not themselves structural dynamic but are nevertheless implied by a structural dynamic description. It might be argued, perhaps, that truths about representation or belief have this character. As we saw earlier, however, it seems clear that any sense in which these truths are implied by a structural dynamic description involves a tacitly functional sense of representation or belief. This is what we would expect, if claims involving these can be seen, on conceptual grounds, to be true in virtue of structural dynamic description holding, then the notions involved must themselves be structural dynamic at some level. One might hold that there is some intermediate notion X, such that truths about X hold in virtue of structural dynamic descriptions and such that truths about consciousness hold in virtue of X. As in the case of type A materialism, however, either X is functionally analyzable, in the broad sense, in which case the second step fails, or X is not functionally analyzable, in which case the first step fails. This is brought out clearly in the case of representation. For the notion of functional representation, the first step fails, and for the notion of phenomenal representation, the second step fails. So this sort of strategy can only work by equivocation. Third, does explaining or deducing complex structure and dynamics suffice to explain or deduce consciousness? For the usual reasons, it seems clearly not. Mary could know from her black and white room all about the spatio-temporal structure and dynamics of the world at all levels, but this will not tell her what it is like to see red. For any complex macroscopic structural or dynamic description of a system, one can conceive of that descriptions being satisfied without consciousness. And explaining the structure and dynamics of a human system is only to solve the easy problems while leaving the hard ones untouched. To resist this last step, an opponent would have to hold that explaining structure and dynamics thereby suffices to explain consciousness. The only remotely tenable way to do this would be to embrace type A materialism, which we have set aside. A type C materialist might suggest that instead of leaning on dynamics, as a type A materialist does, one could lean on structure. Here, spatio-temporal structure seems unpromising. To explain a system's size, shape, position, motion, and so on is clearly not to explain consciousness. A final possibility is to lean on the structure present in conscious states themselves. Conscious states have structure, there is internal structure within a single complex conscious state, and there are also patterns of similarities and differences between conscious states. But this structure is a distinctively phenomenal structure that is quite different in kind from the spatio-temporal and formal structure present in physics. The structure of a complex phenomenal state is not spatio-temporal structure, although it may involve the representation of spatio-temporal structure, and the similarities and differences between phenomenal states are not formal similarities and differences but differences between specific phenomenal characters. 19. This is reflected in the fact that one can conceive of any spatio-temporal structure and formal structure without any associated phenomenal structure, one can know about the first without knowing about the second, and so on. So the epistemic gap is as wide as ever. The basic problem with any type C materialist strategy is that epistemic implication from A to B requires some sort of conceptual hook by virtue of which the condition described in A can satisfy the conceptual requirements for the truth of B. When a physical account implies truths about life, for example, it does so in virtue of implying information about the macroscopic functioning of physical systems of the sort required for life. Here, broadly functional notions provide the conceptual hook. In the case of consciousness, by contrast, no such conceptual hook is available, given the structural dynamic character of physical concepts and the quite different character of the concept of consciousness. Ultimately, it seems that any type C strategy is doomed for familiar reasons. Once we accept that the concept of consciousness is not itself a functional concept and that physical descriptions of the world are structural dynamic descriptions, there is simply no conceptual room for it to be implied by a physical description. The only room left is to hold that consciousness is a broadly functional concept after all, accepting type A materialism, or that there is more in physics than structure and dynamics, accepting type D dualism or type F monism, or that the truth of materialism does not require an implication from physics to consciousness, accepting type B materialism. 20. So in the end, there is no separate space for the type C materialist. 8. Interlude. Are there any other options for the materialist? One further option is to reject the distinctions on which this taxonomy rests. For example, some philosophers, especially followers of Quine, 1951, reject any distinction between conceptual truth and empirical truth or between the a priori and the a posteriori or between the contingent and the necessary. One who is sufficiently Quinian might therefore reject the distinction between type A and type B materialism, holding that talk of epistemic implication and / or modal entailment is ungrounded but that materialism is true nevertheless. We might call such a view type Q materialism. 21. Still, even on this view, similar issues arise. Some quinians hold that explaining the functions explains everything, then it may be an example. If so, all the problems of type A materialism arise. Others hold that we can postulate identities between physical states and conscious states in virtue of the strong isomorphic connections between them in nature. Paul Chitchland may be an example. If so, the problems of type B materialism arise. Others may appeal to novel future sorts of explanation. If so, the problems of type C materialism arise. So the quinian approach cannot avoid the relevant problems. Leaving this sort of view aside, it looks as if the only remotely viable options for the materialist are type A materialism and type B materialism. Other views are either ultimately unstable or collapse into one of these, or the three remaining options. 22. It seems to me that the costs of these views, denying the manifest explanandum in the first case and embracing primitive identities or strong necessities in the second case, suggest very strongly that they are to be avoided unless there are no viable alternatives. So the residual question is whether there are viable alternatives. If consciousness is not necessitated by physical truths, then it must involve something ontologically novel in the world. To use Kripke's metaphor, after fixing all the physical truths, God had to do more work to fix all the truths about consciousness. That is, there must be ontologically fundamental features of the world over and above the features characterized by physical theory. We are used to the idea that some features of the world are fundamental. In physics, features such as space-time, mass, and charge are taken as fundamental and not further explained. If the arguments against materialism are correct, these features from physics do not exhaust the fundamental features of the world. We need to expand our catalog of the world's basic features. There are two possibilities here. First, it could be that consciousness is itself a fundamental feature of the world, like space-time and mass. In this case, we can say that phenomenal properties are fundamental. Second, it could be that consciousness is not itself fundamental but is necessitated by some more primitive fundamental feature X that is not itself necessitated by physics. In this case, we might call X a proto-phenomenal property, and we can say that proto-phenomenal properties are fundamental. I typically put things in terms of the first possibility for ease of discussion, but the discussion that follows applies equally to the second. Either way, consciousness involves something novel and fundamental in the world. The following question then arises. How do these novel fundamental properties relate to the already acknowledged fundamental properties of the world, namely, those invoked in microphysics? In general, where there are fundamental properties, there are fundamental laws. So we can expect that there will be some sort of fundamental principles, psychophysical laws connecting physical and phenomenal properties. Like the fundamental laws of relativity or quantum mechanics, these psychophysical laws will not be deducible from more basic principles but instead will be taken as primitive. But what is the character of these laws? An immediate worry is that the microphysical aspects of the world are often held to be causally closed, in that every microphysical state has a microphysical sufficient cause. How are fundamental phenomenal properties to be integrated with this causally closed network? There seem to be three main options for the non-reductionist here. First, one could deny the causal closure of the microphysical, holding that there are causal gaps in microphysical dynamics that are filled by a causal role for distinct phenomenal properties. This is type D dualism. Second, one could accept the causal closure of the microphysical and hold that phenomenal properties play no causal role with respect to the physical network. This is type E dualism. Third, one could accept that the microphysical network is causally closed but hold that phenomenal properties are nevertheless integrated with it and play a causal role by virtue of constituting the intrinsic nature of the physical. This is type F monism. In what follows, I discuss each of these views. The discussion is necessarily speculative in certain respects, and I do not claim to establish that any one of the views is true or completely unproblematic. But I do suggest that none of them has clear fatal flaws and that each deserves further investigation. 9. Type D dualism. Type D dualism holds that microphysics is not causally closed and that phenomenal properties play a causal role in affecting the physical world. 23. On this view, usually known American Samoa interactionism, physical states cause phenomenal states, and phenomenal states cause physical states. The corresponding psychophysical laws run in both directions. On this view, the evolution of microphysical states is not determined by physical principles alone. Psychophysical principles specifying the effect of phenomenal states on physical states also play an irreducible role. The most familiar version of this sort of view is Descartes' substance dualism, hence D for Descartes, according to which there are separate interacting mental and physical substances or entities. But this sort of view is also compatible with the property dualism on which there is just one sort of substance or entity. On a type D property dualism, there will be both physical and phenomenal fundamental properties, and the phenomenal properties will play an irreducible role in affecting the physical properties. This view is compatible with an emergentist view such as Broad's, according to which phenomenal properties are ontologically novel properties of physical systems, not deducible from microphysical properties alone, and have novel effects on microphysical properties, not deducible from microphysical principles alone. Such a view would involve basic principles of downward causation of the mental on the microphysical, hence also D for downward causation. It is sometimes objected that distinct physical and mental states could not interact since there is no causal nexus between them. However, one lesson from Hume and from modern science is that the same goes for any fundamental causal interactions, including those found in physics. Newtonian science reveals no causal nexus by which gravitation works, for example, rather, the relevant laws are simply fundamental. The same goes for basic laws in other physical theories, and the same presumably applies to fundamental psychophysical laws. There is no need for a causal nexus distinct from the physical and mental properties themselves. By far the most influential objection to interactionism is that it is incompatible with physics. 24. It is widely held that science tells us that the microphysical realm is causally closed, so that there is no room for mental states to have any effects. An interactionist might respond in various ways. For example, it could be suggested that although no experimental studies have revealed these effects, none have ruled them out. It might further be suggested that physical theory allows any number of basic forces, for as things stand, but there is always room for more, and that an extra force associated with a mental field would be a reasonable extension of existing physical theory. These suggestions would invoke significant revisions to physical theory, so are not to be made lightly, but one could argue that nothing rules them out. By far the strongest response to this objection is to suggest that, far from ruling out interactionism, contemporary physics is positively encouraging to the possibility. On the standard formulation of quantum mechanics, the state of the world is described by a wave function, according to which physical entities are often in a superposed state, example in a superposition of two different positions, even though superpositions are never directly observed. According to the standard dynamics, the wave function can evolve in two ways: linear evolution by the Schrödinger equation, which tends to produce superposed states, and nonlinear collapses from superposed states into non-superposed states. Schrödinger evolution is deterministic, but collapse is non-deterministic. Schrödinger evolution is constantly ongoing, but on the standard formulation, collapses occur only occasionally, on measurement. The collapse dynamics leaves a door wide open for an interactionist interpretation. Any physical non-determinism might be held to leave room for non-physical effects, but the principles of collapse do much more than that. Collapse is supposed to occur on measurement. There is no widely agreed definition of what a measurement is, but there is one sort of event that everyone agrees is a measurement: observation by a conscious observer. Further, it seems that no purely physical criterion for a measurement can work since purely physical systems are governed by the linear Schrödinger dynamics. As such, it is natural to suggest that a measurement is precisely a conscious observation and that this conscious observation causes a collapse. The claim should not be too strong. Quantum mechanics does not force this interpretation of the situation on us, and there are alternative interpretations of quantum mechanics on which there are no collapses or on which measurement has no special role in collapse. 25 Nevertheless, quantum mechanics appears to be quite compatible with such an interpretation. In fact, one might argue that if one were to design elegant laws of physics that allow a role for the conscious mind, one could not do much better than the bipartite dynamics of standard quantum mechanics, one principle governing deterministic evolution in normal cases and one principle governing non-deterministic evolution in special situations that have a prima facie link to the mental. Of course, such an interpretation of quantum mechanics is controversial. Many physicists reject it precisely because it is dualistic, giving a fundamental role to consciousness. This rejection is not surprising, but it carries no force when we have independent reason to hold that consciousness may be fundamental. There is some irony in the fact that philosophers reject interactionism on largely physical grounds. 26. It is incompatible with physical theory, while physicists reject an interactionist interpretation of quantum mechanics on largely philosophical grounds. It is dualistic. Taken conjointly, these reasons carry little force, especially in light of the arguments against materialism elsewhere in this chapter. This sort of interpretation needs to be formulated in detail in order to be assessed. 27 I think that the most promising version of such an interpretation allows conscious states to be correlated with the total quantum state of a system, with the extra constraint that conscious states, unlike physical states, can never be superposed. In a conscious physical system such as a brain, the physical and phenomenal states of the system will be correlated in a non-superposed quantum state. Upon observation of a superposed external system, Schrödinger evolution at the moment of observation would cause the observed system to become correlated with the brain, yielding a resulting superposition of brain states and so, by psychophysical correlation, a superposition of conscious states. At this point, however, a fundamental constraint holds that such a superposition cannot occur, so one of the potential resulting conscious states is somehow selected, presumably by a non-deterministic dynamic principle at the phenomenal level. The result is that, by psychophysical correlation, a definite brain state and a definite state of the observed object are also selected. The same might apply to the connection between consciousness and non-conscious processes in the brain. When superposed non-conscious processes threaten to affect consciousness, there will be some sort of selection. In this way, there is a causal role for consciousness in the physical world. Interestingly, such a theory may be empirically testable. In quantum mechanics, collapse theories yield predictions slightly different from no-collapse theories, and different hypotheses about the location of collapse yield predictions that differ from each other, although the differences are extremely subtle and are currently impossible to measure. If the relevant experiments can one day be performed, some outcomes would give us strong reason to accept a collapse theory and might in turn give us grounds to accept a role for consciousness. As a bonus, this could even yield an empirical criterion for the presence of consciousness. There are any number of further questions concerning the precise formulation of such a view, its compatibility with physical theory more generally, example relativity and quantum field theory, and its philosophical tenability, example does this view yield the sort of causal role that we are inclined to think consciousness must have. But at the very least, it cannot be said that physical theory immediately rules out the possibility of an interactionist theory. Those who make this claim often raise their eyebrows when a specific theory such as quantum mechanics is invoked, but this is quite clearly an inconsistent set of attitudes. If physics is supposed to rule out interactionism, then careful attention to the detail of physical theory is required. All of this suggests that there is at least room for a viable interactionism to be explored and that the most common objection to interactionism has little force. Of course, it does not entail that interactionism is true. There is much that is attractive about the view of the physical world as causally closed, and there is little direct evidence from cognitive science of the hypothesis that behavior cannot be wholly explained in terms of physical causes. Still, if we have independent reason to think that consciousness is irreducible, and if we wish to retain the intuitive view that consciousness plays a causal role, then this is a view to be taken very seriously. 10. Type E dualism. Type E dualism holds that phenomenal properties are ontologically distinct from physical properties and that the phenomenal has no effect on the physical. 28. This is the view usually known as epiphenomenalism, hence type E physical states cause phenomenal states, but the converse is not true. On this view, psychophysical laws run in one direction only from physical to phenomenal. The view is naturally combined with the view that the physical realm is causally closed. This further claim is not essential to type E dualism, but it provides much of the motivation for the view. As with type D dualism, type E dualism is compatible with a substance dualism with distinct physical and mental substances or entities, and is also compatible with a property dualism with one sort of substance or entity and two sorts of properties. Again, it is compatible with an emergentism such as Broad's, according to which mental properties are ontologically novel emergent properties of an underlying entity, but in this case, although there are emergent qualities, there is no emergent downward causation. Type E dualism is usually put forward as respecting both consciousness and science. It simultaneously accommodates the anti-materialist arguments about consciousness and the causal closure of the physical. At the same time, type E dualism is frequently rejected as deeply counterintuitive. If type E dualism is correct, then phenomenal states have no effect on our actions, physically construed. For example, a sensation of pain will play no causal role in my hands moving away from a flame, my experience of decision will play no causal role in my moving to a new country, and a sensation of red will play no causal role in my producing the utterance I am experiencing red now. These consequences are often held to be obviously false or at least unacceptable. Still, the type E dualists can reply that there is no direct evidence that contradicts their view. Our evidence reveals only regular connections between phenomenal states and actions, so that certain sorts of experiences are typically followed by certain sorts of actions. Being exposed to this sort of constant conjunction produces a strong belief in a causal connection, as Hume pointed out in another context, but it is nevertheless compatible with the absence of a causal connection. Indeed, it seems that if epiphenomenalism were true, we would have exactly the same evidence and be led to believe that consciousness has a causal role for much the same reasons. So if epiphenomenalism is otherwise coherent and acceptable, it seems that these considerations do not provide strong reasons to reject it. 29. Another objection holds that if consciousness is epiphenomenal, it could not have evolved by natural selection. The type E dualist has a straightforward reply, however. On the type E view, there are fundamental psychophysical laws associating physical and phenomenal properties. If evolution selects appropriate physical properties, perhaps involving physical or informational configurations in the brain, then the psychophysical laws will ensure that phenomenal properties are instantiated, too. If the laws have the right form, one can even expect that, as more complex physical systems are selected, more complex states of consciousness will evolve. In this way, physical evolution will carry the evolution of consciousness along with it as a sort of byproduct. Perhaps the most interesting objections to epiphenomenalism focus on the relation between consciousness and representations of consciousness. It is certainly at least strange to suggest that consciousness plays no causal role in my utterances of I am conscious. Some have suggested more strongly that this rules out any knowledge of consciousness. It is often held that, if a belief about X is to qualify as knowledge, the belief must be caused in some fashion by X. But if consciousness does not affect physical states, and if beliefs are physically constituted, then consciousness cannot cause beliefs. Even if beliefs are not physically constituted, it is not at all clear how epiphenomenalism can accommodate a causal connection between consciousness and belief. In response, an epiphenomenalist can deny that knowledge always requires a causal connection. One can argue, as I do in Chapter 9, that there is a stronger connection between consciousness and beliefs about consciousness. Consciousness plays a role in constituting phenomenal concepts and phenomenal beliefs. A red experience plays a role in constituting a belief that one is having a red experience, for example. If so, there is no causal distance between the experience and the belief. Additionally, one can argue, as I do in Chapter 10, that this immediate connection to experience and belief allows for the belief to be justified. If this is right, then epiphenomenalism poses no obstacle to knowledge of consciousness. A related objection holds that my zombie twin would produce the same reports, example I am conscious, caused by the same mechanisms, and that these reports are unjustified. If so, my own reports are unjustified. In response, one can hold that the true bearers of justification are beliefs and that my zombie twin and I have different beliefs, involving different concepts, because of the role that consciousness plays in constituting my concepts but not the zombies. Further, the fact that we produce isomorphic reports implies that an observer might not be any more justified in believing that I am conscious than that the zombie is conscious, but it does not imply a difference in first-person justification. The first-person justification for my belief that I am conscious is not grounded in any way in my reports but rather in my experiences themselves, experiences that the zombie lacks. For these reasons, I think that there is no knockdown objection to epiphenomenalism here. Still, it must be acknowledged that the situation is at least odd and counterintuitive. The oddness of epiphenomenalism is exacerbated by the fact that the relationship between consciousness and reports about consciousness seems to be something of a lucky coincidence, according to the epiphenomenalist view. After all, if psychophysical laws are independent of physical evolution, then there will be possible worlds where physical evolution is the same as ours but the psychophysical laws are very different, so that there is a radical mismatch between reports and experiences. It seems lucky that we are in a world whose psychophysical laws match them up so well. In response, an epiphenomenalist might try to argue that these laws are somehow the most natural and are to be expected, but there is at least a significant burden of proof here. Overall, I think that epiphenomenalism is a coherent view without fatal problems. At the same time, it is an inelegant view, producing a fragmented picture of nature, in which physical and phenomenal properties are only very weakly integrated in the natural world. And, of course, it is a counterintuitive view that many people find difficult to accept. Inelegance and counterintuitiveness are better than incoherence, so if good arguments force us to epiphenomenalism as the most coherent view, then we should take it seriously. At the same time, however, we have good reason to examine other views very carefully. 11. Type F monism. Type F monism is the view that consciousness is constituted by the intrinsic properties of fundamental physical entities, that is, by the categorical basis of fundamental physical dispositions. 30. On this view, phenomenal origin proto-phenomenal properties are located at the fundamental level of physical reality and in a certain sense underlie physical reality itself. We might call this view Russellian monism because it takes its cue from Bertrand Russell's discussion of physics in the analysis of matter. Russell pointed out that physics characterizes physical entities and properties by their relations to one another and to us. For example, a quark is characterized by its relations to other physical entities, and a property such as mass is characterized by an associated dispositional role, such as the tendency to resist acceleration. At the same time, physics says nothing about the intrinsic nature of these entities and properties. Where we have relations and dispositions, we expect some underlying intrinsic properties that ground the dispositions, characterizing the entities that stand in these relations. 31. As I noted in Chapter 1, however, physics is silent about the intrinsic nature of a quark and about the intrinsic properties that play the role associated with mass. So this raises a metaphysical puzzle: what are the intrinsic properties of fundamental physical systems? At the same time, there is another metaphysical puzzle: how can phenomenal properties be integrated with the physical world? Phenomenal properties seem to be intrinsic properties that are hard to fit in with the structural dynamic character of physical theory, and arguably, they are the only intrinsic properties that we have direct knowledge of. Russell's insight was that we might solve both these puzzles at once. Perhaps the intrinsic properties of the physical world are themselves phenomenal properties. Or perhaps the intrinsic properties of the physical world are not phenomenal properties but nevertheless constitute phenomenal properties, that is, perhaps they are proto-phenomenal properties. If so, then consciousness and physical reality are deeply intertwined. This view holds the promise of integrating phenomenal and physical properties very tightly in the natural world. Here, nature consists of entities with intrinsic, proto-phenomenal qualities standing in causal relations within a space-time manifold. Physics as we know it emerges from the relations between these entities, whereas consciousness as we know it emerges from their intrinsic nature. As a bonus, this view is perfectly compatible with the causal closure of the microphysical and indeed with existing physical laws. The view can retain the structure of physical theory as it already exists, it simply supplements this structure with an intrinsic nature. Furthermore, the view acknowledges a clear causal role for consciousness in the physical world. Proto-phenomenal properties serve as the ultimate categorical basis of all physical causation. This view has elements in common with both materialism and dualism. From one perspective, it can be seen as a sort of materialism. If one holds that physical terms refer not to dispositional properties but to the underlying intrinsic properties, then the proto-phenomenal properties can be seen as physical properties, thus preserving a sort of materialism. From another perspective, it can be seen as a sort of dualism. The view acknowledges phenomenal or proto-phenomenal properties as ontologically fundamental, and it retains an underlying duality between structural dispositional properties, those directly characterized in physical theory, and intrinsic proto-phenomenal properties, those responsible for consciousness. One might suggest that while the view arguably fits the letter of materialism, it shares the spirit of anti-materialism. In its proto-phenomenal form, the view can be seen as a sort of neutral monism. There are underlying neutral properties X, the proto-phenomenal properties, such that the X properties are simultaneously responsible for constituting the physical domain, by their relations, and the phenomenal domain, by their collective intrinsic nature. In its phenomenal form, the view can be seen as a sort of idealism, such that mental properties constitute physical properties, although these need not be mental properties in the mind of an observer, and they may need to be supplemented by causal and spatio-temporal properties in addition. One could also characterize this form of the view as a sort of panpsychism, with phenomenal properties ubiquitous at the fundamental level. One could give the view in its most general form the name panprotopsychism, with either proto-phenomenal or phenomenal properties underlying all of physical reality. A type F monist may have one of a number of attitudes to the zombie argument against materialism. Some type F monists may hold that a complete physical description must be expanded to include an intrinsic description and may consequently deny that zombies are conceivable. We only think we are conceiving of a physically identical system because we overlook intrinsic properties. Others could maintain that existing physical concepts refer via dispositions to those intrinsic properties that ground the dispositions. If so, these concepts have different primary and secondary intentions, as discussed in Chapter 6 and in the appendix, and a type F monist could correspondingly accept conceivability but deny possibility. On this interpretation, we misdescribe the conceived world as physically identical to ours when in fact it is just structurally identical. 32. Finally, a type F monist might hold that physical concepts refer to dispositional properties, so that zombies are both conceivable and possible, and the intrinsic properties are not physical properties. The differences among these three attitudes seem to be ultimately terminological rather than substantive. As for the knowledge argument, a type F monist might insist that for Mary to have complete physical knowledge, she would have to have a description of the world involving concepts that directly characterize the intrinsic properties. If she had this, as opposed to her impoverished description involving dispositional concepts, she might thereby be in a position to know what it is like to see red. Regarding the explanatory argument, a type F monist might hold that physical accounts involving intrinsic properties can explain more than structure and function. Alternatively, a type F monist who sticks to dispositional physical concepts will make responses analogous to one of the other two responses given earlier. The type F view is admittedly speculative, and it can sound strange at first hearing. Many find it extremely counterintuitive to suppose that fundamental physical systems have phenomenal properties, for example, that there is something it is like to be an electron. The proto-phenomenal version of the view rejects this claim but retains something of its strangeness. It seems that any properties responsible for constituting consciousness must be highly unusual properties of a sort that we might not expect to find in microphysical reality. Still, it is not clear that this strangeness yields any strong objections. Like epiphenomenalism, the view appears to be compatible with all our evidence, and there is no direct evidence against it. One can argue that if the view were true, things would appear to us just as they in fact appear. And we have learned from modern physics that the world is a strange place. We cannot expect it to obey all of the dictates of common sense. One might also object that we do not have any conception of what proto-phenomenal properties might be like or of how they could constitute phenomenal properties. This is true, but one could suggest that this merely a product of our ignorance. In the case of familiar physical properties, there were principled reasons, based on the character of physical concepts, for denying a constitutive connection to phenomenal properties. Here, there are no such principled reasons. At most, there is ignorance of a connection. Of course, it would be very desirable to form a positive conception of proto-phenomenal properties. Perhaps we can do this indirectly by some sort of theoretical inference from the character of phenomenal properties to their underlying constituents, or perhaps knowledge of the nature of proto-phenomenal properties will remain beyond us. Either way, this is no reason to reject the truth of the view. 33. There is one sort of principled problem in the vicinity, pointed out by William James, 1890, Chapter 6. Our phenomenology has a rich and specific structure. It is unified, bounded, and differentiated into many different aspects but with an underlying homogeneity to many of the aspects, and it appears to have a single subject of experience. It is not easy to see how a distribution of a large number of individual microphysical systems, each with its own proto-phenomenal properties, could somehow add up to the subject of experience with a rich and specific structure. Should one not expect something more like a disunified, jagged collection of phenomenal spikes? This is a version of the combination problem for panpsychism, Seeger 1995, or what Staljar, 2001b, calls the structural mismatch problem for the Russellian view, see also Foster 1991, 1930. To answer it, we need a much better understanding of the compositional principles of phenomenology, that is, the principles by which phenomenal properties can be composed or constituted from underlying phenomenal properties, or proto-phenomenal properties. We have a good understanding of the principles of physical composition but no real understanding of the principles of phenomenal composition. This is an area that deserves much close attention. The combination problem is easily the most serious problem for the type F monist view, and at this point, it is an open question whether or not it can be solved. Some type F monists appear to hold that they can avoid the combination problem by holding that phenomenal properties are the intrinsic properties of high-level physical dispositions, example those involved in neural states, and need not be constituted by the intrinsic properties of microphysical states. Hence, they may also deny panprotopsychism. But this seems to be untenable. If the low-level network is causally closed and the high-level intrinsic properties are not constituted by low-level intrinsic properties, the high-level intrinsic properties will be epiphenomenal all over again, for familiar reasons. The only way to embrace this position would seem to be in combination with a denial of microphysical causal closure, holding that there are fundamental dispositions above the microphysical level, which have phenomenal properties as their grounds, but such a view would be indistinguishable from type D dualism. 34. So a distinctive type F monism will have to face the combination problem directly. Overall, type F monism promises a deeply integrated and elegant view of nature. No one has yet developed any sort of detailed theory in this class, and it is not yet clear whether such a theory can be developed. At the same time, however, there appear to be no strong reasons to reject the view. As such, Type F monism is likely to provide fertile grounds for further investigation, and it may ultimately provide the best integration of the physical and the phenomenal within the natural world. 6. The two-dimensional argument against materialism. A number of popular arguments for dualism start from a premise about an epistemic gap between physical truths and truths about consciousness and infer an ontological gap between physical processes and consciousness. Arguments of this sort include the conceivability argument, the knowledge argument, the explanatory gap argument, and the property dualism argument. Such arguments are often resisted on the grounds that epistemic premises do not entail ontological conclusions. My view is that one can legitimately infer ontological conclusions from epistemic premises if one is careful about how one reasons. To do so, the best way is to reason first from epistemic premises to modal conclusions, about necessity and possibility, and from there to ontological conclusions. Here, the crucial issue is the link between the epistemic and modal domains. How can one reason from theses about what is knowable or conceivable to theses about what is necessary or possible? To bridge the epistemic and modal domains, the framework of two-dimensional semantics can play a central role. I have used this framework in earlier work, Chalmers 1996, to mount an argument against materialism. Here I revisit the argument, laying it out in a more explicit and careful form and responding to a number of objections. In what follows I concentrate mostly on the conceivability argument. Similar considerations apply to the other anti-materialist arguments, however, and in the afterword to this chapter, I show how this analysis might yield a unified treatment of many of these arguments. The conceivability argument. The most straightforward form of the conceivability argument against materialism runs as follows. 1. P and Q is conceivable. 2. If P and Q is conceivable, P and Q is metaphysically possible. 3. If P and Q is metaphysically possible, materialism is false. 4. Materialism is false. Here Pi's the conjunction of all microphysical truths about the universe, specifying the fundamental features of every fundamental microphysical entity in the language of microphysics, as well as fundamental microphysical laws. Q is an arbitrary phenomenal truth, perhaps the truth that someone is phenomenally conscious, or perhaps the truth that a certain individual, that is, an individual satisfying a certain description, instantiates a certain phenomenal property. P and CQ, P and not Q, CO and joins the former with the denial of the latter. If Q is the truth that someone is phenomenally conscious, then P and Q is the statement that everything is microphysically as in our world, but no one is phenomenally conscious. In this version, P and Q says that the world is a zombie world, see chapter 5. If Q is the truth that a certain individual instantiates a certain phenomenal property, then P and Q is the statement that everything is microphysically as in our world, but that it is not the case that the individual in question instantiates the relevant phenomenal property. In this case, it suffices for the truth of P and Q that the world is a zombie world, or simply that the individual in question is a zombie in a physically identical world. It also suffices that the individual in question is an invert, who has an experience that differs slightly from the corresponding experience of the corresponding individual in our, physically identical, world. The first premise of this argument asserts an epistemic thesis, about what can be conceived. The second premise steps from the epistemic thesis to a modal thesis, about what is possible. The third premise steps from the modal thesis to a metaphysical thesis, about the nature of our world. The third premise is relatively uncontroversial. It is widely accepted that materialism has modal commitments. Some philosophers question whether materialism is equivalent to a modal thesis, but almost all accept that materialism at least entails a modal thesis. Here one can invoke Kripke's metaphor: if it is possible that there is a world physically identical to our world but phenomenally different, then after God fixed the physical facts about our world, he had to do more work to fix the phenomenal facts. A familiar complication arises from the observation that physicalism about our world is compatible with the possibility of dualism in other worlds, and in particular is compatible with the possibility of a physically identical world that contains extra, non-physical phenomenology. This means that if Q is a negative truth about our world, say, the truth that no one instantiates a certain phenomenal property, then materialism about our world is compatible with the possibility of P and Q. To finesse this point, we can ensure that in this argument, Q is a positive truth, one that holds in all worlds that contain a duplicate of our world, see Chalmers 1996, 40. If Q is a positive truth, such as someone is conscious, then materialism is incompatible with the possibility of P and Q. Alternatively, we can conjoin P with a that's all statement T, stating that the world is a minimal world that satisfies P, see Jackson 1998, 26. Then even when Q is a negative truth, materialism is not compatible with the possibility of PT and CQ, where T's the conjunction of P and T. The real work in the argument is done by the first and second premises. The second premise is particularly controversial. A number of examples have led many philosophers to deny that there is an entailment from conceivability to metaphysical possibility. To assess these premises, we need to understand the notion of conceivability. Two varieties of conceivability. Conceivability is to be understood as an epistemic notion, defined in epistemological, and perhaps psychological, terms. To a first approximation, we can say that a sentence S is conceivable when S expresses a coherent hypothesis, one that cannot be ruled out a priori. To refine this understanding, it is useful to make some distinctions. These distinctions are discussed at much greater length in Chalmers 2002b. We can say that S is prima facie conceivable, for a subject, when that subject is unable to rule out the hypothesis expressed by S by a priori reasoning on initial consideration. We can say that S is ideally conceivable when the hypothesis expressed by S cannot be ruled out a priori even on ideal rational reflection. The main difference here is that prima facie conceivability is tied to a subject II contingent cognitive limitations, while ideal conceivability abstracts away from those limitations. Here are some examples. 1. 2 plus 2 equals 5 is neither prima facie conceivable nor ideally conceivable. 2. Where S is a highly complex but provable mathematical truth, S will be prima facie conceivable for most subjects, but it is not ideally conceivable. 3. Where S is there is a flying pig, S is prima facie conceivable and is almost certainly ideally conceivable. These notions of conceivability are versions of negative conceivability, which is defined in terms of what a subject can rule out through a priori reasoning. We can say that S is negatively conceivable when S cannot be ruled out through a priori reasoning. The notions of prima facie and ideal conceivability defined here can then be seen as prima facie negative conceivability and ideal negative conceivability, respectively. It is also possible to define notions of positive conceivability, which is characterized in terms of what subjects can form a positive conception of. We can say that S is positively conceivable when one can coherently imagine a situation in which S is the case. Where negative conceivability requires merely entertaining a hypothesis and being unable to rule it out, positive conceivability involves being able to form some sort of clear and distinct conception of a situation in which the hypothesis is true. One can then say that S is prima facie positively conceivable when a subject can imagine a situation that the person takes to be coherent and also takes to be one in which S is the case. Furthermore, one can say that S is ideally positively conceivable when its prima facie positive conceivability cannot be defeated on ideal rational reflection, in particular, when arbitrary details can be filled in the imagined situation without any contradiction revealing itself, and when ideal reflection reveals the imagined situation as one in which S is the case. Traditional notions of conceivability, Descartes' clear and distinct conceivability, for example, are arguably varieties of positive rather than negative conceivability. At the same time, the notion of positive conceivability is more complex than that of negative conceivability, and a rigorous characterization of the notion requires saying much more about just what it is to imagine a situation and so on. I characterize positive conceivability in more depth in Chalmers 2002b. In this chapter the roles of positive and negative conceivability are often interchangeable. I will be clear when the difference is relevant, so the preceding informal account suffices for present purposes. For much of the discussion one can focus on negative conceivability without much loss, but positive conceivability is available as an alternative if there turn out to be any problems with theses tied to negative conceivability. Insofar as there is a gap between prima facie conceivability and ideal conceivability, it is ideal conceivability that is the better guide to possibility. This is especially clear in the case of prima facie negative conceivability. We have seen that the negation of a complex mathematical truth may be prima facie negatively conceivable, but it is not ideally conceivable, and it is not possible. It is less easy to find cases of prima facie positive conceivability without ideal positive conceivability. See Chalmers 2002b for some potential cases, but insofar as there are such cases, there will be little reason to think that they are possible. Correspondingly, some familiar purported counterexamples to the claim that conceivability entails possibility are really counterexamples to the claim that prima facie conceivability entails possibility. For example, it is sometimes said that both Goldbach's conjecture and its negation are conceivable, while only one of them is possible. Here the relevant notion of conceivability is something like prima facie negative conceivability. There is no reason to believe that both Goldbach's conjecture and its negation are ideally conceivable, so there is no reason to think that this is a counterexample to the claim that ideal conceivability entails possibility. So from here onward, talk of conceivability simpliciter should always be understood to be talk of ideal conceivability, either positive or negative. The other familiar class of purported counterexamples arises from Kripke's analysis of the necessary a posteriori. It is often said that sentences such as water is not H2O provide counterexamples to the claim that conceivability entails possibility. It is conceivable that water is not H2O, but it is not metaphysically possible. Here one has to be careful. There is a sense of conceivable in which water is not H2O is not conceivable, given that water is H2O in the actual world. In this sense, any conceivable situation in which it seems that water is not H2O, a twin Earth world, say, should better be described as a conceivable situation in which water is still H2O but in which there is watery stuff that is not H2O. Using the term conceivable this way, as Kripke seems to do, one might say that water is not H2O seems conceivable, or that it is prima facie conceivable to one without relevant empirical knowledge, but that it is not really conceivable. We might call this sense of conceivability secondary conceivability, for reasons familiar from a two-dimensional analysis and discussed in Chalmers 2002b. Then the Kripken cases are compatible with the claim that secondary conceivability entails metaphysical possibility. At the same time, however, this claim is not very useful for present purposes, as whether a sentence is secondarily conceivable will typically depend on a variety of empirical factors, and an opponent might deny that zombies are secondarily conceivable on the grounds that there is an a posteriori identity between phenomenal and physical properties. So a link between secondary conceivability and possibility does not offer an a priori route to conclusions about metaphysical possibility. Instead, what is relevant here is primary conceivability, the sense in which water is not H2O can correctly be said to be conceivable. The notion of negative conceivability defined earlier is a sort of primary conceivability as it is defined in terms of what can be ruled out a priori, and water is H2O cannot be established a priori. One might define a distinct notion of negative secondary conceivability, but I will set that aside here. One can likewise define a notion of positive primary conceivability, so that S is positively primarily conceivable when the subject can imagine a coherent situation that verifies S, where a situation verifies S when, under the hypothesis that the situation actually obtains, the subject should conclude that S. If the subject imagines a twin Earth situation with XYZ in the oceans and lakes and assumes that the situation obtains in the subject's own environment, then the subject should conclude that water is XYZ rather than H2O. So water is not H2O is positively primarily conceivable, as well as negatively primarily conceivable. Unlike secondary conceivability, matters of primary conceivability are plausibly in the a priori domain. Whether S is primarily conceivable turns on matters of a priori reasoning. But primary conceivability does not entail metaphysical possibility. Water is not H2O is primarily conceivable, but it is not metaphysically possible. Still, there remains a link between primary conceivability and metaphysical possibility in these cases. When we conceive that water is not H2O, we imagine, for example, a twin Earth situation in which the watery liquid in the oceans and lakes is XYZ. This situation is metaphysically possible, so there is a sense in which our conceiving involves access to a possible world. Under the usual way of describing possible worlds, this world is not one in which water is not H2O. But the world still stands in a strong relation to the sentence water is not H2O. In particular, if we came to accept that our own world had the character of this world, with XYZ in the oceans and lakes, we should then endorse the claim water is not H2O. This can be put in two-dimensional terms by saying that while the twin Earth does not satisfy water is not H2O, water is not H2O is not true of that world considered as counterfactual. The twin Earth world verifies water is not H2O, water is not H2O is true of that world considered as actual. Equivalently, we can say that while the secondary intention of water is not H2O is false at W, the sentence's primary intention is true there. To a first approximation, a world W verifies S, or S is true at W considered as actual, or the primary intention of S is true at W, when, if we came to accept that our own world is qualitatively like W, we should then endorse S. Strictly speaking, the worlds that are relevant to primary intentions are centered worlds, worlds that come with a mark center consisting of an individual and time. When we consider a centered world W as actual, we consider the hypothesis that we are currently in the situation of the individual at the center. For much more on these notions, see the appendix to this book. We can say that when the primary intention of S is true at some centered world, i.e., when some centered world verifies S, S is primarily possible, or one possible. When the secondary intention of S is true at some world, i.e., when some world satisfies S, S is secondarily possible, or two possible. Then water is not H2O is not two possible, but it is one possible. The observation that sentences such as water is not H2O are conceivable but not possible in these terms comes to the claim that these sentences are primarily conceivable, conceivable, but are not secondarily possible, two possible. So there is good reason to believe that conceivability does not entail two possibility. However, these cases are entirely compatible with a link between two conceivability and two possibility, and more important for present purposes, they are entirely compatible with a link between conceivability and possibility. In fact, it is not hard to argue that all of the standard Kripken a posteriori necessities, heat is the motion of molecules, Hesperus is phosphorus, and so on, have this structure. For each of these necessities, one might say that its negation is conceivable but not possible, meaning that it is conceivable but not two possible. But in each of these cases, the sentence in question is one possible. For example, heat is not the motion of molecules is verified by a world in which something other than molecules causes sensations as of heat. Hesperus is not phosphorus is verified by a world in which the objects visible in the morning and evening skies are entirely distinct. Furthermore, it is plausible that worlds such as these are just what one is conceiving of when one conceives that heat is not the motion of molecules or that Hesperus is not phosphorus. So in these cases, there remains a strong link between conceivability and metaphysical possibility. To summarize, we have seen that the standard counterexamples to a conceivability-possibility link are accommodated by noting that, prima facie conceivability is an imperfect guide to possibility and that, 2. primary conceivability is an imperfect guide to secondary possibility. But, I, is entirely consistent with a link between ideal conceivability and possibility, and, 2, is entirely consistent with a link between primary conceivability and primary possibility. Putting the pieces together, all of these counterexamples are compatible with the thesis that ideal primary conceivability entails primary possibility. There are two versions of this thesis, depending on whether one interprets the relevant sort of conceivability as positive or negative. CP+, ideal primary positive conceivability entails primary possibility. CP, ideal primary negative conceivability entails primary possibility. Ideal primary positive conceivability entails ideal primary negative conceivability. If S can be ruled out a priori, then no coherent imagined situation will verify S. It follows that CP entails CP+. It is not obvious whether or not CP+ entails CP, as it is not obvious whether ideal primary negative conceivability entails ideal primary positive conceivability. That is, it is not obvious whether there is an S that cannot be ruled out a priori but such that no coherent imagined situation verifies S. In Chalmers 2002b I argue that there is no such S, so that ideal primary negative conceivability entails ideal primary positive conceivability. So CP is at least as strong as CP+ and is possibly somewhat stronger. Most important for present purposes, however, both CP+ and CP are compatible with all of the familiar purported counterexamples to the conceivability-possibility link. Furthermore, it seems that there are no clear counterexamples to either thesis, though later in the chapter I discuss some potential counterexamples that have been put forward. In particular, both theses are entirely compatible with the existence of Kripken a posteriori necessities, so while the existence of these necessities is often used to cast doubt on conceivability-possibility theses, they cannot be used to cast doubt on CP+ or CP-. So for now, I take these theses as reasonable conceivability-possibility theses that might be used in mounting a refined conceivability argument against materialism. Later in the chapter I return to the question of their truth. 3. A refined conceivability argument. Henceforth, unqualified uses of conceivability and conceivable should be understood as invoking ideal primary conceivability. I will often be inexplicit about whether positive or negative conceivability is involved. In effect, the argument forms that follow can be understood as generating two different arguments, depending on whether one understands conceivability as ideal primary positive conceivability or as ideal primary negative conceivability. For many purposes the distinction will not matter. When it does matter, I will be explicit. Given the preceding discussion, one might try to generate an anti-materialist argument by simply substituting primary possibility for metaphysical possibility in the original argument. 1. P and Q is conceivable. 2. If P and Q is conceivable, P and Q is one possible. 3. If P and Q is one possible, materialism is false. 4. Materialism is false. On this reading, premises 1 and 2 are both plausible theses, but premise 3 is not obviously plausible. The reason is that materialism requires not the one impossibility of P and Q but the two impossibility of P and Q. That is, materialism requires that it could not have been the case that P is true without Q also being true. This is a subjunctive claim about ordinary metaphysical possibility and so invokes two impossibility rather than one impossibility. A materialist might reasonably question premise 3 by holding that even if there is a world W verifying P and Q, W might be a world with quite different ingredients from our own. For example, it might be that W does not instantiate true microphysical properties, those instantiated in our world, such as mass and charge, but instead instantiates quite different properties, say, pseudo-mass and pseudo-charge, which stand to mass and charge roughly as XYZ stands to H2O. Likewise, it might be that W does not lack true phenomenal properties but instead lacks quite different properties, say, pseudo-phenomenal properties. If so, then the possibility of W has no bearing on whether true microphysical properties necessitate true phenomenal properties, and it is the latter that is relevant for materialism. Still, it may be that the gap between one possibility and two possibility could be closed. If P has the same primary intention and secondary intention, then a world will verify P if it satisfies P, so P will be one possible if it is two possible. The same goes for Q, and for P and Q. We could then run the following argument. 1. P and Q is conceivable. 2. If P and Q is conceivable, P and Q is one possible. 3. If P and Q is one possible, P and Q is two possible. 4. If P and Q is two possible, materialism is false. 5. Materialism is false. Here, the truth of premise 3 requires that both P and Q have primary and secondary intentions that coincide. In the case of Q, this claim is quite plausible, although as I note later, this claim is not required for a refined conceivability argument to go through. As Kripke noted, there does not seem to be the same strong dissociation between appearance and reality in the case of consciousness as in the cases of water and heat. While it is not the case that anything that looks like water is water or that anything that feels like heat is heat, it is plausibly the case that anything that feels like consciousness is consciousness. So it is not clear that the notion of pseudo-consciousness, something that satisfies the primary intention of consciousness without being consciousness, is coherent. The same holds for other, more specific phenomenal properties. So there is a strong case that the primary and secondary intentions of phenomenal terms coincide. For more on this case, see Chapter 8. However, in the case of P, this claim is less plausible. A materialist might reasonably hold that microphysical terms, such as mass and charge, have primary intentions that differ from their secondary intentions. In particular, it is plausible that the primary intentions of these terms are tied to a certain theoretical role. We might say that the primary intention of mass picks out whatever property plays the mass role, example resisting acceleration in certain ways, being subject to mutual attraction in a certain way, and so on, and that the primary intention of charge picks out whatever property plays the charge role, example obeying certain electromagnetic principles, being subject to attraction and repulsion in certain ways, and so on. By contrast, one might reasonably hold that the secondary intention of microphysical terms is tied to the property that actually plays the role. For example, if property M plays the mass role in the actual world, then one might hold that in any world in which mass is instantiated, mass is M. It follows that if there are worlds in which some other property Mr plays the mass role, then M is not mass in that world, at best, it is pseudo-mass. If so, then the primary and secondary intentions of mass will not coincide. The primary intention of mass will pick out whatever plays the mass role in such a world, but the secondary intention will not. There are other views of the semantics and metaphysics of microphysical terms that may reject this argument for the distinctness of the primary and secondary intentions of mass. In particular, the argument will not go through on views according to which it is necessary that mass is the property that plays the mass role. These include views on which mass is a non-rigid designator whose secondary intention picks out different properties that play the role in some worlds, as well as views on which it is necessary that M is the property that plays the mass role, where M is the property rigidly designated by mass. Still, the view sketched in the previous paragraph is a quite reasonable view, more plausible than the alternatives, in my opinion, and it is the view that best grounds resistance to an inference from the one possibility of P and Q to its two possibility. So we can suppose that the view is correct in order to see what follows. According to this view, a world may verify P without satisfying P. The secondary intention of P requires that certain specific properties such as mass, spin, and charge are distributed in a certain specific way across spacetime, with appropriate causal and gnomic relations among them. The primary intention of P requires only that whatever properties play the mass role, the spin role, and the charge role are distributed in this way. If W is a world where these roles are played by properties other than mass, spin, and charge, we might say that they are played by Schmass, Schmann, and Schmarge, which are otherwise distributed in the right way over space-time and have appropriate causal and gnomic relations among them, then W will verify P, but it will not satisfy P. Here, we might say that the physics of W has the same structural profile as physics in the actual world, but that it has a different intrinsic profile, in that it differs in the intrinsic properties that fill this structure. To verify P, a world must have the right structural profile, while to satisfy P, a world must have the right structural and intrinsic profiles. It follows that premise 3 is not guaranteed to be true. Because a world can verify P without satisfying P, it may be that P and Q is one possible but not two possible. However, this requires that P and Q be related in a certain specific way. In particular, it requires that some worlds that verify P also verify Q, while no worlds that satisfy P also satisfy Q. This requires in turn that some worlds that have the same structural profile as the actual world verify Q, while no worlds that have the same structural and intrinsic profiles as the actual world satisfy Q. We can assume for the moment that the primary and secondary intentions of Q coincide. Then we can put all of this by saying that for premise 3 to be false, it is required that the structural profile of physics in the actual world does not necessitate Q, but that the combined structural and intrinsic profiles of physics in the actual world do necessitate Q. This idea that the structural properties of physics in the actual world do not necessitate the existence and/or nature of consciousness, but that the intrinsic properties of physics combined with the structural properties do corresponds to a familiar view in the metaphysics of consciousness. This view is the type F monism of the last chapter, or Russellian monism. On this view, consciousness is closely tied to the intrinsic properties that serve as the categorical basis of microphysical dispositions. Russell and others held that the nature of these properties is not revealed to us by perception, which reveals only their effects, or by science, which reveals only their relations. But it is coherent to suppose that these properties have a special nature that is tied to consciousness. They might themselves be phenomenal properties, or they might be proto-phenomenal properties, properties that collectively constitute phenomenal properties when organized in the appropriate way. Russellian monism is an important view on the mind-body problem. It is certainly not ruled out by the conceivability argument and related arguments. If Russellian monism is true, then when we conceive of zombies, we hold fixed the structural properties of physical systems in the actual world but not their intrinsic properties, which are proto-phenomenal properties. If these intrinsic proto-phenomenal properties qualify as physical properties, then the zombies we conceive of are not full physical duplicates, and any full physical duplicates will also be phenomenal duplicates. On this understanding, Russellian monism qualifies as a form of physicalism. However, because it relies on speculation about the special nature of the fundamental properties in microphysics, it is a highly distinctive form of physicalism that has much in common with property dualism and that many physicalists will want to reject. 1. In any case, we can now close the loophole in the previous argument as follows. 1. P and Q is conceivable. 2. If P and Q is conceivable, then P and Q is one possible. 3. If P and Q is one possible, then P and Q is two possible, or Russellian monism is true. 4. If P and Q is two possible, materialism is false. 5. Materialism is false, or Russellian monism is true. This argument is valid. I discussed the case for premises 1, 2, and 4 earlier, and I have just now argued for premise 3. I think that 5 is the proper conclusion of the conceivability argument. For the reasons given earlier, such arguments, and also related arguments such as the knowledge argument and the property dualism argument, cannot exclude Russellian monism, and Russellian monism is arguably a form of physicalism, if a distinctive and radical kind. So the possibility of Russellian monism needs to be explicitly acknowledged as an option in the conclusion. A couple of minor notes on the argument. First, to be fully explicit, the argument might take the truth of Q as a premise. If Q were false, the ground for accepting premise 4 would collapse. In the less explicit version of the preceding argument, we can consider the truth of Q as part of the case for accepting premise 4. In fact, for reasons given earlier, the case for 4 requires that Q be a positive truth about consciousness. Alternatively, one can remain silent on whether Q is a positive or negative truth and handle this matter by conjoining P with the that's all clause asserting that the world is a minimal world in which P, or equivalently, by building such a that's all clause into P. Second, it is worth noting that, contrary to a common supposition, the assumption that Q has the same primary and secondary intentions is not necessary for the argument for 5 to go through. To see this, we can consider the version of the argument where we adjoin a that's all clause to P from premises 1 and 2. We can derive the conclusion that there is a minimal world verifying P in which the primary intention of Q is false. If P has the same primary and secondary intentions, then this world will be a minimal P world in which the primary intention of Q is false. This world must differ from our world because the primary intention of Q is true in our world. There is a small loophole here arising from the possibility that this world differs merely in the location of the center of the relevant centered world. I discuss this loophole in section 5. It follows that there is a minimal P world that is not a duplicate of our world, so that physicalism is false with regard to our world. It could be that, strictly speaking, physicalism will be true of consciousness because P necessitates Q, but physicalism will be false of properties closely associated with consciousness, namely those associated with the primary intention of Q. We might think of this sort of view as one on which phenomenal properties are physical properties that have non-physical properties as modes of presentation. Alternatively, if P has different primary and secondary intentions, then by the reasoning given in the earlier discussion of premise 3, one can conclude that either there is a minimal world satisfying P in which the primary intention of Q is false, which again entails the falsity of physicalism, or that the primary intention of Q is necessitated by the structural and intrinsic profiles of physics in our world but not by the structural profile alone. This view can be considered another form of Russellian monism in that the intrinsic properties of physics in our world are crucial for constituting the properties associated with the modes of presentation of consciousness. So if Q has distinct primary and secondary intentions, then one will have to formalize premises 3 and 4 somewhat differently, but the argument for 5 will still work just as well. This completes the exposition of the two-dimensional argument against materialism. In what follows I address some objections to the final version of the argument, p. 152, that arise from the recent literature. I have already said what needs to be said about premises 3 and 4, and I do not anticipate significant objections to them, with one exception that I discuss. I discuss some objections to premise 1 and some hard to classify objections relatively briefly, and then I focus on objections to the crucial premise 2. 4 objections to premise 1. Premise 1 says that P and Q is conceivable, that is, that we can conceive a world physically identical to ours containing zombies and or inverts. It is worth noting that such a world need not be an entire zombie world. One might worry that there are complications associated with imagining oneself to be zombie at the center of a centered world. For the purpose of the argument, it usually suffices to conceive of a physically identical world in which some other being, corresponding to a conscious being in this world, is a zombie or an invert. The premise can be understood as invoking ideal primary negative conceivability or ideal primary positive conceivability. The first version makes a somewhat weaker claim: positive conceivability entails negative conceivability, but the reverse is not obviously the case, and is slightly more straightforward. In this version, the premise simply says that P and Q cannot be ruled out a priori, that a priori reasoning cannot rule out the hypothesis that P obtains and that someone else is a zombie, for example. The second version makes the somewhat stronger claim that we can, in principle, clearly and distinctly imagine a situation in which P holds and in which someone is a zombie or an invert, where the hypothesis that this situation obtains cannot be ruled out by a priori reasoning. Of course, Any difference in strength here will be balanced by an inverse difference in strength for the corresponding versions of premise 2. I discussed the strong prima facie case for these claims in Chalmers, 1996, and will not recapitulate it here. The zombie hypothesis is at least prima facie coherent and imaginable. To reject the premise, one needs to find something that undermines the prima facie coherence and imaginability, such as some sort of a priori incoherence, contradiction, or unimaginability in the hypothesis that emerges on reflection. A detailed defense of the premise involves arguing that no candidate for this sort of undermining can succeed. Here I consider various candidates. 1. Analytic functionalism. One way to reject the conceivability premise would be to accept an analytic functionalist view of consciousness, on which to say that someone is conscious is that to say they have a state that functions in an appropriate way in their cognitive system and their behavior. If consciousness were defined in this way, then any functionally identical being would be conscious by definition, so zombies would be ruled out. Analytic functionalism about consciousness is widely rejected, however, and I have argued against it in the last chapter, under the discussion of type A materialism, so I will not argue against it further here. 2. Prima facie but not ideal conceivability. It is natural to suggest that zombies may be prima facie but not ideally conceivable. See Van Gulik 1999 and Worley 2003 for suggestions along these lines. This corresponds to the type C materialism of the last chapter, according to which there is a prima facie epistemic gap between physical and phenomenal truths that may be closed on ideal reflection, perhaps because of new discoveries about physical processes or perhaps because of novel reasoning. As I argued there, to render zombies incoherent even on ideal reflection requires some sort of conceptual link between physical and phenomenal concepts. Given that physics and physical concepts are all structural dynamic in character, and new scientific developments are unlikely to change this, although see option 3, phenomenal concepts must have a character that is linked to structural dynamic concepts in an appropriate way. Upon examination, the only candidate that is remotely tenable is the hypothesis that phenomenal concepts are functional concepts, but we have already seen that there is good reason to reject that view. A related objection, example Bailey forthcoming, holds that arguments from ideal conceivability are toothless since non-ideal creatures such as ourselves cannot know whether or not a given statement is ideally conceivable. I think that there is little reason to accept this claim. Although we are non-ideal, we can know that it is not ideally conceivable that 0 equals 1 and that it is ideally conceivable that someone exists. We know that certain things about the world, say, that all philosophers are philosophers, are knowable a priori, and that certain things about the world, say, that there is a table in this room, are not so knowable even by an ideal reasoner. Likewise, reasoning of this sort gives us very good reason to think that there is no a priori entailment from physical to phenomenal truths and that zombie hypotheses are conceivable even for an ideal reasoner. 3. Expanding the conception of the physical. Staljar, 2001a, argues that whether zombies are conceivable depend on how we understand physical properties. When we conceive of zombies, we hold fixed T-physical properties, or properties as characterized in physical theory. But we do not hold fixed O-physical properties, or the underlying properties of physical objects, including the intrinsic properties that play the roles characterized in physical theory. So the position is left open that O-physical zombie duplicates are both inconceivable and impossible. If we adequately conceived of the O-physical properties, we would see that any O-physical duplicate of a conscious being is conscious. Furthermore, if we expanded P to include hypothetical O-physical concepts of these intrinsic properties, characterizing their intrinsic nature, then P and Q would be inconceivable. I think that this is an important position, but it is clearly a version of Russellian monism, so I take it to be compatible with the overall argument given earlier. 4. Zombies presuppose epiphenomenalism. John Perry, 2001, has suggested that the assertion that zombies are conceivable presupposes epiphenomenalism, the thesis that consciousness plays no causal role. If we thought that consciousness plays a causal role, we would not find zombies conceivable. In Chalmers, 2004b, I argue that this claim is simply false. Its falsity is demonstrated by the fact that many non-epiphenomenalist views are compatible with the conceivability of zombies. For example, many Type B materialists, such as Hill, Lohr, and Papineau, accept that zombies are conceivable and that consciousness plays a causal role. These philosophers deny that zombies are possible, but that denial comes at a different stage of the argument. Furthermore, the Russellian monist view is a non-epiphenomenalist view that we have seen is compatible with the conceivability of zombies in the relevant sense. Finally, even Cartesian interactionist dualism, in which consciousness certainly plays a causal role, is compatible with the conceivability, and possibility, of zombies. On such a view, physically identical beings without consciousness will presumably have large causal gaps in their functioning, or else will have some new element to fill those gaps, but there is nothing obviously inconceivable about such causal gaps. For more on this, see Chalmers 2004b. 5. The judgments of zombies. It is an admittedly strange feature of zombies that they appear to make claims about consciousness that are indistinguishable from the claims of conscious beings, and that they even make parallel judgments, if judgments are functionally understood. In the conscious mind, I called this the paradox of phenomenal judgment, and argued that, while it is strange, many strange things happen in other possible worlds, it does nothing to undermine the coherence of zombies. Thomas, 1998, argues that we have to choose between saying that zombies' claims are true, meaningless, insincere, or mistaken, and that each of these options is untenable. Others, Kirk 1999, Lynch 2006, have argued that the coherence of zombies undermines our knowledge of consciousness, since we will then be unable to distinguish ourselves from zombies. In Chapter 9, I argue that an appropriate account of the content and epistemology of our phenomenal judgments shows that there is no problem here. 6. Zombies are not positively conceivable. Some, example Ashwell 2003, Marcus 2004, have argued that while zombies may be negatively conceivable, they are not positively conceivable. To positively conceive another creature, one must conceive of some combination of physical processes and conscious states. But conceiving of physical processes clearly does not suffice to conceive of a zombie, since conscious beings may have the same processes, and in conceiving of a zombie it is out of the question to conceive of conscious states. So we can form no positive conception of a zombie. In response, I think it is clear that when we conceive of zombies, we conceive of the absence of consciousness. There is no more problem with clearly and distinctly imagining a situation in which there is no consciousness than in imagining a world in which there are no angels, or in imagining a world with one particle and nothing else. The argument here appears to require that absences are never positively conceivable, or at least that to positively conceive an absence always requires conceiving something else in its place. But these cases suggest that such a claim is clearly false. The claim may turn on misinterpreting the notion of positive conceivability. Presumably there is a sense in which conceiving of an absence is negative conceiving, but this is not the sense that is relevant here. A general point about the preceding arguments: many of these arguments, especially 4-6, turn on considerations that are specific to the conceivability of zombies and do not apply to the conceivability of inverts and the like. One should keep in mind that for the anti-materialist argument, one does not need to consider beings as remote from us as zombies, or even as remote as full-scale inverts. It suffices if we can conceive of a being whose conscious experience is for just a moment slightly different from that of an actual physical duplicate. Perhaps they experience a slightly different shade at a point in the background of their visual field. Any problems that are specific to zombies then will not apply. 5 hard to classify objections. Here I consider 3 objections to the argument that are not straightforwardly classifiable as objections to premise 1 or premise 2. 1. The conditional concepts objection. David Bratton Mitchell, 2003, John Hawthorne, 2002a, and Robert Stallnaker, 2002, have independently presented versions of the following intriguing objection. The conceivability of zombies is compatible with materialism if the concept of consciousness has a certain conditional structure. Suppose that consciousness functions as follows. If dualism is true in the actual world, that is, if a relevant sort of non-physical property is instantiated, then consciousness picks out a non-physical property, and if physicalism is true in the actual world, that is, if no relevant non-physical property is instantiated but a relevant sort of physical property is instantiated, then consciousness picks out a physical property. Then if dualism is actually true, we should accept that zombies are possible, and it is at least conceivable that dualism is actually true in that we cannot rule out the truth of dualism a priori. It follows that it is conceivable that zombies are possible. But this conceivability is entirely compatible with the claim that dualism is actually false, so that in fact zombies are impossible. In response, let us say that S is metaconceivable when it is conceivable that S is possible. Then this objection shows that the metaconceivability of zombies may be compatible with materialism. But the relevant premise of the conceivability argument was not that zombies are metaconceivable but that zombies are conceivable. That is, the premise, at least in the negative conceivability version, asserts that we cannot rule out a priori that P and Q obtains in the actual world, not that we cannot rule out a priori that P and Q obtains in some possible world. There are good reasons to accept this premise, and the preceding considerations do nothing to undermine them. So these considerations do not threaten the argument. Hawthorne and Stalnaker do not discuss the claim that zombies are conceivable, as I am understanding that claim here, and they say nothing to undermine either that claim or the claim that conceivability in this sense entails possibility, so their discussion leaves all the premises in the argument I have discussed intact. Braden Mitchell, by contrast, makes it clear that he accepts premise 2 but denies premise 1. He says that the apparent conceivability of zombies is just a shadow of their metaconceivability. That is, we are apt to conflate the claim that zombies are conceivable with the claim that they are metaconceivable, and we mistakenly take the good reasons for the latter to be reasons for the former. He does not say anything to argue directly that zombies are inconceivable, however. On the face of it, even once we distinguish the two notions, the grounds for saying that zombies are conceivable, example that there is no a priori contradiction in the idea, are as strong as ever. These proponents could suggest that the conditional account predicts that zombies are inconceivable and that it has independent support. At least on Braden Mitchell's version of the account, Hawthorne and Stalnaker are not explicit about this. It is an a priori conceptual truth that if T is the case, then Q is the case, as he takes the conditional account to be an a priori conceptual analysis of phenomenal concepts. Braden Mitchell supports this claim by arguing that if an oracle told us that the world is purely physical, we would respond by accepting physicalism about phenomenal consciousness rather than denying that it exists. Hawthorne makes a similar observation. In response, I think that although the observation about our reaction to oracles is correct, it gives no support to the conditional concepts analysis. As Alter, 2006, has noted, the observation is grounded in the fact that we are more certain that we are conscious than we are of any philosophical thesis about consciousness. Furthermore, our certainty that we are conscious is plausibly a posteriori knowledge, justified by experience. If so, then, as Alter argues, our inference from PT to Q in the oracle situation is partly grounded in this a posteriori knowledge rather than being a priori. So the oracle observation does not support the thesis that it is a priori that if PT is the case, Q is the case. Furthermore, that thesis is undermined by both the zombie intuition itself and the knowledge argument intuition that someone who knows PT would not thereby be in a position to know, through a priori reflection, what it is like to see red. So we have good reason to reject the conditional analysis of phenomenal concepts. 2. The zombie parity objection. Balog, 1999, has suggested that there must be something wrong with the conceivability argument on the grounds that if zombies are possible, zombies could make a parallel argument to the conclusion that materialism is false in their world. This conclusion would be incorrect, as materialism is true in their world. So something must be wrong with the zombies argument. As the argument is valid, it must have a false premise. Balog argues that if the premises of the original argument are true, then the premises of the zombies argument are true. It follows that one of the premises of the original argument is false. Balog locates the problem in the equivalent of premise 2, the inference from conceivability to possibility, but this specific claim is not needed to undermine the original argument. In response, I think it is not correct that if the premises of the original argument are true, the premises of the zombies arguments are true. A tacit premise of the original argument is Q itself, stating, for example, that someone is phenomenally conscious. As discussed earlier, either this could be built in as an explicit premise, or it can function as part of the support for premise 4. The corresponding premise of the zombies argument will be the claim someone is phenomenally conscious. I think that this claim is false. For example, in a debate between zombie realists and zombie eliminativists, the zombie eliminativists, who say no one is phenomenally conscious, are correct. For support for this claim, based in an analysis of phenomenal concepts, see Chapter 9. If this is right, then the zombies argument has a false premise where the original argument has a true premise, and the failure of the zombies argument does nothing to undermine the original argument. 3. The index-cycle objection. A fairly common move in response to the conceivability argument, see, example Ismail 1999, Perry 2001, is to suggest that it is undermined by an analogy with index cycles. Even if I have complete objective knowledge of the world, I may lack index cycle knowledge, such as the knowledge that it is now 8 p.m. So it is conceivable that all of those objective truths obtain and that it is not now 8 p.m. However, it does not follow that the fact that it is now 8 p.m. is some ontologically further fact about the world and that materialism is false. Likewise, it does not follow from the conceivability of zombies that materialism is false. One might take this to be an objection to premise 2, the inference from conceivability to possibility. But in fact the point is compatible with premise 2. Premise 2 says that if P and Q is conceivable, it is 1 possible. The analog version for time says that if P and N is conceivable, where N is it is now 8 p.m., then P and N is 1 possible. However, P and N is 1 possible in that there is a centered world verifying P and N, a world physically identical to our world, with the center placed somewhere else. In terms of the current argument, the objection is rather that from the fact that there is a centered world verifying P and N, it does not follow that there is an uncentered world satisfying P and N, or satisfying anything in the vicinity, and such an uncentered world is what is needed for materialism to be false. By analogy, something similar goes for P and Q. So if we accept the analogy, we should deny premise 3. In my main argument for premise 3, I assume the thesis that Q has the same primary and secondary intention. If that thesis is correct, the index-cycle objection does not apply as centering is irrelevant to the intentions of such sentences. If there is a centered world verifying P and Q, then the corresponding uncentered world will also satisfy Q, and any difference between the primary and secondary intentions of P will lead at worst to Russellian monism. However, a proponent of the index-cycle objection may hold that phenomenal concepts are themselves index-cycle concepts, which have distinct primary and secondary intentions. For example, the primary intention of I picks out the individual at the center of a centered world, while the secondary intention of I picks out the same individual in all worlds. If so, then Q will have distinct primary-secondary intentions. When I considered this possibility earlier, I noted that the argument still goes through but that there is a small loophole in the argument due to centering. In effect, the proponent of the index-cycle objection is exploiting this loophole in order to resist the argument. To make considerations about index-cycle concepts maximally explicit, one can modify the formal argument. The modified argument invokes the sentence PTI, a conjunction of P, T, and I. Here P and T are understood as before, the that's all truth T is built in explicitly here for completeness, while I is a conjunction of relevant index-ical truths, such I am X, now is Y, and so on. Here, X and Y are descriptions picking out unique individuals and times. See Chapter 7 for more on this. The modified argument runs as follows. 1. PTI and Q is conceivable. 2. If PTI and Q is conceivable, then P7I and Q is 1 possible. 3. If PTI and Q is 1 possible, then PT and Q is 2 possible or Russell-Lien monism is true. 4. If PT and Q is 2 possible, materialism is false. 5. Materialism is false or Russell-Lien monism is true. Here premise 2 is an instance of the general principle discussed earlier, and premise 4 is as before. The case for the modified premise 3 is more or less the same as that for the earlier premise 3. The main difference is that this version removes the residual loophole in the case for premise 3 at the end of section 3, after we relaxed the assumption that Q has the same primary and secondary intentions. That loophole involved the suggestion that a centered world W** verifying PT and Q need not differ in any objective respect from the actual centered world W, since it might differ only in the location of the center. That loophole is now removed. If both W and W** verify PTI, then they cannot differ only in the location of the center because I specifies that location. 2. So W and W** will differ in objective respects despite both verifying PT, and the rest of the argument will go through as before. As for the modified premise 1, this premise follows from the observation that adding index-ical information does not close the epistemic gap between PT and Q. For example, I can coherently conceive that PT is the case, that I am X, that now is Y, and that someone else is a zombie. Note that this is a disanalogy with index-ical cases. PTI and N is not conceivable where N is a claim about what time it is now. Likewise, if we give Mary in her black and white room the same sort of index-ical information, she will still not be in a position to know what it is like to see red. The epistemic gaps are just as wide as they were before. So the modified premise 1 is as plausible as the earlier version. At this point, an opponent may suggest that phenomenal concepts are primitive index-ical concepts that are quite independent of other index-ical concepts such as I and now. For example, phenomenal concepts might involve a primitive phenomenal index-ical E, which picks out a phenomenal state of the experiencer in a way analogous to that in which I and now pick out the speaker and the time. If so, then the full index-ical truth I must include claims of the sort E is such and such, where the right-hand side is an independent specification of the referent. The opponent might further suggest that this right-hand side could specify a physical or functional property. That is, the index-ical truth I might include a claim of the form E is PP, where PP picks out a physical or functional property instantiated by the subject. Hawthorne 2002 makes a suggestion along these lines. But if so, PTI and Q may well be contradictory. Say that Q is someone instantiates E. P will entail that someone instantiates PP, and in conjunction with I will entail someone instantiates E. If so, then PTI and Q is not conceivable after all. I think that this interesting suggestion founders at the first stage. There is good reason to believe that our core phenomenal concepts are not index-icals. It is plausible that there are index-ical phenomenal concepts such as E that we might gloss as this phenomenal property, picking out a phenomenal property that the subject is currently having. But as I argue in Chapter 8, these concepts are distinct from our core phenomenal concepts, such as the pure phenomenal concept of phenomenal redness. Crucially, any identity claim involving pairs of such concepts is cognitively significant. For example, the thought this phenomenal property is R, involving an index-ical concept and a phenomenal concept of phenomenal redness, is as cognitively significant as a thought such as the shape is circle, involving an index-ical and a geometric concept of circularity. If so, the phenomenal concept is distinct from the index-ical concept. One can also make a direct case against any analysis of phenomenal knowledge as index-ical or demonstrative knowledge as follows. The epistemic gaps associated with index cycles always disappear from an objective perspective. Say that I am physically omniscient but do not know whether I am in the United States or Australia, we can imagine that there are appropriate qualitative twins in both places. Then I am ignorant of the truth of I am in Australia, and discovering that I am in Australia will constitute new knowledge. However, if other people are watching from the third-person point of view and are also physically omniscient, they will have no corresponding ignorance concerning whether I am in Australia. They will know that A is in Australia and that B is in the United States, and that is that. There is no potential knowledge that they lack. From their perspective, they know everything there is to know about my situation. So my ignorance is essentially indexical and evaporates from the objective viewpoint. The same goes for indexical ignorance concerning what time it is. When I am ignorant of the truth of it is now 3 a.m., a physically omniscient historian in later years will have no corresponding ignorance about whether it was then 3 a.m. Demonstrative ignorance concerning the referent of this works in a similar way. In all of these cases, the ignorance disappears from the objective viewpoint. Objectively omniscient observers can know everything there is for them to know about my situation, and there will be no doubts left for them to settle. The epistemic gaps associated with phenomenal knowledge behave quite differently. Consider Mary in her black and white room, ignorant of what it will be like for her to see red for the first time. In this case, a physically omniscient observer may have precisely analogous ignorance, even given the observer's complete physical knowledge. That person may have no idea what it will be like for Mary to see red for the first time, so this ignorance does not evaporate from the objective viewpoint. The same goes even more strongly for knowledge of what it is like for others to see red. For any observers, regardless of their viewpoint, there will be an epistemic gap between complete physical knowledge and this sort of phenomenal knowledge. This suggests strongly that phenomenal knowledge is not a variety of indexical or demonstrative knowledge at all. Rather, it is a sort of objective knowledge of the world, not essentially tied to any viewpoint. If so, then any analysis of phenomenal concepts as indexical concepts will fail. 4. The objection from blockers. Leyenberger, 2008, argues that on a certain conception of physicalism, along with certain views about what is possible, the conceivability argument will not go through. Suppose that P is such that it suffices for consciousness in any metaphysically possible world unless that world contains blockers, cf. Hawthorne 2002a, that prevent consciousness from arising. In this circumstance, we can say that the truth of P is cateris absentibus, other things being absent, sufficient for the truth of Q for all relevant Q. Leyenberger suggests that this condition suffices for an interesting sort of physicalism, which he calls cateris absentibus physicalism. On this view, one can allow the conceivability and even the metaphysical possibility of zombies while denying the inference to the falsity of physicalism. Any world with zombies is also a world with blockers, so it is not a world that falsifies cateris absentibus physicalism. As it stands, the argument denies a version of premise 3, the claim that if P and Q is possible, then physicalism is false. Now, strictly speaking, the argument I have given requires only the weaker premise that if P, T and Q is possible, physicalism is false, where T is a that's all clause saying that our world is a minimal world in which P is true. But Leyenberger will also deny this premise. On his view, our world and the zombie world are both minimal worlds in which P is true, one contains consciousness, the other contains blockers, neither contains both, so that P, T and Q is true in the zombie world, so once again he will deny the relevant version of premise 3. I could respond by denying that cateris absentibus is strong enough to count as physicalism, or in any case by saying that the argument here still establishes the falsity of physicalism in the sense that I am concerned with. But one can also respond to the argument for cateris absentibus physicalism in its own right. I think it is clear that when we conceive of the zombie world, we do not conceive of a world with blockers. We conceive of a world with physics and nothing else, no blockers, no consciousness. That is, it is conceivable that P and Q and B, where B is there are blockers. Leyenberger must deny that such a world is metaphysically possible. So it appears that Leyenberger must deny instances of the relevant conceivability possibility principle, sending us back to the key issues concerning premise 2. Leyenberger responds to an objection like this by denying that P and Q and B is positively conceivable on the grounds that blockers are too unfamiliar for their absence to be positively conceivable. One can respond to this denial by extending my response to objection 6 in the previous section. Absences are positively conceivable, and absences of unfamiliar entities, aliens, ghosts, blockers, are not different in principle. Leyenberger does not give a reason to believe that if we were familiar with blockers, the situation would be any different. Furthermore, even if Leyenberger were right about this, it seems obvious that P and Q and B is negatively conceivable. Leyenberger does not deny this claim but says only that he thinks the argument from negative conceivability is less threatening to physicalism. So one can respond to this objection by defending the entailment from negative conceivability to possibility, as I do in the next section. 5. Objections to two-dimensional semantics. One general sort of resistance to the two-dimensional argument comes from resistance to the two-dimensional framework as I have set it out. If one does not think that the notion of a primary intention is coherent, then most of the premises of the argument will not even be meaningful, let alone true. This sort of objection is too broad in scope to be covered in this chapter. See the appendix for some replies to objections. Here I just note that much prominent resistance to two-dimensional semantics is really resistance to the claims that the intentions it postulates are the semantic content of utterances, or that they are what is said, or that they are what is ascribed in propositional attitude ascriptions or some such similar thesis. It is worth noting that the arguments in this chapter need no such thesis. All they need is that sentences or utterances can be associated with primary intentions in the way I describe. Nothing turns on whether this association yields a sort of semantic content, can be used for attitude ascriptions, and so on. All that matters is that the relation of verification between worlds and utterances is well defined and that it makes the premises true. For example, a critical work by Beeler, 2002, focuses all of its arguments on the semantic theses and gives no argument against the claim that statements can be associated with primary intentions or against the claim that they satisfy the CP theses. Something similar applies to a book on two-dimensionalism by Soames, 2004, which is mostly devoted to arguing against certain two-dimensional analyses of attitude ascriptions and spends very little time arguing against the underlying association of statements with primary intentions. Setting arguments of this sort aside, the majority of other arguments against two-dimensionalism are really arguments against specific theses such as the associated conceivability possibility premise and are addressed in the following sections. So henceforth, I assume the coherence of the framework and defend the specific theses. 6 objections to premise 2. Finally, we come to the crucial premise 2. It is this premise that bridges the epistemic and modal domains, and it is this premise and associated principles that have attracted the most in-depth philosophical discussion. Premise 2 says that if P and Q is conceivable, P and Q is one possible. This premise can be seen as an instance of the general conceivability possibility thesis CP. CP, if S is conceivable, S is one possible. Here, conceivability should be understood as ideal primary conceivability of either the negative or positive variety. I always take ideal primary as understood from here on. The two versions of the thesis that result are equivalent to theses CP and CP+, discussed earlier. Thesis CP is equivalent to the claim that if S is not a priori, S is one possible. The positive version, CP+, holding that if S is positively conceivable, S is one possible, is somewhat weaker than the negative version because positive conceivability entails negative conceivability, but the reverse is not obviously the case. Much of my discussion applies equally to both CP+ or CP-, so I often just speak of CP except where the distinction is relevant. The case for premise 2 largely derives from the case for CP, and from here on I mostly focus on the general principle rather than the specific premise. Of course, If it turns out that the general principle needs to be restricted to a certain class of sentences to be plausible, then the question will arise as to whether P and Q falls into that class. Why believe CP? In the first instance, the thesis is plausible because there are no clear counterexamples to it. Principles linking conceivability and possibility have been widely accepted in the history of philosophy but have more recently been questioned because of various counterexamples, such as the Goldbach case. Both Goldbach's conjecture and its negation are conceivable, but only one is possible, and especially the Kripke cases, Hesperus is not phosphorus is conceivable but not possible. CP accommodates these examples straightforwardly, with the idealization accommodating Goldbach cases, and the primary/secondary distinction accommodating Kripke cases. If it handles these cases, then the central sources of resistance to conceivability possibility principles is undermined. But of course, there may be other possible sources of resistance. 7 Strong necessities. Before proceeding, it is useful to clarify CP by making clear what a counterexample to it would involve. According to the two-dimensional analysis, ordinary Kripke a posteriori necessities such as water is H2O and Hesperus is phosphorus have a necessary secondary intension but a contingent primary intention. That is, such statements are two necessary but one contingent. There are centered possible worlds, a twin Earth world or a world with distinct morning and evening stars, that verify their negations. When S is an a posteriori necessity of this sort, with a contingent primary intention, we might say that S is a weak a posteriori necessity. By contrast, we can say that an a posteriori necessity is a strong a posteriori necessity or just a strong necessity if S has a necessary primary intention. Strong necessities are a posteriori necessities that are verified by all centered metaphysically possible worlds. It is not easy to give examples of strong necessities, because all of Kripke's a posteriori necessities appear to be weak necessities. But I discuss some putative candidates in what follows. It is easy to see that CP is equivalent to the thesis that there are no strong necessities. If S is negatively conceivable but not one possible, then S will be a strong necessity. If S is a strong necessity, then S will be negatively conceivable but not one possible. Insofar as CP plus is potentially weaker than CP-, the relationship between CP plus and the thesis that there are no strong necessities is not as clear. Certainly any counterexample to CP plus will yield a strong necessity, but the reverse is not obviously the case. To handle this, we might define two classes of strong necessities, according to whether they provide counterexamples to CP plus or merely to CP-. Let us say that a negative strong necessity is a statement S such that S is 1 necessary and 2 necessary but S is negatively conceivable. The latter condition is equivalent to the requirement that S is not a priori, so negative strong necessities are equivalent to strong necessities as defined earlier. A positive strong necessity is a statement S such that S is I necessary and 2 necessary while S is positively conceivable. Then all positive strong necessities are negative strong necessities, but the reverse is not trivially the case. Then CP and CP plus are equivalent to the theses that there are no negative strong necessities and that there are no positive strong necessities, respectively. What would a strong necessity involve? To get an idea, consider a philosophical view on which it is metaphysically necessary that an omniscient being, example God, exists but on which it is not a priori that such a being exists. Then, according to this view, an omniscient being exists, or O, is an a posteriori necessity. Like all a posteriori necessities, O is too necessary, and O is negatively conceivable, and also positively conceivable if we add the plausible claim that it is positively conceivable that there is no omniscient being. If O were an ordinary a posteriori necessity, then O would be one contingent, there would be a metaphysically possible world verifying O. However, on the philosophical view in question, there is no such world. There is an omniscient being does not seem to have any difference in its primary and secondary intentions, so if a world satisfies O, it verifies O. So, given that O is too necessary, O is unnecessary. It follows that if this philosophical view is correct, then O is a strong necessity. It is at least a negative strong necessity, and given the positive conceivability claim, it is a positive strong necessity. One could put the matter by saying that there is an epistemically possible scenario verifying O but no metaphysically possible world verifying O. Here a scenario can be understood as corresponding to a maximal a priori coherent hypothesis in the way that worlds correspond to maximal, metaphysically possible hypotheses. I give a formal treatment of scenarios in Chalmers, 2004a, 2011, but here I leave the notion intuitive. One might call this sort of scenario a negative scenario since it corresponds to a maximal, negatively conceivable hypothesis. One could also define a positive scenario so that it corresponds to a maximal, positively conceivable hypothesis. The notion of scenarios is not defined in terms of metaphysical possibility, and in particular it is not assumed that scenarios correspond to metaphysically possible worlds. Nevertheless, it is plausible that there is an intimate relationship. For any a posteriori necessity S, there will be a scenario verifying S. For example, as water is H2O is not a priori, there will be a scenario verifying water is not H2O. That is, there will be some maximal a priori coherent hypothesis H, perhaps involving the assumption that the watery stuff is made of XYZ and so on, such that if we accept H, we should accept water is not H2O. For ordinary a posteriori necessities, these scenarios will correspond closely to centered, metaphysically possible worlds, so that there will be a centered world verifying S. For example, water is not H2O is verified by a centered XYZ world, where the individual at the center is and has always been surrounded by clear, drinkable XYZ in the oceans and lakes. There is little reason to doubt that such a world is metaphysically possible, and there is an intuitive sense in which it qualitatively matches the scenario that we imagine when we entertain the hypothesis that water is not XYZ. I leave the notion of correspondence or of qualitative matching between scenarios and worlds at an intuitive level here because it is not needed to play a formal role in the arguments. One might formalize it by requiring that scenarios be described in a limited vocabulary consisting of semantically neutral terms and index icons in the form D and I, where D is a semantically neutral statement, and I is a conjunction of index icon statements. Then a scenario characterized by D and I will correspond to a centered world W if D is true of W and if I is true, in the obvious sense, of the individuals at the center of W. When S is a strong necessity, by contrast, there will be a scenario verifying S, but this scenario will correspond to no metaphysically possible world. When S is a positive strong necessity, there will be a positive scenario verifying S. When S is a negative strong necessity, there will be a negative scenario verifying S. For example, given the theist view outlined earlier, there will be a negative and positive scenario verifying there is no omniscient being involving some maximally detailed hypothesis under which there is no such being. But on this view, there is no centered world that corresponds to this scenario, and there is no centered world that itself verifies there is no omniscient being. We might put this intuitively by saying that on this view, the space of centered, metaphysically possible worlds is smaller than the space of epistemically possible scenarios, at least in the relevant respect. Given this view, there are scenarios that correspond to no world. To bring this back to the mind-body case, take the paradigmatic type B materialist who holds that premise 1 is true, premise 2 is false, and materialism is true. On this view, the material conditional PDQ, which is itself the negation of P and Q, is a strong necessity. The truth of materialism implies that it is too necessary, the truth of premise 1 implies that it is a posteriori and its negation is one conceivable, but the falsity of premise 2 implies that its negation is one necessary. According to the type B materialist, there are scenarios verifying P and Q, including various specific zombie scenarios, but these scenarios correspond to no metaphysically possible world. Note that the analog of CP with scenarios instead of worlds is close to trivial. If S is conceivable in the relevant sense, there will automatically be a scenario verifying S, at least if the notions of a scenario and of verification are unproblematic. Even a type B materialist and a believer in strong necessities can accept that principle. They must simply deny that all scenarios correspond to worlds. So CP might be seen as equivalent to the thesis that, for every scenario, there is a corresponding world. In Chalmers 2004a, the core thesis of epistemic two-dimensional semantics says that S is a priori if S has a necessary one-intension. If one-intensions are defined over scenarios, then the resulting weak core thesis is independent of CP, makes no claim about metaphysical possibility, and need not be disputed by believers in strong necessities. If one-intentions are defined over centered worlds, then the resulting strong core thesis is equivalent to CP and must be disputed by believers in strong necessities. The strong core thesis can also be understood as the thesis of metaphysical plenitude, that every negatively conceivable statement is verified by some centered world. So the nexus of the debate over premise 2 might be phrased in terms of either CP, the strong core thesis, or the thesis of metaphysical plenitude. My view is that for every scenario there is a corresponding world and that there are no strong necessities. In the conscious mind I gave the following reasons for this. Strong necessities cannot be supported by analogy with other a posteriori necessities. 2. They involve a far more radical sort of a posteriori necessity than Kripke's, requiring a distinction between conceptual and metaphysical possibility at the level of worlds. 3. They lead to an ad hoc proliferation of modalities. 4. They raise deep questions of coherence. Strong necessities will be brute and inexplicable. And 6. The only motivation to posit a strong necessity in the mind-body case is the desire to save materialism. I still accept most of these reasons, but there is more to say. In the last decade or so, numerous objections to CP have been proposed. These objections fall into a number of classes. The first, and largest, involves attempts at exhibiting clear cases of strong necessities. The second involves attempts at explaining how there might be strong necessities in the phenomenal case, if not elsewhere, by analyzing the nature of phenomenal concepts. The third involves general philosophical objections. I will consider these three classes in turn. 8. Are there strong necessities? Examples. We can start with 14 putative counterexamples to CP. The first 5 involve a posteriori identities. The next 4 are tied to issues about the a priori and a priori entailment and involve potential challenges to CP-. The last 5, suggested especially by Yablo, 1999, 2002, involve challenges to CP and CP+. 1. Kripke cases. It is occasionally proposed that some Kripkean a posteriori necessities are in fact strong necessities. In particular, it is sometimes proposed that coextensive names such as Cicero and Tully may have the same primary intention, as well as the same secondary intention. If so, Cicero is Tully is a strong necessity, as it is clearly a posteriori. In response, when we entertain the hypothesis that Cicero is not Tully, this hypothesis corresponds to specific scenarios that we can elaborate. In particular, the relevant scenarios may involve the hypothesis that the causal chains associated with the names Cicero and Tully pick out different historical individuals. A scenario like this certainly corresponds to a centered, metaphysically possible world. There are certainly worlds where the causal chains associated with these words function as described. And it seems clear that if we discovered that our world were such a world, we would reject the hypothesis that Cicero is Tully. So such a world seems to verify Cicero is not Tully, although it may not satisfy Cicero is not Tully. Worlds like this can be found for any Kripkean a posteriori necessity S, as Kripke himself pointed out, in effect, and such worlds will always verify S. One might resist the claim that the world in question verifies S by rejecting the claim that there is an a priori entailment, for the speaker in question, from a description of the world in question to S. In response, I think that the sort of considerations in Chapter 7 strongly suggest that these entailments are a priori at least in principle. Even if one rejects this claim, however, there clearly remains some distinctive epistemic relation between the world in question and Cicero is not Tully. In particular, it remains the case that if one accepts, hypothetically, that the actual world is qualitatively just like the world in question and reflects on this hypothesis, then one will accept the claim that Cicero is not Tully. Note that this is quite unlike the situation that the theist thinks obtains in the God case, where there is no world that stands in this inferential relation to there is no God. So if one rejects a priori entailments, one can use this sort of inferential relation to define primary intentions, and ordinary Kripken necessities will always have a primary intention that is false at some world. 2. Essential modes of presentation. Bloch, 2006a, and Ty, 1997, have suggested that one might get counterexamples to CP via identities in which each expression picks out an identity via an essential property. For example, let Q be a quantum mechanical description that happens to pick out H2O. Then Q equals H2O is a posteriori, since the quantum mechanical and chemical descriptions are not conceptually connected, but each picks out the referent via an essential property, which corresponds to the primary intention, so Q equals H2O will be 2 necessary. Kalistrup, 2006, also argues that a posteriori microphysical identities such as Q equals H2O will be strong necessities on the grounds that microphysical terms have identical primary and secondary intentions. In response, it is arguable that microphysical and chemical expressions pick out their referents by contingent properties for reasons described earlier. Further, an entity can have more than one essential property, so that if a substance is picked out by distinct essential properties, the corresponding primary intentions will differ, and the sentence will not be one necessary. Finally, it is pretty clear that the scenario one has in mind when one conceives of the falsity of Q equals H2O, say, a world where something with the structure of Q yields quite different chemical level properties due to different quantum mechanical laws, will itself correspond to a possible world W that verifies Q is not H2O. So, unless one gives independent reason to think that there is no such world W, perhaps because one holds the strong view of the necessity of laws of nature, discussed later under objection 12, there is little reason to deny the natural view that Q and H2O have distinct primary intentions. If so, there is no counterexample here. 3. Distinct homophonous expressions. Bloch, 2006a, has suggested a case analogous to the Cicero equals Tully case, except that the same orthographic expression is used on each side. For example, perhaps one has acquired the term chat on 2 separate occasions for what one takes to be 2 separate species. As it happens, the 2 expressions chat pick out the same referent, so that chat equals chat is necessary. Over time, one loses any associated information while still recognizing that these are distinct expressions. Then chat equals chat is not a priori. But according to Bloch, both sides will have the same primary intention. At least, the preceding explanation, suggesting a primary intention along the lines of the thing causally connected to my use of chat, suggests that the 2 intentions are the same and the sentence is unnecessary. In response, even here, there will be a centered world corresponding to the scenario one has in mind when one entertains the falsity of the hypothesis one expresses with chat equals chat. Such a centered world involves distinct causal chains from each of the 2 uses of chat to distinct entities. Here the 2 uses can at least be distinguished indexically, with a primary intention along the lines of the thing causally connected to this use of chat. If necessary, these indexicals can be grounded in direct indexical reference to token mental states, as with the case of demonstratives discussed below. 4. Demonstratives. Schiffer, 2003, suggests an objection that turns on identities involving perceptual demonstratives, such as that equals that. In most such cases, there is no problem, the conceivable falsity of such a claim corresponds to a scenario in which the item causing a certain sort of experience in one differs from the item causing a different sort of experience, and this scenario will correspond to a centered world such that if one discovered this world to be actual, then one would reject that equals that. But there are cases in which the relevant experiences are indistinguishable, such as Austin's two tubes case, 1990, in which one simply sees two red dots in a symmetrical visual field, or a case where one sees many dots and has no way to pick out any one of them by description. Then the preceding model involving different sorts of experience will not apply. In response, again one will have to invoke index cycles here so that the primary intention of each that will be roughly equivalent to that of the cause of this experience for different phenomenal index cycles this. In this case, the phenomenal index cycle must be considered a primitive index cycle akin to I and now. Formally, evaluating the primary intention of such an index cycle requires a centered world where the center includes not just a subject and a time but also certain marked experience tokens to which the distinct phenomenal index cycles are linked. Then that equals that will be false at centered worlds where the two relevant experience tokens marked at the center are caused by different objects. For more on this, see Chapter 8. 5. Dancing qualia. Hawthorne, 2006, suggests a case involving phenomenal concepts based on the dancing qualia case in the conscious mind. Say that Fred starts with identical red experiences in the left and right half of his visual field, forms concepts Ri and R2, pure phenomenal concepts in the language of Chapter 8, of the relevant phenomenal property, phenomenal redness, and judges Ri equals R2. After this the experiences in the right half of his visual field dance between red and blue every minute, while they continue to play the same functional role. In the conscious mind I argue that this is naturally impossible but allow that it is logically possible. Fred has been told that this may happen, but when a change happens he is unable to notice it. After 4 minutes his right field experience is back to red, and he once again entertains the thought R equals R2. According to Hawthorne, he is unable to know Ri equals R2 by any amount of a priori reasoning, so Ri is not R2 is at least negatively conceivable. But both Ri and R2 have the same primary intention, so Ri equals R2 is one necessary. If so, this is a counterexample to CP-. In response, this case should be treated analogously to a case in which Fred's cognitive processes are tampered with so that he first judges 7 plus 5 equals 12, with normal processes, then 7 plus 5 equals 14 with abnormal cognition, then back again. If Fred knows this is happening, then when he entertains 7 plus 5 equals 12, he will be unable to know that truth through any amount of a priori reasoning. Nevertheless, his thought is still a priori. This is simply a situation in which tampering with cognitive processes renders him less than ideal, so that he is unable to know all a priori knowable truths. Or, in a closely related version, it is a situation where misleading empirical evidence undercuts his ability to know these truths. The dancing qualia case should be treated the same way. 6. Ordinary macroscopic truths. Another class of examples comes from the suggestion that consciousness is not alone in its failure to be a priori entailed by microphysical truths. Bloch and Stallnaker, I-999, have suggested that many ordinary macroscopic truths such as water boils at 100 degrees, or W, are not a priori entailed in this way. If so, then P and W is at least negatively conceivable. But P and W is not too possible, at least if water and its properties supervene on the microphysical, and it is not clearly one possible, either. If it is not, then P and W is a counterexample to CP-. In response, Chapter 7 makes the case that these macroscopic truths are a priori entailed by P or at least by PQTI, the conjunction of P with Q, all phenomenal truths, T, that's all truth, and I, index cycle truths. Now, P and Q, P and T, and P and I may be negatively conceivable, but the latter two are clearly also one possible, so they do not yield strong necessities, and the I possibility of P and Q is precisely the current topic of dispute. So any failures of a priori entailment by P associated with the failure of entailment of Q, T, or I give no independent support to the existence of strong necessities. Such support would require at least a truth M such that PQTI does not a priori entail MAND such that P did miss 2 necessary and I necessary. The arguments in the next chapter suggest that no ordinary macroscopic truths M are like this. In any case, even if one rejects the a priori entailment thesis here, these cases will yield at best exceptions to CP, i.e., negative strong necessities, not exceptions to CP+, i.e., positive strong necessities. Even if W is like Q in that P and W and even PQTI and W is negatively conceivable, PQTI and W is not positively conceivable. Water zombies are not positively conceivable in the way that zombies are positively conceivable. So this sort of case leaves CP+ unthreatened. 7. Unknowable mathematical truths. Perhaps the most challenging cases for CP are mathematical truths M such that M is true, and therefore necessarily true and I necessarily true, but not knowable, and so not knowable a priori. If there are such cases, M is a negative strong necessity, though not a positive strong necessity, as M is not positively conceivable. Here one might appeal to unprovable true mathematical sentences, such as those whose existence is entailed by Gödel's theorem. In response, unprovability in a given system does not entail known a priori. For example, the consistency of Peano arithmetic is not provable in Peano arithmetic but is still plausibly knowable a priori. One can make the case, see Chalmers 2002b, that all true statements of arithmetic are knowable a priori at least under an idealization, i.e., our failure to know them a priori is due to certain limitations of our cognitive systems. One might worry about sentences of higher set theory, such as the continuum hypothesis, but here it is far from clear that such sentences are determinately true or false, and it is also far from clear that they are not knowable a priori under an idealization. So although these cases provide an interesting challenge to CP-, they do not provide clear counterexamples to CP-. And as in the previous case, there is no challenge to CP+ here. 8. Inscrutable truths. A related class of potential counterexamples to CP includes special sorts of true sentences M such that, according to certain philosophical views, M is not a priori entailed by any underlying qualitative truths but such that it is necessitated by such truths. In Chalmers, 2002b, I call these inscrutable truths. Such sentences might include vague sentences such as John is bald under some versions of the epistemic theory of vagueness, according to which such sentences can be true but unknowable even in principle on the basis of underlying qualitative information. Others might include certain moral or metaphysical truths, on views according to which there are true such sentences with no a priori link to underlying qualitative truths. In response, in Chalmers, 2002b, I argue that there are no compelling counterexamples here, as the philosophical views in question should all be rejected. In any case, these cases do not typically go along with the positive conceivability of P-M, so they at best challenge CP-, not CP+. 9. The deeply contingent a priori. Hawthorne, 2002a, suggests that some truths may be a priori even though they are false in some possible worlds considered as actual. For example, let EDH be a conditional from one's total evidence to a hypothesis it supports. Then there are some grounds for holding EDH to be a priori, since the inference from E to H transmits justification and arguably cannot itself be a posteriori. If this is right, then it seems to follow that E and H is ruled out a priori, so it counts as inconceivable by the earlier definition. But E and H is certainly one possible, it is verified by many worlds where the evidence E is misleading. So EDH is not I necessary. Strictly speaking, this sort of case does not challenge CP but rather challenges the associated right-to-left principle that I possibility entails I conceivability. This is still a worry for the framework, however, and addressing it helps to clarify an important issue. In response, there may be a sense in which EDH is a priori here, in that it has some justification independently of experience. But there is also a sense in which it is not, or at least in which its justification is much weaker than that of many other a priori truths. Intuitively, one cannot conclusively rule out the possibility that E and H, whereas one can conclusively rule out the hypothesis that 2 plus 2 equals 5, for example. One can get conclusive justification from proof and analysis, among other methods, but not from abduction and induction. In the uses of the a priori in the current context, it is always the conclusive a priori that is relevant. By this standard, E and C is not ruled out a priori. This allows one to accommodate the clear intuition that E and CH is not just one possible but also one conceivable. It is always conclusive a priori that is relevant to matters of conceivability. 10. Disquotational truths. Yablo, 2002, suggests that certain disquotational truths, such as sister means sister, are a priori but are not one necessary. It could turn out that sister does not mean sister in worlds where the term is used differently, and such worlds verify sister does not mean sister. In response, the treatment of this case differs depending on whether one sees sister picking out its referent orthographically, so that just a certain orthographic form is required, or semantically, so that a certain meaning is required. If sister is understood orthographically, then sister means sister is not a priori, it is substantive a posteriori knowledge that the orthographic item means anything at all. If sister is understood semantically, then sister means sister may be a priori, but it is also one necessary. Cases where the orthographic item is used with a different meaning will be irrelevant to the primary intention of sister. 11. Response-enabled concepts. Yablo, 2002, argues that certain geometric terms such as oval may pick out certain shapes according to the way they trigger certain responses rather than through a substantive independent grasp. In the actual world, the extension of oval includes Cassinis, where Cassini is defined mathematically, but Cassinis are ovals is not knowable a priori. However, Cassinis are ovals is nevertheless necessary and unnecessary. A world where Cassinis do not cause oval experiences is not a world where it would have turned out that Cassinis are not ovals, according to Yablo, so it is a strong necessity. In response, I think that the actual term oval may embody a geometric understanding so that Cassinis are ovals, or something like it, is a priori. But there might be other terms that could work in Yablo's response-enabled way, though, so I will go along with his treatment of oval as one of them. Under this assumption, we should say that Cassinis are ovals is not unnecessary. If W is a world where HS cause oval experiences, then, under this model of oval, it is a priori that if W is actual, so that HS cause oval experiences, then HS are ovals. What matters for evaluating a primary intention is the a priori connection, not the turns out claim above. 12. Laws of nature. According to some philosophical views, laws of nature are not just naturally necessary but metaphysically necessary. Shoemaker, 1999, holds such a view and suggests that it may provide a counterexample to CP. In response, on some versions of this view, laws of nature follow a version of the Kripken model. That is, if mass in the actual world obeys certain laws, then nothing in any counterfactual world counts as mass unless it obeys exactly those laws, so any law involving mass will be necessary. On one model, this pattern obtains because of the semantics of mass, and in particular because a counterfactual property must have the same gnomic role as actual mass in order to qualify as the referent of mass. On another model, the pattern obtains because of the metaphysics of mass, and in particular because properties such as mass have their gnomic profile essentially, as on Shoemaker's view. On these models, we need not deny that there are worlds that correspond to the scenario we conceive when we conceive that mass obeys different laws. It is just that such worlds will contain mass rather than mass. I think that it is implausible that the modal profile of mass and/or the essential properties of mass are this precise, See Fine 2002 and Seidel 2002 for arguments to this effect, but in any case, this model does not provide a counterexample to CP. On these models, a Schmass world may verify the hypothesis that the relevant law of nature is false, so laws of nature are not strong necessities. To yield strong necessities, this sort of view must hold not only that there are no worlds where mass obeys different laws but also that there are no related worlds where something else, Schmass, obeys those different laws. Here, the relevant sort of view is one according to which the fundamental properties and laws of all worlds are the fundamental properties and laws of our world, where these laws are not knowable a priori. In effect, this restricts the space of metaphysically possible worlds to the space of naturally possible worlds. If this view is correct, then a fundamental law will be a strong necessity. There will be no world corresponding to the scenario that we conceive when we conceive that it is false. I think there are no good reasons to accept this extremely strong view of laws of nature, and there are good reasons to reject it. The best reasons to take seriously the hypothesis that laws of nature are necessary come from the Kripke and Shoemaker models just mentioned. But nothing in these models supports the strong view or yields a strong necessity. Rather, the CP thesis can itself be taken as reason to reject the view. 13. A necessary God. I have already noted that the existence of strong necessities is entailed by theist views on which an omniscient being, or an omnipotent being or a perfect being, exists necessarily but on which the existence of such a being is not knowable a priori. If we say that a God is by definition an omniscient being, or a perfect being or whatever, then a God exists will be a strong necessity. In response, I think that theist views of this sort are to be rejected. If the existence of such a God were knowable a priori, then such a God might exist necessarily, but if it is not, then one should conclude that such a being exists at best contingently. I cannot respond to every argument for believing in a necessary God here, but they all rest on highly contentious premises, and once again, CP itself provides an argument against these views. The best way to defend the existence of a necessary God is to argue that a world without such a being is not even conceivable. Even if one believes that the existence of a God provides a strong necessity, it is not clear that this sort of strong necessity undermines the case against materialism. The debate over materialism uses necessity as a criterion of ontological distinctness. The question of whether physical truths necessitate phenomenal truths is relevant precisely insofar as it bears on the question of whether the phenomenal involves nothing ontologically over and above the physical. A variety of necessity in which the existence of a God is necessary will not be well suited to this ontological role. On such a view, the existence of a God will be necessitated by physical truths, but such a God will presumably nevertheless be ontologically non-physical. So if the only strong necessities are strong necessities of this sort, connecting ontologically distinct existences, their existence is no help to physicalism. Given that P and Q is conceivable, Q will be something over and above the physical, either because it is necessitated by the physical or because it is tied to the physical only by this sort of strong necessity. Something similar applies to views on which laws of nature are strong necessities. Even on such views, laws presumably connect ontologically distinct properties. If there is a fundamental law connecting properties A and B, this will not ground any sort of ontological reduction of one property to the other. Indeed, if this view is correct, then a dualist view with fundamental phenomenal properties and fundamental laws connecting them to the physical will itself be a view on which the phenomenal is necessitated by the physical. So again, strong necessities of this sort are no help to the physicalist. 14. Metamodal claims. Yablo, 1999, adapts the God case to provide an intriguing argument against CP. According to Yablo, it is at least conceivable that there is a necessarily existing God. It is also conceivable that there is no necessarily existing God. So, if G is it is necessary that there is an omniscient being, then both G and G are conceivable. If so, then by CP, both G and G are one possible. There appears to be no relevant distinction between the primary and secondary intentions of the expressions involved, so it follows that G and G are two possible, or, metaphysically, possible simpliciter. So it is possible that it is necessary that there is an omniscient being, and it is possible that it is not necessary that there is an omniscient being. But this is a contradiction, at least given S5 as the logic of the metaphysical modality. If it is possible that S is necessary, then S is necessary, so it is not possible that S is not necessary. In response, one might reply by denying S5 or by finding relevant two-dimensional structure, but I think these moves are unpromising. One could also respond, more promisingly, by making the observation about the ontological relevance of this sort of necessity. But I think it is best to deny that it is conceivable that there is a necessarily existing God, at least in the relevant sense of conceivability. Perhaps it is prima facie negatively conceivable that there is such a being, in that we cannot obviously rule it out a priori, but I do not think it is conceivable in any stronger sense. I can certainly form no clear and distinct conception of such a God. Like many, I was suspicious of the idea the moment I heard about it as a student, and continued rational reflection reveals all sorts of problems with the idea. Once one accepts that it is conceivable that there is no God, and this seems like a much stronger intuition, at least to me, this has a strong tendency to undermine the coherence of the hypothesis that a God exists necessarily. The problematic issues here arise because of the double modality. We are conceiving not just of non-modal qualitative features of worlds but also of what is possible or necessary within those worlds. Conceiving of a God, an omnipotent, omniscient, and omnibenevolent being, say, is arguably not too hard. But to conceive in addition that the being exists necessarily, we have to conceive that the space of possible worlds is such that this God exists in each of them, despite the conceivability of a godless world. That is, we have to conceive that CP is itself false. This is what does all the work in the example. If it is conceivable that CP is false, then, by CP, it is possible that CP is false. CP is surely necessarily true if it is true at all, so it follows from the possible falsity of CP that CP is false. Howell 2008 argues against the current framework directly in this way. One way to respond to this sort of argument is to restrict the conceivability/possibility thesis to claims about the distribution of non-modal properties within worlds, leaving double modals outside its scope. I think this response would not be entirely ad hoc. CP would then apply to worlds considered non-modally but not to cosmoses of possible worlds, but I prefer to hold on to the stronger thesis by denying that it is conceivable that CP is false. I hold that CP is a priori, although highly non-trivial, like many theses in philosophy. In fact, I sketch an a priori argument for CP later in this chapter. If this is correct, then CP is not conceivably false on ideal rational reflection, and it is not ideally conceivable that a necessarily existing God exists. 15. The conceivability of materialism. A closely related metamodal argument, Martin 1998, Sturgeon 2000, Frankish 2007, Brown 2010, Balog forthcoming, that is specific to the mind-body domain proceeds as follows. It is at least conceivable that materialism is true about consciousness. Therefore, 2, it is conceivable that PDQ is necessary. By CP, and setting aside two-dimensional structure, it follows that, 3, it is possible that PDQ is necessary. From this it follows using S5 that, 4, PDQ is necessary. Using CP and S5, one can equally infer from the fact that, v, it is conceivable that PDQ is not necessary to the conclusion that, 6, PDQ is not necessary. But, 4, and 6, are contradictory. So one should reject CP. My response here parallels the response to the previous objection. It may be prima facie negatively conceivable that materialism is true about consciousness, but this is not obviously conceivable in any stronger sense. Many people have noted that it is very hard to imagine that consciousness is a physical process. I do not think this unimaginability is so obvious that it should be used as a premise in an argument against materialism, but likewise, the imaginability claim cannot be used as a premise, either. Furthermore, if I am right that CP is a priori, then there is an a priori argument that PDQ is not necessary, so that it is not even ideally negatively conceivable that PDQ is necessary. Overall, we have seen that while there are many putative counterexamples to CP, none of these provides a clear counterexample. In most cases, there are reasonably straightforward independent grounds for rejecting the claim that the cases in question provide strong necessities. Perhaps the most serious challenges come from mathematical cases such as the continuum hypothesis and from metamodal cases. These are the cases where, in advance of commitment to CP, independent reasoning does not clearly settle the question of whether strong necessities are involved. Still, these are cases where the initial situation is unclear rather than cases where there is a clear counterexample. If one can make the case for CP independently, then these cases are not too much of a threat. It is also worth noting that cases such as these seem to work best as challenges to CP rather than to CP+, so that CP+, which is all that is required for the argument against materialism, is relatively unthreatened. We have also seen at various points along the way that even if one takes certain cases to involve strong necessities, the existence of such strong necessities will still be compatible with modified versions of CP, say, a version involving ontological necessities in the law/God cases or a version involving non-modal sentences in the metamodal cases, that will be strong enough for the anti-materialist argument to go through. So where the consideration of counterexamples is concerned, the anti-materialist argument seems to be on reasonably strong ground. 9. Are there strong necessities? 2. Explanations. In the previous section, I considered attempts on behalf of Type B materialism to establish that there are strong necessities outside the mind-body domain, and I argued that these attempts fail. Other Type B materialists adopt an alternative strategy. They accept that there are no strong necessities outside the mind-body domain but argue that there are nevertheless strong necessities inside the mind-body domain. To avoid postulating an ad hoc exception, such a view must provide an explanation of why the mind-body domain is exceptional. By far the most common way to explain such exceptions is to appeal to the special nature of phenomenal concepts, the concepts that we use to think about consciousness. Proponents argue that because of this nature, we should expect that there are strong necessities involving consciousness, ones that reflect not an ontological gap in nature but rather a merely epistemic gap in our cognitive processes. I think that this strategy is the most interesting and attractive strategy for the defense of Type B materialism. However, I do not think that the strategy can work. In Chapter 10, I argue that no such strategy can succeed in supporting Type B materialism against the arguments considered here. Here, I briefly consider two versions of the strategy and offer some different arguments, drawn from Chalmers 1999, against them. 1. Independent cognitive processes. Hill, 1997, and Hill and McLaughlin, 1999, offer a psychological explanation of why we can conceive of zombies, appealing to the cognitive processes by which we conceive of physical processes and by which we conceive of experiences. On their view, these processes involve independent faculties, and the mental representations involved have independent cognitive roles, so it is to be expected that there is no conceptual connection between them. The psychological explanation is consistent with physicalism. So the conceivability of zombies does not entail the falsity of physicalism. In response, the crucial question is whether a psychological explanation of the independence of physical and phenomenal concepts suffices to explain the existence of strong necessities. On the face of it, it seems not. After all, one can also give a psychological explanation of why we can conceive of red squares, in terms of the distinct cognitive processes involved in conceiving of color and shape. One can give a psychological explanation of why we can conceive of five-horned animals, or of silicon-based life, but no one would infer that there are strong necessities denying the metaphysical possibility of red squares or five-horned animals or silicon-based life. An explanation of a strong necessity has to do two things: it has to show us why a state of affairs should be conceivable while at the same time being impossible. To put matters differently, it should explain why conceivability is an unreliable guide to the possibility of such states of affairs. This is what Kripke, 1980, does in explaining away the intuition that heat might not have been molecular motion. He explains why and how the conceivability of the state of affairs is compatible with its impossibility. Hill, 1997, likens his strategy to Kripke's, but it discharges only half of the burden. It explains why zombies might be conceivable, but it does nothing to explain why and how this conceivability coexists with the impossibility of zombies. If we do not demand such an explanation, a strategy like Hill and McLaughlin's could be used to explain away any conceivability intuition at all. Presumably, there will always be a psychological explanation of the processes involved in a modal intuition, but one should not infer that these intuitions are always unreliable. If one did, then one might likewise find a psychological explanation of our mathematical beliefs and infer that these beliefs are no guide to mathematical truth. Hill and McLaughlin, 1999, come close to addressing this issue by saying, given these differences between sensory concepts and physical concepts, a sensory state and its nomologically correlated brain state would seem contingently connected even if they were necessarily one. However, this may well be a deeply impossible counterfactual. Given mathematical concepts, 1 plus 1 would seem to be 2 even if it were 3. What we need is an explanation of how the two states could be necessarily one. Or ascending to the level of concepts, we need an explanation of how two such distinct concepts could pick out the same property. As it stands, Hill and McLaughlin's strategy does not provide such an explanation. 2. Recognitional concepts. Lohr, 1990/1997-1999, attempts to fill this gap by explaining how physical and phenomenal concepts can be conceptually distinct but nevertheless pick out the same property, without distinct properties serving as modes of presentation. If one could do this, one would thereby explain why identities involving such concepts are strong necessities. Lohr appeals to two theses about phenomenal concepts. First, he appeals to the thesis that they are recognitional concepts, picking out their referent through a direct process of recognition. Second, he appeals to the thesis that they have the same primary and secondary intentions. Lohr puts this in his own terminology by saying that phenomenal concepts have the same property as both referent and reference fixer, but for ease of discussion I translate into my terminology. The significance of the first thesis is that a recognitional concept, that sort of cactus, may refer to the same property as a physical theoretical concept even though the two concepts are cognitively distinct. On its own, this is not enough to yield a strong necessity. Recognitional concepts and physical theoretical concepts typically have quite different primary intentions, partly because the recognitional concept picks out its referent under a contingent mode of presentation. Example: a cactus might be picked out by relying on the sort of experience it produces. So Lohr adds the second thesis, holding that phenomenal concepts are unique among recognitional concepts in having the same primary and secondary intentions. Lohr also holds that theoretical physical concepts have coinciding primary and secondary intentions, an assumption that I will go along with here for the purpose of simplifying discussion. As usual, relaxing the assumption only opens up the possibility of Russellian monism. From the first thesis, Lohr infers that phenomenal concepts may co-refer with physical concepts even though they are cognitively distinct, in such a way that zombies are conceivable. Both concepts are rigid, so they will have coinciding secondary intentions. From the second thesis, combined with the same claim about physical concepts, he infers, in effect, that the two concepts have coinciding primary intentions. So an identity involving the concepts will be one necessary despite being a posteriori and counter-conceivable. Such an identity will be a strong necessity. The problem with this is straightforward. The truth of the second thesis undercuts Lohr's inference from the first thesis. It may be true that recognitional concepts are cognitively distinct from theoretical concepts, and it may be true that they often co-refer with those concepts. However, the cases in which they do are all cases where the recognitional concepts have non-trivial two-dimensional structure, typically picking out their referent as the cause of a certain sort of experience, or by some similar contingent mode of presentation, so that they have distinct primary and secondary intentions. Furthermore, this two-dimensional structure provides a clear explanation of how and why the recognitional concept co-refers with the theoretical concept. If we remove this feature of recognitional concepts, as we do in accepting the second thesis, we no longer have any reason to believe that recognitional concepts and distinct theoretical concepts should co-refer. Lohr's two theses, if accepted, should lead one to accept that phenomenal concepts and physical concepts are, I, cognitively distinct and, 2, have the same primary and secondary intentions. But nothing here begins to justify the coreference of phenomenal and physical concepts. In fact, the situation is the opposite. In every other case of concepts satisfying, I, and, 2, they have distinct referents. One might suppose that recognitionality is doing some extra work here, thus distinguishing this case from other cases involving non-recognitional concepts, but it merely supports, I, and supports the possibility of coreference when, I, is true but, 2, is false. So nothing here supports the possibility of coreference when, I, and, 2, are both true. Rather, given the truth of, I, and, 2, one should more naturally infer that the referents of the concepts differ. Lohr suggests that his two theses are themselves neutral between physicalism and dualism and therefore can equally be conjoined with the claim that phenomenal concepts pick out physical properties as with the claim that they pick out non-physical properties. But this is far from obvious. The reasoning above suggests that Lohr's two theses support the claim that phenomenal concepts pick out non-physical properties. Perhaps Lohr could build in the further claim that phenomenal concepts pick out physical properties as part of his explanation, but then this claim will be doing all the work. Lohr's opponent will deny the possibility of this claim, so Lohr still needs an explanation of how phenomenal concepts could pick out physical properties, given the earlier situation. As things stand, the model will then require that physical properties have their phenomenal mode of presentation non-contingently. But this means that the explanation is building in a necessary connection between physical and phenomenal properties from the start and so is assuming strong necessities in order to explain strong necessities. It appears that neither Hill and McLaughlin's nor Lohr's account can explain the existence of strong psychophysical necessities. Instead, both accounts need to assume such necessities at a key point as a kind of primitive. One might think that some more refined account will avoid this problem, but I think that the problem is inevitable. For an in-depth discussion of problems that afflict all appeals to phenomenal concepts to support physicalism, see Chapter 10. 10. Modal rationalism. So far I have argued that there are no clear counterexamples to the conceivability-possibility thesis and no good explanations of how it could be false. Most Type B materialists support their view either by potential counterexamples to the conceivability-possibility thesis or by potential explanations of its falsity, so I think that this removes the central plank of support from the view. Still, one might wonder why CP has to be true. Why couldn't there be strong necessities, so that some scenarios correspond to no metaphysically possible world? The first thing one can say at this point is that in the absence of an explanation, these strong necessities will be brute and inexplicable. Epistemically, they must be taken as primitive in the same way that we take the fundamental laws of nature as primitive. We might consider them to be either fundamental laws of metaphysics or laws grounded in related fundamental laws involving properties, essences, and the like. I think that there is good reason to doubt that there are a posteriori fundamental laws of this sort. Rather, where there are a posteriori fundamental laws, these should always be taken as laws of nature and therefore as metaphysically contingent. The most fundamental reason for rejecting strong necessities comes from conceptual analysis of modal notions and an analysis of the reasons that lead us to believe in modality in the first place. This analysis is itself an extended project, but here I give the sketch of an argument. The argument involves locating the roots of our modal concepts in the rational domain. When one looks at the purposes to which modality is put, example in the first chapter of Lewis 1986, it is striking that many of these purposes are tied closely to the rational and the psychological, analyzing the contents of thoughts and the semantics of language, giving an account of counterfactual thought, and analyzing rational inference. It can be argued that for a concept of possibility and necessity to be truly useful in analyzing these domains, it must be a rational modal concept that is tied constitutively to consistency, rational inference, or conceivability. It is not difficult to argue that even if not all conceivable worlds are metaphysically possible worlds, we need a modal concept tied to rational consistency, a priority, or conceivability to best analyze the phenomena in question. We might call this modality the logical modality. We can say that S is logically necessary when S is a priori, and we can define corresponding notions of possibility and entailment. Note that, as defined here, the logical modality has no special connection to formal logic. The terminology is imperfect, but alternatives such as epistemic and conceptual modality also have obvious imperfections. We can then argue that a space of logically possible worlds will be vital for many of the explanatory needs for which possible worlds are needed in the first place. To see this, let us pretend for a moment that all worlds with laws of nature that differ from ours are metaphysically impossible. Even so, it will still be tremendously useful to appeal to a wider space of logically possible worlds, or world-like entities, with different laws to help analyze and explain the hypotheses and inferences of a scientist investigating the laws of nature. Such a scientist will be considering all sorts of rationally coherent possibilities involving different laws. She will make conditional claims and engage in counterfactual thinking about these possibilities, and she may have terms and concepts that are coextensive at all worlds with our laws but that intuitively differ in meaning because they come apart at worlds with different laws. To analyze these phenomena, the wider space of worlds is needed to play the role that possible worlds usually play. Something similar applies to zombie worlds. Even on a type B materialist view, we can think counterfactually, and rationally, about the possibility of a different distribution of phenomenal properties with the same physical properties. We need worlds that correspond to these possibilities to make sense of counterfactual thought, of the semantics of counteractual utterances, of rational inferences involving consciousness, of the contents of rational beliefs about consciousness, and so on. We can write coherent science fiction about zombies and speak coherently about the truth in such fictions. Talk of logically possible zombie worlds is justified in the usual way by their role in these uses. Further, there is no bar to a space of such worlds. If one does not want simply to postulate them, one can easily construct them in an ersatz way, perhaps by using equivalence classes of sets of semantically neutral sentences. If one has qualms about using the term world for these entities, nothing turns on the word, one can call them scenarios or something similar instead. One can then introduce means of semantically evaluating expressions at these worlds, by considering these worlds as actual, considering what to infer from the hypothesis that the world actually obtains, or as counterfactual, considering what would have been the case had the world obtained. There are a few complications. One may want to add centers to the worlds for consideration as actual, and one may want to allow hypostatic differences between worlds for consideration as counterfactual, depending on one's philosophical views. But this sort of construction is reasonably straightforward. A related construction is given in Chalmers 2011. The two sorts of evaluation with respect to these worlds correspond to two sorts of necessity of sentences. We might say that S is epistemically necessary if it is true at all logically possible worlds considered as actual, and that S is subjunctively necessary if it is true at all logically possible worlds considered as counterfactual.